and they're scary. I mean, we're taking some risks in that. And I think something I didn't fully appreciate until I got here is, talking to some veterans and talking to people that really know, EVA is maybe a third one, where we're doing some risky stuff. Obviously, we're doing it as safely as we can, but I'm curious, do you think of it that way, similar to launch and landing? And are you nervous going out the door like you might be anticipating a launch?
Well, I think everyone is a little kind of, your nerves are on edge on your first one. As you do a few more, first of the 4 that Bob and I did, which was the first one for me for 7 years and the last one since Luca and I went out and all that water in the helmet problem happened, it was just another morning as I was going through the morning, and we got into the deep press and the hatches closed and we start moving air out of the crew lock, and it got to the low pressures where I knew my next actions were opening the hatch, and I felt my heart race a little bit. And I was thinking to myself, what are you doing, man? Settle down. And I opened the hatch and out I went, and I remember feeling a little like I wanted to go fast, and I even thought to myself, they're going to call on the radio and say to slow down.
Because they're watching all your data.
Because they're watching all your heart rate data and everything. And they did do that. But it only lasted a minute or two. But it surprised me that I had that kind of first time feeling a little bit on this one. And then it was just so awesome to be out there with Bob, somebody who was so capable and talented. And I think we fell into a rhythm pretty fast. And that was very settling. Bob and I have never done even an NBL run together. The first time we've ever done any spacewalk activity was on a real EVA, but it didn't feel like that. It just kind of clicked. Your questions about the risk of it, you definitely, you get a sense for it when you're outside. And what I think most is now we're at a phase where I can only help Bob and Bob can only help me. You as Capcom can't, flight director can't. They can provide good ideas and direction. But at the end of the day, the two people out there are for each other.
You're a busy man, and I don't want to take too much of your time, so it's a true honor to get to talk to you so soon after you landed.
Yeah, this is awesome.
Really fun to see you.
I can't wait till I'm sitting there talking to you about your first space flight. That'll be super cool.
Thanks, Chris.
Yeah, awesome.
Chris, welcome back.
Oh, man. Great to see you, man.
I can't believe it was less than a week ago you were in space.
I can't either. It all happens so fast. It's so cool. And next thing you know, you're seeing your friends, and a week ago you were in space.
Take me through a little bit of the rehab so far. Like, how do you feel right now, less than a week out?
I feel really good. I think that our bodies are like amazing, because getting there to space, I had almost zero adaptation opening the hatch and floating in. My body just knew how to do it. And I feel like it was better coming back this time than last time as well. I mean, really little dizziness or anything like that. And so rehab has been, at the gym, and we're focusing on balance and changing direction and that sort of thing. But it hasn't been vomit-inducing or anything like that. It's been not so bad.
I saw the photos of you smiling right after landing. It looks like you were just right at home.
I was smiling because I finally got to stretch my knees out. I'm like, oh, thank God, my knees.
You talked about adapting. We obviously see videos of you down here in Mission Control, and you just look like you're completely comfortable. You're really good at moving in zero-G in weightlessness. Does it take 3 missions to get that way?
It doesn't take 3 missions, but it takes a good chunk of a couple weeks or a month, maybe longer. Everybody's different. But for instance, what I really enjoyed was we got to space. Anatoly had been there multiple times. I'd been there a couple times, but Ivan hadn't. And watching him gangle his way through the hatch, and the first couple days kind of move around with extreme uncertainty, and even inside looking for the next place to put his hand, and then slowly watching his comfort level. And man, towards halfway through and the rest of the mission, he was just zipping around just like he'd been there a million years. So again, your bodies and your brains just sort of adapt to it. And the other thing is, you get used to not needing your hands to do stuff, and your feet just start instinctively grabbing handrails, but your feet just find it. And in fact, there was a few times where I needed to move a handrail for some science reason, or payload had to go there, and my foot would naturally swoop in that location, and there would be no handrail there. And I realized, well, that's pretty crazy. Like without even thinking, my foot knew that that's where the handrail should be to grab, but it wasn't there.
Being your third mission, did it come back, a minute in, an hour in?
Minutes, yeah, like really fast. And when I was a shuttle guy, I came to the space station, but my analogy is like a vacation rental. Like you're enjoying the house, you're enjoying the facilities, but you don't care how the VCR and cable wiring is. You don't care how the sprinkler system works. You don't care the nuance on the thermostat. Everything should work. And if it doesn't, you call the landlord and say, fix this thing. That's like a shuttle visiting person for just 2 weeks. But my last mission, and again this one, now it's not a vacation rental, it's your house. And you care about how the wiring on the TV system is. You care about the sprinkler system not going on time, and you care about trash day and all those things, and it's your home. And you have like this real ownership of it. And I remember thinking how cool that was last time when I got to that point. And this time it was right away, because I only overlapped with Drew and Jessica for a week, maybe 9 days. And then I was on my own, but it was no big deal because I'd already had that feeling of ownership. And the space station had changed, but it really hadn't changed a ton, so I felt really quite at home. Yeah, it was a neat feeling.
After viewing Earth in orbit, do you feel like it has fostered a greater sense of sensitivity towards the well-being of our planet and the planet's environment for you?
Oh my gosh, yeah. I mean, when you look at that planet, like I said, from the first time I saw it out the windows of the shuttle till, looking out the cupola or going out for a spacewalk, I mean, you just can't help but thinking, like going back to the very beginning, like there are people down there, and those people are not only people, heck, there's trees and plants and animals that are on that planet, and the only reason that they're there is because this miracle that has our planet have all the right things at this time, right? Mm-hmm. And so everything that we know and we love is only here because of the way the planet is in its lifetime at this moment in time. So you can't help thinking about, we're pretty bold to think that we should have the right to change it, let it change over time. I mean, we are like one planet in our solar system. Our sun is only going to be around for so long, a little longer than you and I will be alive, so that's sort of convenient for us, but maybe inconvenient for later. But our planet is going to evolve as it should, and we should be really good stewards of it just to make sure that it does it as naturally as it does it for the sake of all the living things on this planet. And our planet is alive too. I mean, that's what's, I think, really super compelling from space. You can actually see it, not like on a daily basis, but on a yearly basis, specifically pictures from space 10 years, 20 years, 30 years ago, we can see things changing. Some of it just as it does for itself, some of it as a reaction to us. And I think we should be conscientious of what our impact is and try to minimalize that as much as possible so that we can all live on this planet happily and healthily. Like I said, not only the humans are only one part of it, but everything else that is on our planet.
So we've been traveling into space, maybe not for a very long time, but for a bit. Do you think this is a similar experience that astronauts, even in the past, and anyone who's been able to have that same perspective on our planet, do you think that they have had a similar feeling, and how do you think that that has evolved through the decades?
Yeah, I'm sure they have. But in the very beginning, before we had satellites, we probably didn't have as many, overarching views of what's going on over the long term. In geological time, it's a blink of an eye, but over the long term for our human existence here, I think it's becoming more and more obvious that we have an impact. Like I mentioned, I think folks all need to take the lap around the planet, because then you can see, the frailty of it. Like our atmosphere is so thin, it's ridiculous. Like I think, when we look up to the sky, we think, there's plenty of, oxygen to breathe. We're fine. When you step away from the planet and you see that's just this little thin layer, and that's it between, we're only at 250 miles above the Earth, and it's a totally inhospitable place to be. It's hot, super cold. Obviously there's no oxygen, there's a vacuum of space. You cannot live there unless you have a space station, and that is very fragile as it is. I think you probably know we're always doing maintenance on the space station, so we're always fixing it. So there's no way we could really sustain ourselves in space. So we need to really take care of our planet. And it's the place that we all live and where we're from. We absolutely need to take care of it. You're into the environment, and
Yes.
like everybody should be. And I'm
Yes.
so proud of you at your young age to be thinking about that, have that on the forefront of your mind. It's pretty cool.
I think I'm particularly interested in the environment because, yes, the planet, I love it. If we want to keep living and we want everybody to keep continuing to have the full lives that they deserve and have the same thirst for life, we need a planet that can give us
Sustain
that
that.
kind of shelter.
Yep.
And that's a two-way relationship. Any passions, I think, music, science, whether it's like in space or on our planet, you can't really have those passions if you don't have a planet to live on to experience them. And I think that's kind of what connects all people.
Yep. I agree. I think everybody wants to have a happy life,
Yes.
healthy life.
A healthy life. Exactly.
Yeah. And we all deserve it, but we all have to take responsibility. I love what
Yes.
you said. It's a two-way street.
Yes.
It gives us so much. We need to give back.
As we keep doing maintenance on the space station every day, we need to do that back to our planet.
Yep. Exactly.
Beautiful. What about doing a spacewalk do you think would be the most surprising for people to hear about? Like, what do you think is the most interesting aspect of it that maybe isn't just, well, obviously you're outside in space.
Yeah. There's so many really fascinating things about doing a spacewalk. It is entirely your sensory overload. It is every sensation that you have as a human being wrapped up in 6 hours. First of all, as just to take you through, like getting out the door, as you're getting up, suited up, it's like this is something professionally that you've looked forward to for a long time and practiced. You know it's not going to be easy. You're super focused. You've studied, so you're on the top of your game. And you go out the door and move your way over to where you're supposed to go to work, and then the sun starts to come up and you see the planet right below you. I mean, you have total control of that, of where you're looking, and it's a little shocking and somewhat a little scary. It makes you sort of hold on a little bit for a second, but double check your tethers, make sure you're okay. Okay, my heartbeat just went down, I'm okay. Now the sun's up, so I'm getting a little bit hot because I'm working a whole lot, and then the sun starts to go down 45 minutes later. Oh man, now I'm getting super cold and I'm starting to get hungry because I'm out there for a couple hours. In the middle of it, you're having a conversation with the folks on the ground, so it's tying you right back to Earth. On my first spacewalk, we were up hanging out at the solar array, and we happened to fly over Canada, and the northern lights were below you. It's like, holy moly, that's amazing. That was compelling, left an impact on me because it reminded me that there's so much out there in space that's going on that we have absolutely no control of. You know, probably in those northern lights, my background is as a scientist, but I'm sure that it started from some type of solar flare, and then the magnetic field of the Earth gets activated as that particles come toward the Earth, and we can't do anything about that. That's what it is. And I think that was the most compelling feeling. Like, we squabble down here about energy or whatever we squabble about down here on Earth, which is very inconsequential to really what's going on in the rest of the universe. I mean, we are only one little planet, but it is getting affected by the rest of the universe. And I think that really came true when I was sitting there and that green stuff was below me hitting the Earth, and it is what it is, you know? We're just part of it. So it's like all of that, and then at the end of it, you're like, wait a minute, tick-tock, you know, like, we have to get back in the house, right? So you have to go back, you know, then your brain starts to tick again. Did it get everything done? Where's all my equipment? Where's my buddy? Where's my partner? Make sure all of that, you know, sort of like survival skills, I think, at the end, this sort of tick in, you know, come to play. And every now and then it dawns on you that, like, hey, I'm in a very dangerous place, actually. The main goal of this spacewalk is actually to go outside and come back in, both of you. And I think it finally, at some point in time, that kicks in. So we practice all this on Earth, but there's always something that you don't anticipate. Either it's too hot or too cold for a piece of metal to work correctly. You might have to wait. And so there's a lot of highs that you got something done really quick and fast and you were successful. A lot of lows of like I'm working as hard as I can, and I can't get this done, and maybe you have to alter the plan and call your buddy in to help you out. So it is really a huge spectrum.
What is it like, or what does it feel like to see the outside of the ISS so close, knowing it's just like controlled falling just through space?
You recognize that it's sort of fragile and you're living in there. I think that's one of the things, and it's also incredibly beautiful. Sounds sort of silly maybe, but it really feels like you're in space. You are really part of this universe, versus inside you're sort of like on a ship. I guess it's equivalent to like when you're on a boat and you're on the boat and you're having a pretty cool view of the water and all that kind of stuff, and then if you jump out and you go for a swim and you have some goggles on and you're looking around underneath, I think it's probably that different. It's like you're in it, right? You are in it. I think that's probably a good description of it. I had the opportunity to be on the top of P6 when we had a solar array sticking up, and then look down at it, and it was super cool. I also had the opportunity to be on the front of it, like somebody on the front of a ship, like doing that type of thing. And that's your house, that's your home, that's your base. You want to stay connected to it. You don't want to go away from it. It's humongous. It's absolutely humongous, and you realize that you're pretty far away from the door to get in, but it's an engineering marvel, and you look at all the different pieces and parts that came from all the different agencies and countries, and it's amazing that we were able to put that all together. So it's humbling, super humbling, because you're just one guy out there. Hopefully you're not making a mess of it and making a mistake, and all the work of all those people, I mean, it's culminated into that amazing laboratory. It makes you stop for a minute.
So I have a few questions, as you might guess. And to start with, I'd like to know, what is one thing about living and working in space that most people who have never been to space might not know about or understand?
Well, that's a good question, and I'm not just saying that to fill time. There's a whole bunch of interesting things to talk about. I think probably people think it's pretty nice that you can go and float around up there. But that has some consequences to it, of course. I think our bodies need to adapt to going to space. The initial getting to space, like, whoa, it's a big adaptation, but you feel like we're there. Okay, so now I can float around. Okay, maybe I'm a little clumsy. But I think what people don't recognize is your whole being starts to adapt, and it does take time. Folks had said in the past that maybe a month. I didn't believe it. I think most people don't believe it, but you can really see how people become so natural up in space after about a month, and how smoothly they fly, and actually how that translated to me as a reality. It was like, I was like, I don't know what it would be like to walk. When I was up there was, through the center of the stack, there was a module that went down, and that was essentially our closet, but it was pretty deep. It was probably like 30 feet down, and I'd float right over it, and I was thinking to myself, I don't even think twice about this. Like, if I was walking, I'd be like, oh, like, what do I have to do here? And I actually sort of forgot what it was like to walk around. That your body, your brain, your body can all just sort of live or change to the environment that you're in. I thought that was pretty fascinating.
It reminds me of the videos that you can see of astronauts when they come back and they're holding something and let go, and then it just falls.
Mm-hmm. Yep.
That's always
one time, and then you go, okay, I got it. Now gravity is back. Yeah.
Yes. It also reminds me of if you're ever like on a boat for an extended period and you get back on land and then you have the sea legs.
Yep, exactly.
Would you say that, or was there something else that was the biggest adjustment for you in space?
I think that was the biggest. I think a close second is losing things. I think one of the most annoying things is like when you think just for a second, you just let something go. It's just gonna be there for just a second, and you turn around and some air current takes it, and you'll see a lot of video of people doing this. And that's because they're looking for something, and that's, I think, one of the most annoying things about being in space. And so good pants, a good flight suit like this with lots of pockets is really beneficial.
What is it like once you're in orbit, seeing Earth from the first time from so far away?
Ridiculous. It's awesome. I was actually on the middeck of the space shuttle Discovery that took me up there, and I was working in, we got to space, and things start floating, and that was fun, and I'm chuckling about that. And the commander and the pilot up in the front seats of the shuttle, the commander said, Sonny, come on up. And so I flew up there, and he gave me my little wings, and what was more impressive, I was like, oh, that's nice, but looking out the window, I was like, oh my God, there's Earth. and it's round. It's like they were right. You know, it's super cool, and it's just seeing that planet, you know, in that view is just amazing, and you just can't get sick of it. Every opportunity I think everybody has who lives on the International Space Station. We have this amazing cupola window now. We have 2 windows that look out by the GEM, so you could see the curvature of the Earth from those 2 venues, and it's just compelling. I mean, you can spend all day sitting there watching our planet. Another transition, you know, sort of like your body adapting. Initially, I was always trying to find places that I knew, like, of course, like Houston, or where I grew up in Massachusetts, or where my dad was from in India, highlighting little pieces and parts of the Earth for the people, which is, of course, very important. But after time, I think I started getting more joy out of looking at our planet as a planet. Like watching algae blooms and all of a sudden in the ocean someplace there's this huge amazing blue spot, or how the ice forms and flows up in the North Atlantic with swirls, or how the clouds are moving. That was another transition. You look at it like it's a living system. The environment is absolutely living. The oceans are living. It's all changing right below you. It seems like, you know, as we sit here on Earth, we don't see all that happening, but when you look at it from that, you know, macro perspective, finally, it took a little while, but that's how I viewed Earth. It's a pretty cool planet.
And I'm sure it's even more because it's not just the still picture, you're watching it just like grow and transform right in front of you.
Right in front of you, yeah.
Before you saw it from that perspective, did you have any expectations about what you were going to see?
Yeah, of course. I mean, I was, you know, whenever I would get a little bit bummed out here for some whatever reason, missing my family or whatever, I would take a little trek over to Space Center Houston and watch an IMAX movie and go, wow, you know, there's some pretty cool views, but it doesn't even do it justice. I mean, it gave you a foundation, a baseline of what you might see, but when you actually see it for your own 2 eyes, one of the reasons I feel like everybody on this planet needs to take a lap around our planet. Go to space, take a lap, and just look out the window, come back, it'll change your view of things, your perspective.
Mission and liftoff.
Touchdown confirmed.
Hello, United States.
To explore every phase of cosmic history.
Flashing across California desert skies, the airplanes you see here are writing new chapters in the story of man-made flight. There she goes.
This is my first opportunity to greet you as Deputy Administrator of the National Aeronautics and Space Administration.
Together, you and I must make our new agency
the most unusual place.
An organization that can challenge conventional wisdom.
We can engineer anything we can write the requirements for.
We're going to make your idea work. This particular idea is quite disruptive.
A typical flight, of course, starts under the wing of the B-52 mothership.
This sleek, high-speed machine would have made Rube Goldberg proud.
The manner in which we fly re-entry from space on the space shuttle was pioneered on the X-15.
The X-31 pretty much wrote the book on thrust vectoring, along with its sister program, the F-18 HAR.
An observation of an occultation is one of the more challenging missions that Sophia can do.
Right now, we are looking at the dawn of a new era of aviation.
Since the telescope was invented in 1610, The astronomer's lens has been partially obscured by the Earth's atmosphere. He has always carried his telescopes as high as he could.
The Earth seen whole is a compelling reminder of the need to safeguard our earthly resources.
To predict, and perhaps someday to control, changes in weather and climate is of the utmost importance to man everywhere. The ocean.
The air and atmosphere, fresh water, ice packs, crops, forests, mineral deposits, pollution. Each has its own type of impact, but always they will be there.
The X-15 aircraft.
She's not the queen of the hangar anymore, although she's still hard at work.
Carrying a heavy payload of instruments, undertaking studies of the near-space environment, possible before only with unmanned satellite and rocket-borne probes.
There's hardly any atmospheric pressure at all. So that's when some of those high-altitude experiments were performed. One of the airplanes had wingtip pods on with experiments out there, sometimes a camera, sometimes a sampling device for a high-altitude or micrometeorite.
Dryden's SR-71 was used as a science camera platform. An upward-looking ultraviolet video camera studied a variety of celestial objects in wavelengths which are blocked by the atmosphere to ground-based astronomers.
Every object on land or sea emits visible light, heat, and other radiation which can be measured.
High above the ground, we can more clearly see nature at work.
Advancing our understanding of the Earth as an integrated system.
Earth observations, stratospheric sampling, and testing of future shuttle or satellite instruments.
If it takes $1 billion to launch a satellite, you want to make very certain that your instrument works properly.
Plane and satellite complement each other.
Not only for validation, but also to acquire data that you simply can't get from satellites. Vertical profiles, high-resolution measurements.
In situ data.
Actually sample rather than to try to observe this from 100 kilometers away in space.
The sophisticated airborne research platform supports scientific investigators involved in a wide variety of disciplines.
Our first goal is to underfly the ER-2 up and down the Scandinavian coastline, look at CLO and the nitric acid out in the vortex.
With a platform like this, we can carry thousands of pounds of instrument aboard this aircraft. And that means we can put a huge variety of measurements on board. And those measurements all together really pin down how ozone is changing.
We're asking the types of questions now that aren't the first order questions, probing in more detail at a lot of the facets of atmospheric chemistry. We've actually pushed the flying capability of the platform to the limit. It represents a critical engineering feat on the part of the engineers who work on the ER-2 to integrate these instruments.
When we understand the details of what's happening, then we can make better predictions of what this may mean in the next century. Our job is to give that information to policymakers for them to make an informed judgment about what needs to be done to prevent problems.
Our purpose is not here to set policy, but to get sound scientific information on the environment.
U-2 is unique in that it flies at very high altitude, above 60,000 feet. From that vantage point, your view is very similar to that you would get from a satellite. Gathered data over the same spots here in South Africa when the satellite's overpass, and then they can use that data for validation of the satellite data.
Plus we have the ability to measure in situ, actually flying through the atmosphere, even getting a true cross-section from the satellite down to the ground.
Not that my flight is directly going to affect the welfare of any one person or group of people. It's part of an overall larger effort to enhance living standards worldwide.
What we're hoping to be able to see are the remains of advanced civilizations beneath the forest cover.
Multiple sites all throughout Central America, from Panama to Mexico. They believe that they've discovered things that would have taken an archaeologist 30 or 40 years of digging.
AIRSAR is an instrument that provides you very detailed information about the hydrology of the landscape, meaning how the streams are located, what areas are wetter than the other areas.
Having the platform that is movable and changeable and variable in flight, not dependent on ground programming, is a priceless asset.
The DC-8 has a large range. I don't know that there are too many other platforms that could have gotten us out to the Antarctic for significant data acquisition and then back to Punta Arenas, Chile.
We need to understand and map how the polar ice sheets and the sea ice are changing from year to year.
Since we have this opportunity with a big aircraft that can carry many different instruments, we not only measure the ice surface elevation, but we have also ice-penetrating radar instruments that allow us to actually look through the ice, find out how thick the ice is.
In this case, we're measuring the rain and snow.
It's an incredibly versatile and sturdy platform. It allows us to fly high or low, and it can carry a very nice complement of instruments. It will provide direct information about the nature of these fronts and atmospheric rivers. This information can be analyzed directly by the modelers to understand where can they improve their models.
Things that study nature, they don't ever do exactly what your plan was.
Measurements we make and impacts will help us improve forecasts. It'll also help us improve how we measure from space.
Winter storms, intense rain activity on the West Coast.
We're trying to get an understanding of the thermodynamic state of the atmosphere.
NASA deployed its piloted DC-8 and unmanned Global Hawk aircraft in a massive effort to collect as much data as possible.
It costs about $1 million per linear mile of coastline. We mispredict the landfall of a major hurricane.
We expect that these measurements will enable hurricane modelers to improve their track. The involvement of the Global Hawk is a game changer.
You can use this plane to do reconnaissance. Science is just a different kind of reconnaissance.
A combination of endurance, range, and altitude.
We're above the weather. We can study it with all our sensors from on top.
Satellites in low Earth orbit only provide a very brief glimpse.
With the Global Hawk, the expectation is that because of its 30-hour flight duration, we're going to be able to be out over storms for up to 20 hours or so.
Similar remote sensors that you might fly on a satellite, and then you're bringing it down to a 60,000-foot level. That's like putting the whole storm up into higher resolution.
We will start setting out specific flights to address things like air quality, aerosol over polluted areas.
Measuring the atmosphere from pole to pole, doing vertical profiles from approximately 42,000 feet down to 500.
What does the atmosphere look like? We'll quantify 100 gases.
250 different chemicals and ultrafine aerosol. Most can't be measured by satellites at all.
Where does ozone go to be removed from the atmosphere?
We can do things for climate and air quality if we decide we want to do something about that.
Science has a mission to measure atmospheric carbon dioxide during all times of the day and night.
You don't realize how fun it is to be flying 500 feet off the ground. This big DC-8 that kind of scares everybody in the neighborhood.
The DC-8 has some of the best measurements of CO2, methane, and other greenhouse gases.
We get to see where the different layers are as we change altitudes during the campaign.
What happens when this air mass gets up into the stratosphere?
From the overshooting cloud tops of thunderstorms, see how far different chemicals have penetrated into the stratosphere. When things get that high of altitude, it gets into more of the global airstream, and things can go downstream very quickly and start circulating around the globe.
I can't think of another airplane that could carry this many sensors and fly at those altitudes and do that kind of a mission.
ER2 acts like a steerable satellite for us. By studying the interactions between clouds and aerosols, we can better forecast models of climate.
These atmospheric trace gases are important because they affect the formation and destruction of ozone in our atmosphere.
How winds couple with convective systems to really either inhibit or accelerate their growth.
Never before have we been able to fly a system that can measure water vapor, winds, and aerosols all simultaneously.
We're trying to measure every 300 feet as we go up in the atmosphere, and about every couple miles as the plane is moving along. So this is really detailed measurements that you would really only be able to get aboard an aircraft like this.
The DC-8, it's really an airborne laboratory. You're chasing things like winds, they're fairly dynamic phenomena. There's a lot of times when the objectives will change or the area that they're wanting to look at is moved based off of what they're seeing, and we have to try and make that happen in real time.
The aircraft will take off from the Dryden Flight Research Center and then fly over the western United States using its infrared camera to find and actually map out fires.
We will get
real-time information from that scanner that's related to the thermal emission coming from individual fires.
The U.S. Forest Service can use that data to help plan out their resources.
The nice thing about the radar is it can see through smoke, it can see through clouds. So it's an all-day, all-night imaging technology.
The FireX AQ team will deploy throughout the U.S., taking measurements of smoke from wildfires.
The purpose of this overflight was to collect thermal and visual imagery of some study caves that we have located in the Mojave Desert. By being at 3,000 feet, we were able to have good coverage as far as the landscape is concerned. Through developing techniques for detecting caves on Earth, we can then take those techniques and use them to look for caves on Mars.
There was an earthquake about a week ago. We're surveying that area to see what ground movement has happened since the earthquake.
The objective is to prove the technique of simultaneous measurements of ocean currents and winds from the same instrument. Both ocean currents and winds actually influence Earth's climate, and they influence each other. This should be a path forward for the next generation space mission.
The main goal of the mission is to measure as precisely as we can the vertical exchange that the structure produces between the surface and the depths of the ocean. The structure we're trying to see are small, and satellites today are not capable of having this level of resolution. That's the beauty of planes. It allows us to have way higher resolution.
Pretty neat mission. We've been flying around at 28,000 feet. The biggest challenge we have flying these type of missions out here are staying on these exact lines as we fly over the wetlands.
The G3 is an excellent platform for this work. Its speed, its range, it's an easy work environment, as you can see in here.
You can go wherever you want, whenever you want.
And also we can have a different look angle compared with satellites.
Dryden engineers developed this repeat pass capability, which is our platform precision autopilot, which enables us to fly a line in the sky today, and then tomorrow, a week from now, a month from now, a year from now, we can repeat that line every time to within plus or minus 5 meters.
Couples the radar to the flight track of the aircraft.
Right now, the pilots aren't even flying the airplane. It's completely hands-off. This right here is actually flying the airplane.
Flying these lines over and over will allow us to study the wetland change over time.
We can look at how natural deltas form so that we can understand more about sediment deposition and maybe try to reverse these loss of sediments in many of the other deltas around the world.
What we're really out here doing is we're trying to understand how much water, how much sediment, and how much carbon is moving from North America out into the coastal ocean.
This time around, we're focused on forested biomes. The main question we're trying to answer here is how much carbon is stored in a forest ecosystem. These trees are amazing because they really are the connection between the land and the sea.
Today we are over the Arizona area to look at the landslide.
Measuring the heights of the levees against high tide and low tide.
You get information about where the levees are weak. It's very economical to use science to determine where to best use your resources. We could tell when a sinkhole is forming before that catastrophic failure happens. We can try to image the oil spill and the effects on the coastline.
Looking at glaciers as well as volcanoes, which will then go on and help us do some predictive analysis in the future. A lot of it is supporting private organizations, universities, other NASA centers, but we actually have the teams and the tools to be able to take a science instrument like this UAV SAR pod and put it up into the environment where they need it.
The ER-2 is a very unique aircraft. We can get a very wide swath with these super high-tech instruments. We're kind of the last step in development on some of our Earth science satellites. We actually take it up to extreme altitudes and cold soak it and put it in an extreme environment.
We're here to study the volcanic plumes from Kilauea volcano. And we can have a real impact on helping people to manage this risk if we can make the measurements and give them the information they need.
Knowing the spectral signature of what you're looking for can help you ascertain the health of a system.
Different types of coral have different spectral signatures.
We believe we'll be able to say something about where the coral resides and how healthy it is.
We want to make sure that we're using our technologies
to also help the planet and understand processes on the planet.
This basically gives us almost the same view of the moon as Earth orbiting satellites would have. We want to know this to a high level of accuracy because we essentially are using the moon as a benchmark so that Earth observing satellites can turn and look at the moon and set the scale on the amount of light they're measuring from the Earth.
We were beautifully set up to see this. We were just well positioned. Aircraft performed perfectly.
What Armstrong is doing to go out there and facilitate science missions such as this Eclipse mission, these involve detailed logistics, flight planning, modification of aircraft.
We're able to see the eclipse for a little bit longer than others might. We control our timing exactly so that we enter that region of totality right when it starts, fly as slow as we can through it, and get the maximum amount of time on that target.
You don't have to be a scientist to really be transformed by the beauty of a total solar eclipse.
If you think about what our own eyes are able to see, a rainbow of colors, but that rainbow is a very, very tiny sliver of the much larger types of light that is out there. Infrared astronomy allows us to study objects that are very cold.
The center of our galaxy, in the visual range, you really can't see much because it's obscured by this dust. And infrared can see through dust.
The Earth's atmosphere blocks most of the infrared band. To really get an infrared view of the universe, you need to get somehow above the water vapor in the Earth's atmosphere.
It is a 747 plane in which we have put a 2.5 meter infrared telescope.
It's the largest telescope to leave the surface of the Earth so far.
We're going to look at a view that no one's ever seen. So you're bound to find out something.
It's currently operating in a regime no other instrument in the world can operate at.
What the big advantages of a flying observatory like SOFIA is you can always access the instrument, you can always upgrade the instrument.
We can make improvements to the telescope, we can make improvements to the mission systems on board.
One of the premier observatories to pioneer large instruments.
We're not limited to weight that launch vehicles require to put something into space. We can carry instruments that are hundreds of pounds. We can give those instruments much more power than you can generate from solar collectors in space. There's also time-unique missions.
The shadow of Pluto passing in front of a background star is going to be cast in the middle of the ocean.
It's going to have the best position of any observatory on the planet for this particular event.
A significant technical accomplishment of the program is the pointing stability of the telescope itself. I have all the little vibrations and jumping around of the airplane that can actually stay stabilized on a quarter 3 or 4 miles away.
It looks like the telescope is moving, but the telescope is rock stable. The aircraft is moving beneath the telescope.
It's an amazing engineering feat, I think, that door back there is big of the hole that it makes. When it opens, you don't even notice it whatsoever.
Hello from Sofia. I'm flying in the world's greatest and highest altitude infrared astronomy telescope ever.
It's nice to be able to share what we're doing with people who will take it back to students and hopefully inspire them to go into science and technology and engineering.
I think that's giving us the opportunity to gather information that we may have never had before.
I've watched a world-class telescope take data that no other telescope on Earth can take.
It really invigorates you. It stimulates your thinking.
We can turn all of these things into teachable moments in our classroom.
Having them see that it's really such a team effort, I think is important.
I'm going to be able to take what I've learned on SOFIA into my chemistry, into my biology, into my physics classes, and into my engineering classes.
What I learned on SOFIA is you have to know a little bit about all of the disciplines in the sciences to be successful.
What an amazing science opportunity for not only my students, but for myself to truly grow as a teacher.
If I could talk to my high school students right now, I would just say that if you look around, you're going to see why hard work and science and math and all kinds of opportunities out there are worth the effort.
I hope that many teachers will have the same chance as me, go on a plane called SOFIA and fly to the stars.
We're flying on the DC-8. It's really exciting. There's a bunch of different real-time measurements. It's
It's really cool to see how these are fluctuating when we're flying over different environments.
Look out the window and you see the city, you see the smog. Then you look at the screen here and you see a direct relationship with the measurements of these different compounds that we're looking at. In the classroom, you don't get that degree of involvement.
Really interesting what we're seeing today, very different from what we expected and what we saw yesterday.
An amazing opportunity to, first of all, do cool stuff like this, like flying a plane, and also conduct amazing research and build my skill set and network with people at NASA.
You get to dream about, doing all this science in the field, and you literally are doing it right now.
It's my first experience with Fieldwork, really.
Highly recommend applying to NASA SARP if you are even remotely interested. It's such an amazing program.
We are going. The history of this agency is marked with broken barriers, once viewed as impossible, with science fiction turned reality, with innovations that have spun industries all their own, and with demonstrations of peace for all humankind.
We soar in the skies of our home planet. We maintain a human presence just outside of gravity, and we touch points all across the solar system and beyond. We're going back to the moon, and this is why.
The moon is a treasure trove of science.
It holds opportunities for us to make discoveries about our home planet, about our sun,
and about our solar system.
The wealth of knowledge to be gleaned from the moon will inspire a new generation of thought and action.
Without fail, every major program and mission NASA has invested in has led to technologies and capabilities that have shaped our culture.
The breakthroughs of the Artemis era will define our generation and the generations to follow.
The tens of thousands of jobs associated with propelling us to the moon today are just the beginning of a lunar economy that will see hundreds of thousands of new jobs develop around the world.
This is not an ambition of one entity or one country. The exploration of the moon is a shared effort,
woven together by a desire for the greater good.
Why the moon? Because the missions of tomorrow will be sparked by the accomplishments of the Artemis generation today.
Because the ambition to go has already begun.
And because Mars is calling. We need to learn what it takes to establish community on another cosmic shore. So let's camp close before pushing out.
And so, we go to the moon now, not as a series of isolated missions, but to build a community on and around the moon capable of proving how to live on other worlds.
We'll use the lessons from more than 50 years of peaceful exploration to send a new generation to the lunar surface to stay.
We will anchor our efforts on the lunar South Pole to establish the Artemis Base Camp,
positioning us for long-term science and exploration of the lunar surface.
We will prove what it takes to assemble a complex ship in deep space.
We will perfect descending down to and returning from a distant surface.
We will learn how humans can survive and thrive in a partial gravity environment.
With improved spacesuit designs, mobile habitats, and with reconnaissance robots pre-positioning and relocating supplies.
We will learn how to utilize the resources we find on these other worlds, starting with finding water ice and purifying it to drinkable water.
And refining that into hydrogen for fuel and oxygen to breathe.
We will establish fission power plants on the surface of the moon, capable of supporting a growing community of efforts.
And we will expand the logistics supply chain
to enable commercial and international partners
to resupply and refuel deep space outposts.
None of this is simple or easy, but nothing in our history ever has been.
The Eagle has landed. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot.
This kind of continuous lunar presence is a natural extension of all that we've learned in low Earth orbit. and what we will accomplish there will ensure the monumental missions to Mars are within reach. As we ready the launch of the first Artemis mission, and as commercial companies ready their lunar landers for the first private payload deliveries, we have already begun to take the next step.
Getting ready to image faraway planets, discussing artificial intelligence at NASA, and a milestone for our supersonic X-plane. A few of the stories to tell you about this week at NASA. The Roman coronagraph instrument for our Nancy Grace Roman Space Telescope was recently shipped from our Jet Propulsion Laboratory to our Goddard Space Flight Center. The coronagraph will test new tools that block starlight to reveal planets hidden by light from their parent stars. The instrument will demonstrate technologies that could help pave the way for future missions searching for habitable worlds outside of our solar system, like NASA's proposed Habitable Worlds Observatory. The Roman Space Telescope is targeted for launch by May 2027. On May 22nd, agency leaders hosted an artificial intelligence or AI town hall at our headquarters in Washington. The event provided an opportunity to discuss how NASA is using and developing a variety of AI tools to advance missions and research. Learn more about artificial intelligence at the agency at nasa.gov/artificial-intelligence. Our team for the quiet supersonic X-59 aircraft has taken the next step toward verifying the airworthiness of the plane by completing a milestone flight readiness review. This review allows the X-59 to progress toward flight. The X-59 is being developed as part of NASA's Quest mission to reduce the sound of the typical sonic boom associated with supersonic flight to a quieter sonic thump. As part of our efforts to expand commercial resupply in low Earth orbit, Sierra Space's Dream Chaser spaceplane recently arrived at our Kennedy Space Center to prepare for its first flight to the International Space Station. Before Kennedy, the uncrewed spaceplane and its cargo module were at our Neil Armstrong Test Facility in Sandusky, Ohio. While there, the Dream Chaser was exposed to vibrations like it will experience during launch and re-entry, as well as low ambient pressures and extreme temperatures it will encounter in space. The spaceplane, named Tenacity, is expected to deliver 7,800 pounds of cargo to the space station later this year. That's what's up this week at NASA. For more about what else we're up to, check out nasa.gov.
Years ago, we went to the moon. We called it Apollo.
What many people don't know is that Apollo had a twin.
She was a woman named Artemis, goddess of the moon.
We are returning to the moon
as a new generation of explorers.
This time to stay.
And to prepare to achieve humanity's next giant leap of sending the first human missions to Mars.
We believe our course will redefine what is possible.
That we would discover life-saving,
earth-changing science.
And that the challenges ahead will inspire generations.
This is our manifest.
For all who wondered if we could return.
For all who dreamed of pressing beyond.
This is your calling.
We go for all of America.
We go. We go as the Artemis generation.
We go.
Hello and welcome to the official kickoff event for NASA's App Development Challenge. We appreciate you joining us today as we launch the latest version of the ADC specifically designed for middle and high school students and educators. My name is Jamie Semple. I'm a NASA Education Specialist with Paragon Tech. And I work at NASA's Johnson Space Center in Houston, Texas. I'll be providing details on this year's challenge, and we'll also be joined today by NASA subject matter experts to talk to you a little bit about NASA's Artemis program and also share with you some essential information to be successful in this year's challenge. So what exactly is the App Development Challenge? The ADC is a coding challenge where NASA presents technical problems to students seeking their contribution for future exploration missions. By participating in the App Development Challenge, you directly take part in the Artemis generation's efforts to land American astronauts, including the first woman and the next man on the moon by the end of 2024. This year's App Development Challenge was created in collaboration with NASA's Space Communications and Navigation Team, also known as NASA SCAN. The SCAN team needs an app that visualizes the moon's South Pole region. Based on that need, we are asking students to form teams to create a visualization that will display essential information of the moon's South Pole region. Student teams will have up to 7 weeks to create an app solution and post a video of that solution online for NASA to review and potentially use in the future. We'll talk a little bit more about the ADC in just a few moments. I'd like to give you an idea of our agenda today. In just a moment, we'll have some opening remarks, and then we'll have 3 presentations. The first presentation will be about NASA's Artemis program, the second presentation about the App Development Challenge, and the third presentation presented by our ADC technical advisor, who's going to talk a little bit more about the app that you're going to create and how to be successful in this endeavor. If you have any questions throughout the course of the presentations today, we encourage you to go ahead and post a question in the chat. We'll try to answer those after each presentation, or most likely at the end of all the presentations today. But now it's time to officially launch this year's App Development Challenge. I'd like to go ahead and introduce Dr. Danae Fullwood, NASA's Next Gen STEM Moon to Mars lead, to provide some opening remarks. Hey, Danae, thank you for being here today.
Hi, Jamie. Thank you for having me. I just want to say to everyone who is tuning in, thank you. Thank you for your interest in this opportunity, and thank you for your interest in NASA. Thank you for being a part of the Artemis generation. We are looking to you to help us stay inspired and stay on track when it comes to landing the first woman on the moon and putting the next man on the moon. We do believe that your creative ideas and your input is something to be valued, something to be treasured, something to be incorporated. This is something I would love to make sure that everyone has the opportunity to hear about. So please make sure that you share this with other middle school and high school students. Do not keep this opportunity to yourself. Be collaborative, be creative, and be certain to participate in those things that we offer. If you don't have the background of knowing what NASA has, there is an opportunity for you to stay abreast to what we have coming down the pike. That is, you can join our NASA Express email list. Be certain to go to nasa.gov and sign up for the NASA Express email list. This will give you the opportunity to stay abreast of all the student competitions, all of the lessons, all of the SME or subject matter expert opportunities and presentations that can keep you following NASA and what we're doing. We're so happy to have you. I'm happy to invite you to participate in this activity, and thank you.
Great, thank you, Danae. We appreciate your time today. All right, students, it's time to join the Artemis generation and take part in NASA's efforts to return to the moon. In order to do that, we need to know a little bit more about NASA's Artemis program. Our first presenter today is Patricia Moore. Patricia is a member of the Artemis communication team, and she's going to tell us all about the Artemis program. Patricia, thanks for joining us today. We're looking forward to your presentation. Go ahead and take it away.
Thanks, Jamie. I'm super excited to be with you this afternoon, and I'm incredibly excited to share with you about NASA's return to the moon with the Artemis program. So to kick things off, I want to tell you a little bit about myself. I work at Johnson Space Center, which is in Houston, Texas, and I'm part of the Artemis communication team. And our job is to share NASA's story and involve the public and schools and museums and people all over the world and share what we're doing to get our first woman and the next man to the moon in 2024. So let me show you a few pictures of my past and tell you a little bit about my story to NASA. So I started off really falling in love with space when I was in college. I wanted to be a teacher when I was in college. And so I thought, hey, it's a great idea to get some experience working with students. So I worked at Space Center Houston, which is our official visitor center for Johnson Space Center. And I worked there for 10 years. So I finished college, got my education degree, I met my husband, and that's a picture of he and I like in 2002, I think. And then after working at Space Center Houston, I had the opportunity to come and work at NASA. So my first job at Johnson Space Center was working in the Digital Learning Network, where I taught science lessons and shared NASA stories with students and teachers. And not only did I work in a studio, but in the next slide, you can see that I got the opportunity to work with astronauts and got to go on location during analog missions, which are practice missions for future missions to the Moon and Mars. So that was super exciting. And so from there, I now work specifically with the Artemis communication team and get the chance to share NASA's story with people like you, and mostly with museums and science centers. That's kind of my area of expertise. All right, so let's talk about Artemis. So like I mentioned earlier, Artemis is the new lunar exploration program for humans. And our goal and our charter is to get the first woman and the next man to the surface of the moon by the end of 2024. And Artemis, if you're familiar with Greek mythology, is the twin sister of Apollo. So it really is the perfect name for this program, which will include sending female astronauts to the moon as well. So we're super excited to do this, and we need lots of new capabilities and lots of new equipment to get us there. So let's take a look at what we need to get us to the moon. All right, so in order to get to the moon, we have a lot of people at NASA that are working together. We have people working on hardware like rockets and spacecrafts, but we also have people who are scientists that are helping us choose the best location to land on the surface of the moon and to help us figure out what kinds of science that we can do on the surface. So some of the benefits of returning to the moon is being able to explore the solar system in a new way, being able to learn about the water cycle on the moon and look for water, figuring out what can we do on the surface, what resources are available to us to make living off the moon easier. And all of these different science and technology demonstrations that we do will all help us for future Mars missions. So going to Mars is the end goal. That's where we want to go, right? And in order to do that, we want to practice closer to home. And the moon is the great place to do that. Next slide. So when we go to the moon, NASA is focusing on the South Pole, and the Shackleton crater is one of several craters that NASA is interested in. We have not chosen a landing site yet, but Shackleton is pretty exciting. It's one of those really interesting craters in the South Pole region that has permanently shadowed areas. And in this picture, you can get an idea of how big Shackleton is. We have a map of Washington, D.C. laid right on top of that crater, and you can see it's very large. And if we queue up the next video, you can get an idea of, and I'll explain why the South Pole is of interest. If you watch this video, you'll be able to see the sunlight and see how things change. So around the rim of these craters in the South Pole, there is a lot of light. And in the South Pole area, we are almost in constant sunlight most of the time. And then there's a few months out of the year where it's dark, but we get a lot of sunlight at night and all throughout the year. And that's really important. So we have light for our astronauts so they can move around. We can use solar power to power all of our equipment. And so that's one reason the South Pole is great. And then you have those dark craters that you saw earlier. And those dark areas have permanently shadowed regions that have never touched or been touched by the sunlight. And that's where our water ice is. So traveling to the South Pole gives us access to water, which can be used for drinking water, for turned into oxygen, even rocket fuel. It's a great place to look maybe to see if there's any evidence of life on the moon. So it's a great place to do science. And then it also gives us the sunlight that we need. Now, this chart is one of my favorites because it really shows you how difficult traveling into space gets the farther away you get from Earth. So going to the space station takes a few hours. You have to have a heat shield to come home because you experience 3,000 degrees Fahrenheit in return entry. But as you notice, when we go to the moon, it gets more difficult. And then look at Mars. It becomes incredibly difficult. We go from taking a matter of hours to get to space and come home to 9 months to get to Mars and back. And so like I mentioned earlier, that moon is in that perfect place where we're a few days away to give us an experience to be independent and to learn to live without the constant support of the ground and knowing that you can get home very quickly. And so that will be ready for our Mars missions in the future. Next slide. So to get to Mars, we're going to need a rocket. And the Space Launch System is the rocket that NASA's building right now to get us to the moon. And we'll be able to use the same system to get to Mars. So the Space Launch System is different from all of the other rockets that are in existence that are built right now. And it has a greater payload capability, which means we can carry more stuff. And when we go to the moon and when we go to Mars, we're going to need to take a lot of stuff to keep our astronauts safe. We have to take our supplies and our food and our rovers and our experiments and all of our tech and all of our equipment. And the Space Launch System gives us that capability to be able to take a large amount of payload away from Earth orbit to the moon. And in this next picture, you can get an idea of how the Space Launch System compares to other rockets that we've used in the past. So there we go. That next slide, you can take a look at the space shuttle. You see how much smaller it is. The space shuttle didn't have a large amount of payload capability, which means you can take stuff, right? The Space Launch System, that first version, we can take about 12 elephants worth of payload. The second version you see there, we can take up to 22 elephants worth of stuff, and it will end up being taller and more powerful than our moon rocket, the Saturn V. So we're super excited about the Space Launch System because it's almost finished. And in this next picture, you can see the actual hardware, the actual rocket sitting on a test stand at Stennis Space Center in Mississippi. And in just a few weeks, probably the beginning of November, end of October to beginning of November, we're going to do the final large test for the Space Launch System and fire all 4 of the engines on the core stage, and we're going to strap it to a test stand, and we're going to test all 4 engines at the same time. So be on the lookout for that test. It'll be all over NASA TV and all over the internet. So the core stage is almost finished. That's really our last piece. And but there's more to the rocket than just the rocket, right? You have to have a place for the people. And the Orion spacecraft is this next picture, and this is where the crew ride. It is placed on top of the rocket, and the Orion spacecraft can carry 4 astronauts, and it's kind of what we call like a taxi. So the Space Launch System carries Orion to Earth orbit. The Orion goes from Earth orbit to the moon, and then it brings the astronauts back home. And so it's our vehicle that gets the astronauts to and from the lunar orbit. Now, the Orion doesn't land on the surface of the moon. We have to have an entirely new vehicle for that. And so in this next picture, we'll talk a little bit about the human, it's not the human landing systems. I'm sorry, I jumped ahead. So the Artemis programs have several different missions. The Artemis 1 is our first mission that takes place at the middle to end of 2021, so about a year from now. And that will be a test mission of our vehicle and of our rocket and our spacecraft. And in this next picture, we focus on Artemis 2, I think that's next. And Artemis 2 will be the mission that we carry crew for the first time. And that will take place in 2023, about 2 years from Artemis 1. And we'll take astronauts to orbit the moon, and then we'll bring them home. We're not landing on the moon in 2023. We're going to save that for our Artemis 3 mission. And in this next picture, you can see Artemis 3. Artemis 3, which will be our astronauts' crew as they fly onto the moon. And then in this final picture, you'll see our lander on the surface of the moon and our astronauts traveling to the surface with the first woman and the next man. So it's super exciting. Now, I jumped the gun earlier. I mentioned human landing systems, and I think that's what's up next. So let's look. Yeah, here we go. All right. So in order to get to the surface of the moon, we have to have a vehicle just like we did in the Apollo. We had the lunar lander, or the LEM, to land astronauts to the moon, and NASA's developing a lander now. But we're doing it a little bit different. So in this next picture, you'll see that we have 3 different ideas, and these 3 different ideas came from companies. We have ideas from Dynetics, from SpaceX, which is in the middle, and then with Blue Origin at the end. And these 3 companies all proposed ideas to NASA, and they were the 3 that were selected to come up with a landing system. And NASA will choose one of these 3 companies to develop the human landing system that we'll use in 2024, and we'll potentially use the other landing systems for future missions. So NASA's working really closely with industry, so companies, to make our Artemis missions possible. Now, in order to stay in the moon, in the area around the moon for a long period of time, we need something else. And that something else is called the Gateway. And the Gateway in this next picture is like an orbiting platform, an orbiting spacecraft that stays in orbit around the moon. And this is where the Orion spacecraft and the astronauts come, and they attach to the Gateway. the astronauts can get out, stay inside the gateway for a few days or a few hours as they prepare then to get into their human landing system to go to the surface. So this is going to be like a waypoint or an outpost for us to prepare for missions to the surface of the moon. And we may also use the gateway to help us prepare for missions onto Mars. So it's an important part of that, what we call sustainability, which gives us time to be on the moon for longer periods of time. So not just to go once or twice, but we want to go and we want to stay longer each time. In this next picture, you'll get an idea of what those future missions could look like. So when we go to the surface of the moon, we're going to need new spacesuits. We're going to need habitats. We're going to need new tools. We're going to need scientific equipment. All of these new things that we're developing, we'll be able to use to make an outpost and a base on the surface of the moon and the South Pole area. So I think maybe it froze. I don't see the next one coming up. There we go. All right. So in order to make this possible, Gateway, our partners in Gateway, will be able to not just be commercial partners like SpaceX and Northrop Grumman, and we have Maxar, but now we're going to involve our international partners like the Canadian Space Agency and JAXA, which is Japan, and Russia, and ESA, our European partners, to make getting to the moon stronger, a more collaborative endeavor. And in this next picture, you'll see all of our efforts working out great on the surface of the moon, testing out our suits, and really looking forward to how Artemis program can help us prepare for missions to Mars. Remember, Mars is our goal, right? So let's go to the next picture and let's go to Mars. So Mars missions are way into the future. NASA's goal is to have our first mission in 2020 by the end of the 2030s, which is not that far away when you think about it, but we're not quite ready to do that yet. And in this next picture, you'll see that NASA's been going to Mars for quite a while now. We've got rovers that we've been sending for years, and we just launched the 2020 rover, or the Perseverance rover, like a couple of months ago. And so we know a lot. And each of these missions teaches us more. So in this next slide, you'll be able to imagine what it would be like for astronauts on the surface of Mars. And all of these things that we're practicing with Artemis will get us prepared and ready. And I hope that maybe one of you will get to see this image in our next slide. So if you go to the surface of the moon, if you go to the surface of Mars, you could look up in the night sky and see this. And if you look up in this next picture, you'll be able to see Earth as a tiny speck in the sky. And that's what Earth would look like if you were on Mars. So it's very, very far away, right? Millions of miles away. But we want to do it, and we need you to help us get there. So in this final picture, in this final slide, we're going to say, let's go, right? It's time is now, let's go. And being a part of this app development challenge, you will help us make Artemis missions possible. You will help our scientists and engineers gather data that we need to make these missions successful. So with that, I appreciate your time. And if you have any questions about NASA's Artemis program, I'll be around to answer those either now or at the end.
All right, thanks, Patricia. We do have a few questions. So let's go ahead and answer those. First question is, how long does it take to get to the moon?
Great question. So to get to the moon is in between 3 to 4 days. So it takes a little while, but that's not so bad when you think about going to Mars would take about 9 months, right?
All right, is Artemis 3 still planned to land at Shackleton, or is it shifting towards an old Apollo site?
So we are planning to land somewhere in the South Pole region, maybe by Shackleton, maybe not. That has yet to be determined. I know there's still conversations happening within NASA to determine the safest landing spot for this first mission in 2024. But we really plan to land in the South Pole. That's where that's where we want to do our science. That's where we want to do our exploration, because we've never been there. Look at that. But maybe one day later on, we may return to some of the old Apollo sites. But as of right now, NASA does not have that in its charter. It's not part of the
solar system than ever before. An era.
All right. Next question is: are we looking to make temporary or permanent lodgings on the moon?
And novel ways.
Great question. So those first few missions will be temporary lodging situations, right? We want to get there. We want to know we can do it safely. We want to test out, all of our systems and our equipment first. And then once we get into a groove where we feel comfortable and we're ready, then we'll start building permanent structures. So a base that we can return to and eventually grow and expand upon. Great question.
Great. Two more questions. How are we going to get oxygen to the Gateway?
Ooh, so all of our equipment and supplies that includes oxygen are taken on supply ships. So it could be taken with us on an SLS mission, and then the Orion would then take it to the orbit and take it to Gateway. Or NASA is also considering, other ways of getting supplies to Gateway. It could be a commercial partner, a company that provides a service to NASA to take supplies. And so all of that is being worked out right now.
Science can be extremely intimidating, but you don't need to be a rocket scientist. We are living in a new era of spaceflight. One where rockets launching and landing every few days has become routine.
Look at that.
An era where humans are building the biggest and most powerful rockets right before our eyes, designed to take us deeper into our solar system than ever before. An era where new ideas are being tried and tested in exciting and novel ways. And as incredible as it all is, it does bring up a ton of great questions, such as, why don't rocket engines melt from the extreme heat of their exhaust? Why don't we launch rockets from on top of mountains so they're closer to space? How do you actually get a rocket engine started in the first place? These are great questions with interesting answers, but it's one thing to know the answer to these questions, but I believe the real fun comes from understanding the answer. And that's my goal. I'm Tim Dodd, but I'm better known as the Everyday Astronaut. Join me as I take you behind the scenes of rocket factories, get up close and personal with rockets and launch pads, talk to the biggest names in the aerospace industry, take you to the most exciting rocket launches live, and produce deep dive documentary style videos with detailed charts and animations, all to help you understand rocket science better than ever before. And all of this will hopefully give you a better appreciation of the extreme challenges involved in exploring our universe, and helps you cheer on those who are making the history that will certainly be in our future history books. Rocket science can be extremely intimidating, but you don't need to be a rocket scientist to be excited. Everyday Astronaut, bringing space down to Earth for everyday people.
Starship is ready for its 4th flight. Webb finds the most distant galaxy ever seen. A new way to detect Hawking radiation and fresh volcanoes on Venus. All this and more in this week's Space Bites. Well, are you ready for the 4th attempt of launching SpaceX Starship? We got the news this week that SpaceX is targeting June the 5th at the earliest to take another crack at launching Starship. Once again, they're going to blast off a Starship on top of Super Heavy. It's going to separate. Starship is going to fly to orbit. The Super Heavy is then going to attempt to return and land gently into the water in the Gulf of Mexico, while Starship is going to continue onto orbit and then is going to attempt to deorbit through the atmosphere and make its own soft landing somewhere in the Indian Ocean. And this is sort of chosen because this is a way for them to be able to have a trajectory where they don't have any potential of getting near population areas. That sounds safe, wise. Obviously, there's like a ton of little changes they're going to make, small lessons that were learned from the previous launch attempts. One big change is they're going to eject the hot fire staging segment, sort of in between the top of the Super Heavy and the bottom of Starship, and this is going to be destroyed. And Anton, my producer, really wants us to sort of focus in that this means that Starship is no longer going to be fully 100% reusable if they have to actually dispose of this ring on every launch attempt. We'll see whether they can figure it out and bring that back into the era of reusability. So all eyes are on Starship for June 5th. Obviously, I'm going to be watching the launch, and if it whatever happens, I'll try to provide you some coverage after the launch is complete. Speaking of human launches, even sooner than that, we should get a launch of the Boeing Starliner carrying 2 astronauts to the International Space Station. Now, we've been waiting a long time for this launch. There have been a lot of delays, and we're finally there. Now, we're not in is complete. Speaking of human launches, even sooner than that, we should get a launch of the Boeing Starliner carrying 2 astronauts to the International Space Station. Now, we've been waiting a long time for this launch. There have been a lot of delays, and we're finally there. Now, we're not entirely out of the woods yet. There is an ongoing potential leak of helium on the spacecraft, but it's not urgent enough that NASA thinks it's worth canceling the launch. So they're going to keep an eye on it and still launch. The 2 astronauts, Butch Wilmore and Suni Williams, have arrived in Florida, and they're getting ready to actually board the spacecraft. If all goes well, the rocket will blast off on June 1st. But we've seen so many delays, even just in the last couple of months, that don't be surprised if it gets a few more delays until they're finally ready to blast off. Webb finds the most distant galaxy ever seen. All right, here is a record that I don't think is going to last very long. James Webb Space Telescope has found the most distant galaxy ever seen. Now, the galaxy is called JADES GS Z14-0, or JADES Z14. This is a galaxy that is seen with a redshift number of approximately 14, which roughly correlates to about 290 million years after the Big Bang. And we've heard a lot of announcements about the most distant galaxy ever being seen. In fact, as soon as James Webb launched, we got some announcements of people seeing galaxies that were potentially even less than that, 250 million, 230 million years after the Big Bang. But the big difference is that this galaxy has been very heavily studied. So back in January 2024, Webb stared at this one galaxy for 10 hours. And that's the kind of length of time that you need to be able to do a really accurate spectroscopic analysis of this galaxy. You stare at this one galaxy long enough, you can start to see these chemical abundances. You can see the absorption lines and the emission lines of different chemicals. You can detect their current redshift, and that tells you how fast the galaxy is moving away from us, and so what time in the universe you are seeing it at. Only when you take that time and do that spectroscopic data analysis can you get that accurate number, and Webb just hasn't had the time to analyze all these galaxies. So there's probably other galaxies that it has seen that are farther. It's just that nobody has put in the time to actually confirm. But so far, this is the record breaker, 290 million years after the Big Bang. And what's interesting is this is in a time that astronomers refer to as cosmic dawn. This is when those first galaxies were coming together to form the larger structures, the more mature galaxies like the Milky Way that we see today. This is one of the main science goals of James Webb, was to identify these galaxies and try and figure out that merger process to see how we get these larger structures. A new way to measure the rotation of black holes. We don't know much about the black holes. Really, we can know their mass and their rotation. Maybe we can know their electrical charge. And so there are ways to measure the mass of black holes, and there are a few ways to measure the rotation of black holes. But astronomers are always looking for new ways to figure out how fast is that black hole spinning. And so researchers had a wonderful event happen recently that they're able to use to be able to calculate the rotation speed of a black hole. It's called a tidal disruption event. And this is where a star is consumed, torn apart by a black hole. Some of the material is ejected off into space, and some of the material falls down and joins the accretion disk that is surrounding the black hole. So a couple of years ago, astronomers detected one of these tidal disruption events around a supermassive black hole, and they were able to observe it for hundreds of days, watching as the light was changing over time as the black hole was adding this new star to its accretion disk. And they were able to detect a wobble in the accretion disk as this new material was being added. And from that wobble, they were able to calculate the rotation speed of the black hole. What they found was that the black hole is turning at 25% the speed of light, which sounds like a lot, But in fact, that's relatively slow for black holes. Black holes can spin much faster than that, really approaching the speed of light itself, essentially the maximum speed that is predicted by Einstein. Many black holes reach that maximum speed limit and then they just can't spin any faster than that. So it's exciting that astronomers have a new way to be able to measure the rotation speed of black holes. They just need to watch stars get sacrificed to be able to make that speed calculation. A way to detect Hawking radiation. The late great Stephen Hawking, an astrophysicist, did a lot of work thinking about black holes. And one of his best known predictions is that black holes should evaporate over time, that they should release radiation, other particles called Hawking radiation. And then as the black hole does this, it is decreasing in mass. But the problem is that this happens on an incredibly slow scale. Longer than a human lifetime to be able to detect these particles coming from individual black holes. And so we need a place where black holes are evaporating more rapidly. And so the amount of Hawking radiation that's coming off from a black hole is dependent on the mass of the black hole. If you have something that is, say, the mass of a small asteroid, it's going to evaporate very quickly. It's going to be releasing a hot flash of gamma radiation and then it's going to disappear. But we don't have any black holes like that. But maybe there's a way to make them. Astronomers published a new paper where they proposed that if you had merging supermassive black holes, as these black holes are coming together, they might release what they call morsels of smaller black holes, essentially the remnants that are coming out of this merger process. And so there might be a way to get tiny black holes out of the two black holes as they come together. And then these morsels can have all kinds of different masses, and it might be that it's small enough that they can then evaporate and release a blast of gamma radiation. And so the astronomers proposed that if you watch the mergers between various black holes, you might be able to detect the gamma radiation coming from the morsel black holes that are being thrown out and they're evaporating around this merger process. And the cool thing is that we have the kinds of telescopes today that could be able to detect this radiation. Proof that massive stars are disappearing. Over the last decades, astronomers are coming to the conclusion that very massive stars are just disappearing. The traditional idea of what happens at the end of a massive star, like something with more than 8 times the mass of the sun, is that it uses up all the fuel in its core, it then implodes, produces a supernova, and forms a black hole or a neutron star at the heart. But astronomers have found that a lot of the kinds of stars that should be detonating as a supernova are just disappearing. They call them unnovas as opposed to a supernova. But the problem is they're really hard to find. I mean, you've got a star and then you do a survey a decade later and you notice that that star is missing. Now, it could be that there's just dust in the way, or that there was dust in the beginning, or there was some mistake in the observations. So there's lots of reasons to explain why a star might have disappeared. But in a recent study, astronomers looked at a binary star system that has a star with about 25 times the mass of the sun and a black hole with 10 times the mass of the sun. And the two stars are orbiting a common center of gravity. But what they found is that the orbit is too perfect, too circular. In other words, that you could have a star with that kind of mass and a black hole with that kind of mass. So obviously the black hole was the result of a star that went supernova. You could get that if the star didn't die violently, if it just was a star and then it was a black hole and just collapsed in on itself and just kept going in the exact same orbit that it was going before. It wouldn't be the exact same orbit because it would have lost some mass, but I guess if it didn't explode as a supernova. Okay, I'm going to go with that. All right. And so this very perfect star system gives an evidence that you can get giant stars collapsing into black holes without that pesky supernova in between. So hopefully we will find more and more examples of this, and it gives us another way that stars can die. Every week we do a vote on our channel where you tell us what you thought was the best space news of the week, the most intriguing space news of the week. And the winner this week was that Voyager 1 is back online. So thank you everybody who took the time to vote in last week's poll. Now we will post the new poll onto our community tab on our YouTube channel. But if you're just scrolling on YouTube, you should see the vote. So go ahead, take a second, give us a vote, tell us what you thought. The best chance to be able to see this vote is to subscribe to the channel and then watch a bunch of our videos to tell the algorithm that you want more of our sweet space news. Chang'e 6 is about to land on the moon. In addition to Starliner blasting off on June 1st, we should get a landing on the moon on June 1st. And that is the Chinese Space Agency's Chang'e 6 mission, which is going to be landing at the south pole of the moon in the Apollo crater in the South Pole Aitken Basin. If Chang'e 6 lands safely, its job is to scoop up 2 kilograms of lunar regolith. It's then going to package that up and put it into an ascent module that's going to fly up into lunar orbit. It's going to meet with an orbital spacecraft, which will then bring that capsule back down to Earth so that scientists can analyze this. And this is scientifically fascinating. I mean, you're seeing samples that are coming from the south pole of the moon near to the permanently shadowed craters at the moon. And so we can learn about how much water ice is mixed in with the regolith in those southern regions. Scientifically, the far side of the moon, the south pole of the moon, I mean, these are regions that geologists would love to get their hands on to be able to analyze these samples. But also, think about like what this is. I mean, you've got a spacecraft. spacecraft that is launching to the moon. It is separating. Part of it is going into orbit around the moon. It is then sending a lander down to the surface of the moon. It is collecting samples. It's sending an ascent module back up to space, and then is returning safely to Earth. That sounds like the Apollo missions, right? These are all the pieces of the technology that you would master in order to be able to send humans to the moon. And of course, this is China's goal. This is them demonstrating that they have the various technology pieces figured out to be able to send astronauts eventually to the surface of the moon. Of course, it will be hundreds of kilograms of astronauts and not 2 kilograms of lunar samples. But, you know, this is how it starts. Vulcan isn't a planet after all. It looks like Spock is homeless again. Back in 2018, astronomers found evidence that there is a super-Earth exoplanet in the system 40 Eridani. And according to science fiction lore, to Star Trek lore, this is the homeworld for Spock. And so plenty of news outlets, possibly even us, reported that Spock's homeworld had been found. Of course, it couldn't last. And so researchers did a bunch of double checking and some very intensive observations using the radial velocity method to observe the star. They found that the evidence of an exoplanet passing in front of 40 Eridani was perfectly explained by a large group of sunspots on the surface of the star, which matches its 42-day rotation period. In other words, what looked like a planet was actually a bunch of sunspots on the surface of the star, and as it was turning, those sunspots were coming back into view every 42 days. So Spock's homeworld has disappeared again. Didn't that happen in the movie? Wasn't Vulcan destroyed? Was it Romulus that was destroyed? Yeah, Vulcan was also destroyed. Yeah. It's canon, yeah, so this is how it happened. There are active volcanoes on Venus. Now, it's long believed that the surface of Venus isn't volcanically active. We got NASA's Magellan mission that went to Venus. It used radar to scan the surface of Venus, and it didn't find any active volcanoes. But not so fast. Researchers have been looking through the data returned by the Magellan spacecraft very carefully. And fortunately, it took a bunch of images over the course of several years, from 1990 to 1992. And it imaged many places on the surface of Venus multiple times. And so if there was some kind of volcanic eruption, then they would be able to see the changes. And upon careful inspection, and by comparing the data sets over those multiple years, scientists have actually found evidence of active volcanism on the surface of Venus. So there's 2 regions where they found that vents were releasing lava out onto the surface of Venus, and it was creating lava flows between 3 and 20 meters deep across dozens of hectares on the surface of Venus. And so actually it turns out Venus is a lot more active than we thought. I'm going to talk some more about Venus at the end of this episode, so stay tuned for that. And speaking of Venus, we've learned that the Japanese Space Agency has lost contact with their Akatsuki mission. This was the only operational mission that we had at Venus right now. It was a $300 million mission that the Japanese Space Agency sent to explore and understand the cloud tops of Venus. And unfortunately, it failed to be able to make its original orbital insertion. But then the folks at JAXA were able to use a bunch of gravitational slingshots, and 5 years later, it was able to limp finally into the orbit of Venus and perform a lot of observations and send home what I think are some of the most beautiful images of the cloud tops of Venus. And unfortunately this week, JAXA told us that they have lost contact with the spacecraft. They're going to attempt to restore contact, but don't be surprised if this is the last we hear of it. But like I said, I'm going to talk some more about this at the end of this episode. Now, I try to wrap up these episodes with a really cool picture or video, and today I'm able to give you both. So first, let's take a look at a really cool image that comes from James Webb. This is of the dwarf galaxy NGC 4449, and this is an example of a starburst galaxy. In other words, it's a galaxy that is undergoing an intense amount of star formation. You can see that at the center, you've got all of the stars, and then surrounding that, just these giant clouds of gas and dust, which are the fuel for this galaxy. And you don't normally get a starburst galaxy without some kind of event happening. So it's believed that this galaxy either merged with another one or came too close and had some kind of tidal interaction with another galaxy, and that kicked off this era of star formation. And then a video of flying over the Nila Fosse region on Mars. And this was made based on orbital imagery from ESA's Mars Express mission, which has been there forever and has taken a lot of really high resolution images of the surface of Mars. And then they were able to turn that into this sort of virtual flyover above Mars. The region is called Nila Fosse, and it comprises parallel trenches that are hundreds of meters deep across the surface beside a massive impact crater. And in fact, these trenches are known as graben, where you've got the ground in between two faults fractures up and breaks apart, and you get these sort of slumping and trenches and really interesting terrain. And so it just shows you that Mars has a lot of really fascinating places that we really need to explore. Now, you're watching this video, but right now I'm writing my weekly email newsletter. I do it every Friday and I send it out sort of at the end of the day. And, you know, we're reporting on half dozen to 10 interesting stories here in Space Bites, but we cover many, many more, dozens and dozens of stories on Universe Today, and I write them up for the newsletter. So if you want to get just a great overview of everything we're covering on Universe Today, definitely sign up for my weekly email newsletter. Just to give you some examples of what we're covering. Do you remember the announcement of Dyson spheres? Well, there's a more boring explanation for what might cause them. Starlinks can be surprisingly bright if you're a pilot. And how much water would a self-sustaining moon base require? So to find out the answers to all that, you're gonna have to subscribe to the newsletter. The newsletter goes out to more than 70,000 of my closest friends. It's completely free. I write every word. You can unsubscribe if you don't like it for whatever reason. So go ahead, go to universetoday.com/newsletter to sign up. Now, like I said, I want to talk about Venus some more, but first I want to thank our patrons. Thanks to Abe Kingston, Andrew Gross, David Giltonan, Dennis Alberti, Dustin Cable, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Modzo, Paul Robach, Stephen Krasaki, Stephen Filer Munley, and Vlad Shiplin, who support us at the Master of the Universe level, and all of our other supporters on Patreon. When I think about the work that's being done on Venus, the stuff that we're reporting on this week about potential active volcanism, I think about the fleet of spacecraft that are on their way to Venus over the next decade. We've got 2 missions coming from NASA. We've got Da Vinci Plus and Veritas. And so, for example, when you had that ground radar scan that came from the Magellan mission, we're gonna have a much higher resolution version of that from one of those missions. And when you think about that scanning of the surface of Venus from the Magellan mission, we're gonna get a much higher resolution version of that. And so we're also gonna be able to compare the original surface features back in 1990, 1992 to the surface today. And so hopefully with artificial intelligence, with various techniques, they should be able to spot all of the weird new stuff that's appeared on the surface of Venus. We're going to get a much better understanding of the atmosphere of Venus. We're going to search for the conditions of life in the atmosphere of Venus. So many missions, 2 missions from NASA, 1 mission from the European Space Agency. The Indians are sending a mission, and there's going to be a private mission going to Venus in probably first compared to all of the other missions. And so Venus is going to go from this world that has just been chronically, tragically underexplored to a place that's going to feel as vibrant and scientifically exciting as what we've seen on Mars. So stay tuned, get ready for just an avalanche of cool new space science that's going to be coming from Venus over the next decade or so. All right, we'll see you next week.
There are just too many missing pieces of their vestibular systems to accurately orient themselves.
I encourage you to think about the way your vestibular system helps you respond to information from your environment, and take note of what's happening next time you feel a little off balance. Thanks for exploring the effects of micro-G on the vestibular.
A wide range of experiments and studies contributed to health, safety, and quality of life for people all over the world. A wide range of engineers designed these cylindrical projects to health, safety, and quality of life for people all over the wide range of engineers.
So you've learned that Destiny is a cylindrical shaped pressurized module, but inside the space you can see that our interior space is a little bit more like a square. So these racks are designed to fit against the walls of the circular cylindrical module, and so the back of the rack is curved and the front of the rack is straight. And so we can keep a variety of different kinds of experiments in different racks, and we can also use the ceiling and the floor just as easily as if it were a wall. So one of the places that we store some of our stuff is in the ceiling. Use the ceiling and the floor just as easily as if it were a wall. So see, we have these different kinds of bags that we store things in these different kinds of cupboards. We also can keep, we have these different kinds up here out of the way. So if anybody gets a cut or a scrape, kinds of medicine, we have different packs in here. We also have all these different kinds of medicine up here out of the way. So if anybody gets a cut, I can also use space in the floor. We actually have a window that's in our floor that looks straight down onto the earth. I can also use space in the floor. We actually have a window that's in our floor that looks straight down onto the earth. I can also use space in the floor. We actually have a window that's in our floor that looks straight down onto the earth.
I hope you learned a little bit about the importance of engineering and utilizing volume aboard the space station today. Use the corresponding classroom connection to learn more about area and volume and challenge yourself to redesign your own home and classroom for life in microgravity. Use the corresponding classroom connection to learn more about
one day,
area and volume
you
and
will be an
challenge
engineer
yourself to
designing
redesign your
rooms
own
for
home
us
and
up
classroom
here in
for life
space.
microgravity.
See you next time.
Classroom connection to learn more
Maybe
about
one day,
area and volume
you
and
will be an
challenge
engineer
yourself to
designing
redesign your
rooms
own
for
home
us
and
up
classroom
here in
for life
space.
microgravity.
See you next time.
Hello and welcome to the International Space Station. My name is Shane Kimbrough and I'm an astronaut living and working here 250 miles above the Earth. Hello and welcome. Today we're going to be learning about what a simple machine is and exploring the different ways we're using simple machines up here in low Earth orbit. A simple machine is an object that helps us to easily accomplish a task by changing the direction or amount of a force. There are 6 different types of simple machines. An object that helps us screw, incline plane, by changing the wedge, lever, wheel, and axle. There are 6 different types of simple machines. When we combine 2 or more of these simple machines together, they are called compound machines. Let's dive into the purpose of each of these devices and how we are using them up here on this machine together. They are called compound. A screw is a simple machine that helps to fasten 2 objects together. Here we use a variety of screws in order to keep our station intact. A screw is especially as we deal with microgravity causes objects to drift around. Here's an example of a screw that we may use on a spacewalk. A screw is especially as we deal with microgravity causes objects to drift around. Inclined planes are a broad range of simple machines that use an angled plane to accomplish different tasks. Down on Earth, you use inclined planes to move things a broad range of simple machines. But here in microgravity, we don't need inclined planes to help us move objects. If you look closely at a screw, you will see that it is made up of a rod with an inclined plane that spirals around to help us move objects. This inclined plane helps the screw to fasten to another object. Another simple machine using inclined planes to accomplish something is a wedge. A wedge consists of 2 inclined planes combined to split or separate using inclined planes. We often use wedges to cut objects here on the International Space Station. 2 inclined planes combined to split or separate. A wheel and axle is exactly what it sounds like. A wheel is attached to an axle, helping it to rotate and move easily without friction. A wheel and axle, we sometimes use wheels to help move items that we need to be able to travel without floating away. An example of this would be the wheels on our crew equipment translation aid card. It is attached to a track using wheel and axles. An example of this would be so we were able to use it on our spacewalk without the possibility of it drifting off. It is attached to a track using wheel and axles. An example of this would be so we were able to use. I mentioned compound machines before, and our Advanced Resistive Exercise Device, or ARED, is a great example of that. I mentioned it combines the simple machines, levers, and pulleys to help us maintain muscle and bone density in micro-G. Levers use a surface situated on a fulcrum or pivoting point to maintain muscle and bone density. Pulleys are simple machines that use a wheel and axles to change the direction of an object. or pivoting. The pulleys inside ARED allow us to set the level of resistance for our work axis to change the direction of an object. The pulleys inside ARED allow us to set the level of resistance. Thank you for learning about simple machines with me today. Now I'm going to send you back to Earth to design a compound machine you think you can use up here on the International Space Station. Simple machines with me today. See you next time. Now I'm going to send you back to Earth to design a compound machine you think you can use up here on the International Space Station. See you next time. Now I'm going to send you back to Earth to design a compound machine.
Hello, my name is Tom Horsford, and I'm Matthias Malmann. And we're astronauts living and working aboard the International Space Station, orbiting 250 miles above the Earth's surface.
In the not-so-distant future, we'll be sending astronauts on missions that go deeper in space than we ever did before. To do that, in the not-so-distant future, we'll be sending astronauts on missions that go able to meet our needs. Engineers are designing, building, and testing these systems right now.
You may be wondering, how do they achieve this? And what steps do they take? The engineers use what's called the engineering design process. How do they achieve this? This process involves a series of steps to guide the engineers to develop all of the engineering design. Each piece of technology on the space station, in your home or classroom involves to guide the engineers to develop. But what exactly do engineers do? Each piece of technology on the space, they use science, math, and their own ingenuity to create solutions to technical. But what exactly do engineers do? Examples of technical problems can be developed to use more efficient light bulbs for vehicles, lighter sneakers for aircraft. Examples of technical an orbiting space station for transporting fuels for vehicles, lighter sneakers.
Here's one example of what the process looks like.
Space station Step 1, identify the problem.
Here's one example.
Step 2,
of the process looks like.
identify resources. Step 1, identify the problem. Step 3, research. Step 2, Step 4, develop. Identify resources. Step 5, select the best. Step 3, Step 6, build the solution. Step 7, test and evaluate the solution. Step 8, record and present the results. And Step 9, test and improve the solution. Step 8,
take a look at the space that we are currently living and working in. This space is filled with things that have been engineered using the engineering design process. Some of these items are low-tech. This space packaging, storage has been engineered using the engineering. Some of these items are high-tech. Some of these items, like computers, cameras, and science departments, using the engineering.
A great example of an engineering solution to something you might be surprised is a problem in microgravity. How do we drink fluids? How do we keep a container? How do we get them in our mouth without making a mess? You might be surprised. Here's our standard drinking pouch. We've got some great drink in here, and a very nicely designed straw. It's just perfect for living in space. If you didn't have a straw, and a very nicely designed straw, you can see some fluid coming out there, living in space. I don't want to make too big of a mess, so I'm only going to demonstrate what would happen for a second. We didn't have to see some fluid coming out there, and this would come right off. I'm only going to demonstrate what would happen for a second. Let me drink this up. We didn't have to see some fluid coming out there, and this would. But as you can see, we have a clasp here. Very nicely designed. It pinches the straw at this point here, and that keeps more. As you can see, we have a coming up this clasp here, and that way, if you want to drink something, you just open it up when you need to drink, and that keeps more. As you can see, we have a coming up this clasp here, and that way, if you want to drink something, you just open it up before you pull it out of your mouth. Otherwise, you're going to get more fluid coming out.
Hey, Tom, you're floating. I think that's not convenient for working, no?
That's true. Got a little bit of a problem in that if I do any work with my hands, I'm going to be pushed away from where I'm working. And if I have to find a place to put my feet, which I really want to do, in order to get the work done, sometimes I can't find a place to put my feet. Find a place to still working on it. So I got a problem. In order to get the work done, sometimes I can't find a place to put my feet.
Based on astronaut feedback and data, we developed these rounded hand and foot rails so that you can stay in one place comfortably for short periods of time. Based on astronaut feedback. To maximize comfort, we also have these socks that are padded with rubber on top and bottom for short periods of time. For longer periods of time in one workspace. To maximize comfort, we engineered also restrained cloth straps. You can slip right in and adjust them. For longer periods of time in one workspace. We engineered also restrained cloth straps. You can slip right in and adjust them.
Thanks for exploring the engineering design process with us.
I'm going to send it back to Earth so you can solve your own engineering problems using this process.
See you again soon.
I'm going to send it back to Earth so you can solve your own engineering problems using this process.
See you again soon.
Hello, my name is Shane Kimbrough, and I'm an astronaut living and working aboard the International Space Station. We're currently orbiting 250 miles above the Earth's surface at approximately 17,500 miles per hour. You may be wondering how it's possible for the space station to be continuously orbiting Earth. Well, today we're going to answer that question and explore centripetal force. You may be wondering how microgravity environment is continuously orbiting Earth. Let's get started. Today we're going to answer that question. Before we dive into centripetal force, it's important to look at Newton's first law of motion, which states that an object will continue moving with a constant velocity along a straight path unless acted upon by a net external force. This means that the space station will move along a straight path if it weren't for one key external force acting on Earth's gravitational pull. Another name for this external force is centripetal force. A centripetal force is any net force that keeps an object moving along a circular path. Gravity, in this case, is a centripetal force because it is the force that is keeping our space station moving in its circular path around. Gravity, in this case, is a centripetal force. All right, here's our example. We have Aki here that has an object tied to a string. It's just a yo-yo. It's an object on the end of a string. He's going to whirl this object around, attached to the string, so that it's moving in a circular path. The string in this demonstration provides a force of tension, which is the centripetal force keeping the yo-yo revolving around Aki's hand. This demonstration provides a force of tension. It's important to note that centripetal means center-seeking, therefore a centripetal force is a center-seeking force. Centripetal force is always directed inward, toward the center or axis of revolution. This is because it's the force of tension from the string pulling inward that keeps the yo-yo revolving around the axis of revolution. Now Aki's going to set the object moving in the circular path free and remove that centripetal force by releasing the string. As you saw, once the tension from the string or centripetal force was removed, the object continues to follow Newton's first law of motion. As you saw, it keeps moving at a constant velocity along a straight path relative to the space station. Can you think of other examples of centripetal forces back on Earth? To learn more about centripetal force, use a corresponding classroom connection. Can you think of other to conduct your own experiment to discover other ways centripetal forces play out in your everyday life. Thanks for exploring some physics with me today. See you again soon. Other ways centripetal forces play out in your everyday life. Thanks for exploring some physics with me today. See you again soon. Other ways centripetal forces play out in your everyday life. Thanks for exploring some physics with me today. See you again soon.
Hello, my name is Megan MacArthur.
My name is Shane Kimbrough. We are living and working aboard the International Space Station, orbiting 250 miles above your head. Here on station, we live in a microgravity environment, which allows us to experiment with weightlessness and push the boundaries of science. Here on station,
Today, we will demonstrate moment of inertia by first using a large flashlight, then demonstrating it with the human body. Are you ready? Let's go check it out. We'll demonstrate moment of inertia is the tendency of an object to resist change in its current state of motion. Are you ready? That might sound familiar, since Newton's first law of motion is also referred to as the law of inertia. Moment of inertia, on the other hand, describes an object's tendency to resist rotational acceleration. An object's moment of inertia is a property that depends on how mass is distributed around its axis of rotation. There is a relationship between an object's mass distribution and how easily it spins or resists spinning. In general, objects have a lower moment of inertia and are easier to spin if the mass is closer to the axis of rotation. In general, as you can see, the flashlight rotating about its longer axis is spinning at a faster rate than the flashlight rotating about its shorter axis. This is because its mass is closer to the axis of rotation. The spinning flashlight in this position has a lower moment of inertia, which means there is less resistance to rotation. When the flashlight is spun about its shorter axis, its mass is spread further away from the axis of rotation. In this position, the flashlight has a higher moment of inertia. Now let's see if this applies to humans as well.
Notice how fast Megan is spinning in relation to her body's position. When her arms are tucked in tightly next to her body, her moment of inertia decreases, which causes her to spin faster. When her arms are extended out, more mass is pulled further away from the axis of rotation, which increases her moment of inertia and causes her to spin slower. This happens because redistributing our mass changes our moment of inertia, which in turn changes how fast we spin. It causes her to spin slower. Thanks for coming aboard and watching our demonstration today. To explore more on the moment of inertia, check out the Classroom Connection lesson that goes along with this video. Discover many other lessons and activities at the STEM on Station website. See you next time. Lesson that goes along with this video. Discover many other lessons and activities at the STEM on Station website. See you next time. Lesson that goes along with this video. Discover many other lessons and activities at the STEM on Station website. See you next time. Lesson that goes along with this video. Discover many other lessons and activities at the STEM on Station website. See you next time. Thanks for this video. Discover many other lessons and activities at the STEM on Station website. See you next time.
It's a new era of pioneers, star sailors, thinkers, and adventurers. Era of pioneers, star sailors, thinkers, and adventurers. Era of pioneers, star sailors, thinkers, and adventurers.
We have been given the scientific knowledge, the technical ability, and the material to pursue the exploration of the universe. We have been given the scientific knowledge, the technical ability, and the material to pursue the exploration of the universe. We have been given the scientific knowledge, the technical ability, and the material to pursue the exploration of the universe. We have been given the scientific knowledge, the technical ability, and the material to pursue the exploration of the universe.
No matter how good a story you tell, people are captivated by real-world accomplishment. I ask myself, have I done all that I can for my country and for my family?
As the first Black American to be on the International Space Station for a long duration of time. How do you think of those space station shoulders being long duration?
Your mom and I talked a lot about what this was going to be like.
I was scared for you. Were you ever scared? There's always the what if.
Your mom and I talked. I have fantasized about stepping on the moon. It's my dream. My dream is to walk on the surface of the moon. And being able to launch humans from American soil is my very big part of this dream. On the surface. And being able to launch humans from American soil is my very big part of this dream. On the surface. And being able to launch humans from American soil is my very big part of this dream.
He's a naval aviator and test pilot that's flown over 40 different aircraft. Your Artemis II pilot, Victor Glover, that's flown over 40
I'm looking forward to whatever facet this Artemis 2 takes in. I'm Victor Glover, NASA astronaut, Navy commander, husband, father, big brother, and son. Artemis 2 takes in. I'm Victor Glover, NASA astronaut, Navy commander, husband, father, big brother, and son. The benefits of the Artemis program are technological, but they're also cultural. The benefits of the Artemis program, what really means something to me, is the inspiration that will come from it. But they're also inspiring future generations to reach for them, literally to reach for what really means.
That baton has been passed generation to generation, and from crew member to crew member. I think I speak for all of us. I want to thank our families for the amazing support. It's your love and support that has made this journey possible. I think I speak for all of us. I want to thank our families for the amazing support. It's your love and support that has made this journey
definitely
possible.
important. I'm not an adrenaline junkie or looking for extreme experiences out in my real life, because my work life is so chock full of those things. And I like to just sit or read a book and have quiet moments and spend time with my kids. My work life is having been in the Navy for 22 years, it's definitely been a family adventure. I've deployed several times in the Navy on an aircraft carrier, and we had kids every time, a different amount of kids each time. Spending time with my family is the most enjoyable thing. And we had kids every time, a different amount of kids each time.
What inspired my parents? I was born on a wedlock. I didn't live with my mom and my dad at the same time, but they both cared about me becoming the best person I could, mentally, physically, and spiritually.
I was in 5th grade, and we had a program called MESA, Mathematics, Engineering, and Science Achievement. What got me into it was building cars powered by a mousetrap, building bridges out of popsicle sticks and balsa wood. What got me into it, but our advisor, his name was Mr. Harper, and he said to me, building bridges out of popsicle sticks and balsa wood, if you work hard, you would be a great engineer. And he said to me, his belief in me made me think that I could work hard, you would be a great.
I'm 45 now. I've got 3 engineering degrees because of Mr. Hargrove telling me that in 5th grade. I still find myself showing I've got 3 engineering degrees because astronaut was not even on my radar. I just thought to myself, I want to drive that thing. I want to drive that thing. Astronaut was not even on my radar. I just thought to myself.
I went to college, was fortunate to wrestle in college while pursuing my engineering education, and so that experience, I went to college, what I thought I wanted to do as a professional. I really enjoyed engineering academically, but I wasn't sure I was ready to just work on design. I wanted to use those designs, and so being an operator and being out and doing things was important to me. I wasn't sure I was
and one of my mentors, I'm in his office waiting for him to come in. He's one of the few black faculty members at the university. He comes into the room, and as he steps in, he is in this full regalia, the black suit with the gold around the wrist and the hat and everything. And I was like, wow, sir, when did you enlist? And he said, I'm actually an officer in the Navy Reserve. The black suit with the gold around the wrist and the hat. The next version of what I could become. And that, to me, was, there's so many lessons I pulled from that, but the power of exposure and seeing yourself as something what I could become. And that, to me, was, there's so many lessons I pulled from that, but the power of exposure and seeing yourself as something what I could become.
My name is Connor Clinsdale. I'm 15 years old. I enjoy aviation and space, and I look forward to being a pilot for NASA one day. I enjoy aviation and space, and this is where I take flight lessons and I get flight hours. People other than my friends don't really know much about what I do. This is where I take flight lessons and I get flight hours.
As much as I grind to train for my missions, I am also looking for my replacement. In order to ensure that I have a replacement, I need to train for my people like Connor. I am also looking for my replacement.
The first time when I met Victor was in October 2015, and I was 7 years old. I think that is really cool that he's going to be on October 21st, missions out to 7 years old in 50 years. I think that is really cool that he's going to be on October 21st, missions out. A few role models in my life are definitely my parents, Charlie Bolden, and Victor Glover. I admire Victor Glover because he's audacious. I think that they're definitely role models for me because they show me that I admire Victor Glover. it's just definitely, I think that they're definitely role models for me. I'll be sure they show me that people who saw it for the first time. And I'll be soloing on my birthday, which is my parents took me to DC to the Boulevard Space Center, where I first saw the Space Shuttle Discovery, and I was really little. I was only about like half the size of I first saw and I asked my parents if I could fly it today. My mom told me that I could definitely fly it one day. And I asked my parents if I could fly it today. My mom told me that I thought to myself, if I learned to fly this plane, surely I can fly the space shuttle one day. I think that is very motivating and motivating to see people who look like you, and it's important for people to see a version of themselves. It's important for people to see a version of themselves.
I joined the Navy in college because of representation, seeing a black reserve officer on my campus, and I'm finishing my combat tour, and I go to test pilot school. I go into test pilot school, seeing a black, we as a class have to go to a conference, and at this conference, finishing my combat tour, speaker is Pam, who is, I believe, the second female shuttle commander class have to go to a conference, and at this conference, she tells the story about we couplings. That's it. They use that. I believe the second
on my command flight, STS-120, we had a problem while we were unfolding the solar array on the International Space Command flight. It ripped STS-120, and it was a very, very serious crisis for the station. The solution was a set of so-called couplings, which were really just a way to stitch up the solar array and make sure that it was structural integrity. And it was an extraordinarily dangerous space flight. It was really the pinnacle of experience and make sure that
and she tells that story, and that's the bad
an extraordinarily dangerous space flight. It was really the pinnacle of experience. We'll never forget my first meeting with Victor. He introduced himself to me. He told me about hearing the story of couplings. He just had this extraordinarily thoughtful approach to things. In about 3 minutes, I had it figured out that this was somebody who was probably going to be this extraordinarily thoughtful approach to things. In about 3 minutes,
today, I'm pleased to announce that NASA has selected America's next generation of space explorers. Women and men who are committed to ensuring that our nation leads the world like America's next generation of space explorers. Women and men.
I was sitting at my desk in the Russell Senate Office building when I worked for John McCain. And I got a phone call from a Houston phone number, and I grabbed my cell phone and ran out in the hallway. By the time I answered, I missed it. And so I called back, and I was transferred to Jim Cavani, who was the chair of our board, and she asked me if I wanted to come to Houston. And so I called
These new astronauts we are introducing today will help us to continue to lead the world in exploration. These new astronauts we are introducing today will help us to continue to lead the world in exploration. These new astronauts we are introducing today will help us to continue to lead the world in exploration.
All right, that's great. And you notice, NASA did something for the first time when they picked our class.
Our leadership decided generations ago that we were going to make an effort to make our science and technology workforce and our astronaut corps look like America. If you just look at the picture, it doesn't look like it did when we started the Mercury 7. We're essentially all the same America. If you look at my class, there were 4 men and 4 women. Never before done and hasn't been since repeated. If you look at my class, there were 4 men and 4 women. Training for your first mission. There's the basic competencies, I guess, flying T-38s, the high-performance jet flying that we do, the NDL training, the diving, and the full-pressure suit, the spacesuit, to train for spacewalks. I guess, flying T-38s, the high-performance
As I've got to know Victor, he's an extraordinary pilot. He's enormously technically competent, but also he takes that leadership aspect, that teamwork aspect, so much to heart. Technically competent,
I'm very glad
he takes that leadership
as a career, but the other thing I love
so much to heart.
Being in a classroom is one of the most meaningful things I've ever done, even to this day.
I just find myself, being in a classroom is one of the most meaningful things I've ever done, even to this day. Some gets too difficult, kind of like almost giving up.
One thing I think about is also one of the power of the March on Washington with Jobs and Freedom. They had and also Native Power. There was a party making sandwiches, and then there was like with Jobs and Freedom that took the time. They had, and then there was 50 Native Powers directly. There was a party making sandwiches, and then all that Jobs and Freedom that took the time. And then there was 50. And when you think about that, our legacy comes from the very right now. It's your job to choose. And sometimes when you think about the black people, it's also our legacy comes from the very like you're not always going to be somebody here to cheer you. So one, that's one of the important parts of learning, getting around groups of people like this that are diverse. You learn. You're not always going to be somebody here to cheer you. So one, that's one of the important parts of learning, getting around.
I am surrounded by love and support, and it's humbling and overwhelming sometimes. Surrounded by I'm a father to 4 beautiful daughters, and even with a military career and being deployed, and one thing that goes through my mind constantly at the end of the day is knowing that my wife and my children are military career and being deployed, and one thing that goes through my mind constantly at the end of the day is knowing that my wife and my children are military
today are flying on a 6-month mission to the International Space Station. Shannon Walker and Susan Glover will be the first black astronaut to fly on a commercial spacecraft and the first black long-duration crew member to live aboard the International Space Station.
When I got assigned, my wife and I were actually on vacation, and we had some time to just talk about what this meant for our family and what it meant for us individually.
Outside the ONC building, we have friends and family gathered there for final goodbyes prior to liftoff.
And what it meant for us individually. This is, I think, what a lot of the folks that go to test pilot school dream of doing. There aren't many opportunities to work in new space. I think what a lot of the folks that go to test pilot school dream of doing, there aren't many opportunities. My overriding thought, I think what when I envision us getting to that point, dream of doing, don't screw it up. Many opportunities. My overriding thought.
It's one thing to know something intellectually, but another thing to feel in your bones. That 10 is my overriding thought. It's one thing to know something intellectually, but this is really about that. I'm leaving 10, y'all. And it just got to be crazy. This is really about I'm leaving 10, y'all.
Not even gravity contains humanity when we explore as one for all. And resilience rises. Not even gravity contains humanity when we explore as one for all.
The video just doesn't do it justice. It is pretty amazing though. The video just doesn't do it justice. It is pretty amazing though.
We have one member of our crew who does not have the appropriate accoutrement for his uniform, and so it's for a member to be able to get Victor Glover, who is gold astronaut 10 passing for his uniform, and so it's 100 kilometers. Congratulations. To get Victor Glover, who is gold astronaut 10.
Let us know if you are go or approach to and dock it. And there they are, first across the hatch, my captain. And here's Victor Glover. And there they are, first across the hatch, my captain. And here's Victor Glover.
To register.
And there they are, first across the hatch, my captain.
I was scared for you.
And here's
I'm scared.
Victor Glover.
Were you ever scared?
Well, scared is the wrong word to use. I have a respect for these things.
I was scared for you. I'm scared.
Your whole life, scared is flown high-performance aircraft, deployed on ships, and those all have dangers, risks associated with them. It makes me want to work very hard because I want to come back home to deploy on ships, and those all
you told us about
dangers,
launching
risks associated with
a different aircraft, and it exploded. And that terrified me. I learned that different people train for this stuff, and they're there to make sure that doesn't happen, and that made me feel much better. But you know, there's always the what if people train for this stuff, and they're there
for the things that I do and the risks that come with it. The thing that I had the most discomfort or the biggest emotional response to was leaving. The thing that I had the most discomfort or the biggest emotional response to was leaving Syncom. The thing that I had the most discomfort or the biggest emotional response to was leaving Syncom.
There was a lot that happened in the country while I was in space. The trial of the officers that murdered George Floyd that happened in the country while I was in space. I actually took something really special with me, a painting of George Floyd that a friend of a friend made. A vaccine for COVID-19 was developed with me, a painting of what happened on Capitol Hill. I was in space during that time. A vaccine.
One of the most amazing things about his mission was that Stephanie organized those Zoom calls for us, all the black astronauts, to talk to Victor.
Staying connected with things here on Earth is very important.
We have all these things we were thinking about not on the planet, but having a connection with our brothers and family and people help us all get through the things we were thinking about not on the planet, but having a connection with our brothers and family and people
rally together.
help us all get through the things we were thinking about not on the planet.
They called my family, they called my wife to check on the kid together, just knowing that they were checking on my family, what matters the most. They called my family, they called
my goal in this entire endeavor was to make sure that it continued to be a family adventure, that they look back on this time with fondness and not as that, hey, that was that stressful period where Dad was gone a lot. That it continued to be a family adventure, that they look back on this time with fondness and not as that. Flying the spaceship is one piece. There's also the very important mission of being on the International Space Station. We will conduct spacewalks to upgrade and keep the space station flying and healthy. We will do maintenance inside to keep the space station running. We will use that orbiting laboratory to conduct science, or really to do the hands-on part of the science experiments that happen on space station. Use that orbiting laboratory to conduct science, or really to do the hands-on part of the science experiments that happen on space station.
All gather around the table. We float around the table and pass food and snacks and tell stories about what worked, what didn't work, and talk about each other's all gather around the table. We float around.
What did you think about our video conference? Remember what we did for most of them?
Yeah. Charades.
I never felt like I had to go. Come on, guys. What did you think about it? Dad's calling from space. Because at some point, right, even it's still neat that Dad's calling from space, but like after 167 days. Come on, guys. What did you think about Dad's calling from space?
I don't think it was ever like that. It's like major. Like, I want to go because you made a great impression the first time you played when you did Escalator.
That was my highlight. My charades Escalator was
because you could just float.
Weightlessness. Sorry, I mean, it was good.
We got it right away.
My charades Escalator was
because you could just float.
Weightlessness. Sorry, I mean, it was good.
Victor, can you see me? Can you hear me? It's Vice President Kamala Harris calling from the White House.
Madam Vice President, welcome to the International Space Station.
Can you hear me? It's Vice President Kamala Harris calling from the White House. I understand you recently got some fresh air because you went on a spacewalk outside of the space station first time. What was that fresh air?
One of my colleagues said to me to keep your world small, to focus on the thing right in front of you, and then slowly widen out that world view. One of my colleagues said to me to keep your world small, to focus on the thing right in front of you.
Being able to really just stare out into space, like 13 billion light years across. That sounds big, but when you look and you can actually see down at the Earth, the sun comes up and you can see that beautiful color band of atmosphere, and it's really small, and you can see the Earth in curvature, 8,000 miles across, and then you look out there and that sun that I can feel warming my whole suit up, and you can see there's just one of all of these things out there, those stars, and then you look out there and it just really creates this, wow, you can see there's just one of all of these things out there, those stars,
think about
it just really creates this,
as first Black American, first African American, as being on the International Space Station, as long-duration Black American. I want to ask you, how do you think of those so long-duration Black American?
I think about that piece often. Every astronaut or cosmonaut has ever done has led to us being here now, in this special time. I think about that piece. I really appreciate that legacy, and I try to work my hardest to honor it. Ever done has led to us being here now, in this special time. I really appreciate that legacy. legacy, and really what I'm most excited about is the future of human spaceflight and the fact that this is going to be the future. Really what I'm most excited about is the future of human spaceflight and the fact that this is going to be the future.
He was but they just first got interested in space. He was a costume called his uniform.
I think that every parent feels in some shape, form, or fashion that their child could potentially change the world. I think that really every parent feels in some shape, form, or fashion intent that their child could potentially change the world. I think that we started having conversations about the vastness of the universe and the vastness of space. And when my husband pointed to the moon and told Connor that there were actually footprints there, and the vastness of space. And when Connor's response was, "How do I?" and told Connor that there were actually footprints there.
My family has always supported what I wanted to do. They've always supported my dreams and what I wanted to do. My family has always supported what I wanted to do. They've always supported my dreams and what I wanted to do. One reason that I really love flying is because of the overall experience. The reason that is really cool is because it's really cool to see something from like a bird's eye view. The reason that is
he doesn't even think about like the impact that he has
from like a bird's eye view.
He doesn't even think about like the impact that he has.
When I was on the stage with Victor Glover, I really felt out of my space because there were a bunch of really cool, really accomplished astronauts that are really out of space. Because there were a bunch of really
Connor wants to be an astronaut, but I'm going to do everything on my power to make sure that he becomes it.
It's really
Connor wants to be an astronaut, but I'm going to do everything on my power to make sure that
inspire others. It's really
Connor wants to be an astronaut, but I'm going to do everything on my power to make sure that
inspire others.
One of the most important things to your ability to achieve success is your understanding. One of the most important things to your ability to achieve success is your understanding and definition of what success is. So number one is to be gritty. G-R-I-T-T-Y. To be gritty means not quit. And the greatest challenges you'll ever experience are from within. So number one is to control these challenges. External challenges are no big means not quit. Number two, be a lifelong learner. Learning inside and outside the classroom, your ability to acquire skills is the thing that really is going to be so valuable to you in the future. The last one is to be a good teammate. Your ability to your left and your right is to take the focus off of yourself. I think this job highlights something that maybe several people deal with. I've dealt with throughout my 22 years serving our country. And there's this job terms, I think, in psychology or sociology called imposter syndrome and survivors in our country. And being selected for this job, these terms, I can't help but to think of, I've got so many friends that I know could do this job. And that feeling of, wow, why didn't they get it? And why they picked me? That's the survivor's guilt piece. And imposter syndrome is just, why didn't I not get good enough cut out for the job? And I felt horrible. Why they picked me? That's the survivor's guilt. And I would say that that doubt, being a father, a husband, all of those things come with doubt. And my life hasn't been about trying to get rid of it. It's just trying to get comfortable with it and being able to still take one step at a time and be prepared for whatever's coming out. Because anything you practice is just trying to go comfortable with it. I think you have to being able to still take one step at a time and be prepared for whatever's coming out. Because anything you practice. So I think it is an incredible honor to just be a part of this legacy. I think it is an incredible honor that next chapter, that continuation, that continuous human presence, and that is an amazing responsibility. I think it is an incredible honor that next chapter, that continuation, that continuous human presence, and that is an amazing responsibility. Pushing ourselves to explore is just core to who we are. Pushing ourselves to explore is just core to who we are. Pushing ourselves to explore is just core to who we are.
We all share the same goal of achieving what we want in life. To any young people that dream of accomplishing their goals, I would tell them this: never give up, because God always has something in store for you. And to dream big, you can definitely dream bigger. Accomplishing their goals, I would tell them this: never give up, because God always has something in store for you. And to dream big, you can definitely dream bigger. Accomplishing their goals, I would tell them this: never give up, because God always has something in store for you. And to dream big, you can definitely dream bigger. Accomplishing their goals, I would tell them this:
I watched our astronauts up in the space station on YouTube, how they function in zero G to try to mirror something. The Peter Pan production, where you're hanging some wires. So basically what they did with me was just strap me up to the ceiling and then have me spin until I got nauseous to find out where that threshold was with me, so we wouldn't be doing that on set every time. Ceiling and then space spin until I got nauseous to find out where that threshold was with me, so we wouldn't be doing that. Well, it's supposed to be Armstrong, so good luck. Everything. I can't. Well, it's supposed to be Armstrong, so good luck. Settle with the moon right now. I'm older, I don't want to be gone that long. I like my comfort. I'm going moon. Settle with the moon right now. I'm older, I don't want to be gone that long. If I don't moon, I get one item to take with me, I'm taking my music. Settle with the moon. Period. I'm older, I don't want to be gone that long. If I don't moon, I get one item to take with me, I'm taking my music. Space is so fascinating, certainly for cinema. Because it's so unknown. I think so much we don't know. So fascinating. It's certainly for one, our universe has ever expanded. So unknown. I think so much we don't know. These are concepts already that are beyond our understanding. It's wide open. Our universe has ever expanded. Great unknown. How we define us and how we define ourselves beyond our understanding. That makes it wide so right. Our universe story expanded. Great unknown. How we're defining us. Hey, I've got to define ourselves, if I may. So first question I was wondering, when are we going back to the moon? Hey, I've got to Really? First question I was wondering, I heard this room. When are we going back to the moon? Something about water being on the moon. Could that possibly be? I heard this room.
Thanks, Brad. We'll answer these questions and more in our new series, Ask NASA. If you have questions like Brad, use the hashtag We'll Answer These Questions and more in our new series, Ask NASA. If you have questions like Brad, use the hashtag We'll Answer These Questions and more in our new series.
NASA celebrates LGBTQ plus Pride Month.
Use the hashtag We'll Answer These Questions and more in our new series.
NASA celebrates LGBTQ plus Pride Month.
Use the hashtag We'll Answer These Questions.
NASA celebrates LGBTQ plus Pride Month.
So it's Monday the 9th of January 2023 and I'm on my way to the University of Leicester first thing in the morning. So it's all over the weekend the James Webb Space Telescope and the Hubble Space Telescope have been observing the planet Uranus in the morning. Now this is a really exciting moment. This is the first time we've turned the telescope and been observing target. It's a real test. This is a really of capabilities. This is the first telescope we've turned the telescope and been observing target. It's a real test. This is a really of capabilities. This is the first telescope we've turned the telescope and been observing target. It's a real test. This is a really of capabilities. This is the first telescope we've turned the telescope and been observing target. It's a real test. This is a really of capabilities. This is the first telescope we've turned the telescope.
So I'm hoping there'll be a nice little show and tell.
And my emails have been trickling in, even as I've been walking, telling me that more data is available on the archive for me to go and take a look at. So it's going to be a very busy day. I've been walking, telling me that more data is available on the archive for me to go and take a look at.
This is our first glimpse of what the data is.
Very busy day.
Longer wavelengths will get better. There we go. That is Uranus. This is our first glimpse of black. And actually, wavelengths are pretty much. That is Uranus. All of these lines, they're real. They are uranium spectrum, ethane and acetylene. All of these lines, they're real. Uranium spectrum, ethane and acetylene. There we go. Good morning. I understand right and early here in Seattle. Good morning.
Yes.
Good morning.
What wavelength is it? Look at the spectrum. What wavelength is it?
We'll be seeing glimpses of the rings of this data. There we go. Even better. The rings around Uranus and glimpses of the rings. So, this is our first glimpse of the data. Even better. The rings around Uranus.
It is just fantastic to see this.
This is our first glimpse of the data.
It's been a long time coming, but every moment of the 25 years that we've had has come to fruition with this amazing data set. Thank you to you and your team for spearheading this amazing proposal together. Thank you, Nation, and your team. Data, spearheading this. I agree with you. This is going to fundamentally change our understanding of Uranus. And then when we get Neptune data, it's going to be a fundamental Einstein paradigm shift of Uranus. And then when we get Neptune data, it's going to be a fundamental Einstein paradigm shift.
My name is Heidi Hamill, and I am one of the 6 interdisciplinary scientists for James Webb Space Telescope. I started working on JWST, and I am one of the 6 interdisciplinary scientists for James Webb Space 25 years ago. I started working on NASA project, and I am one of the next generation scientists for James Webb. And so I became involved in the project because I wanted to be able to use this fantastic asset to study objects within our solar system. So I became involved, and that's challenging because they're bright and they move quickly through the sky, our planetary, our solar system. So that's my role with the JWST project for the last 20 plus years has been to ensure it did have the capability to observe bright objects, the JWST project. And NASA's been exploring the solar system for many decades, since before I was even born. I don't think I can capture every single mission that's launched and explored, but many decades highlights. We started with the moon. I don't think I can capture every single mission that's launched and explored, them many decades highlights they were getting into. We also, in the early years, sent spacecraft to the moon. Many missions to Mars, starting with the Mariners, and then also in the early years, we've since sent orbiters, many missions, rovers, starting from Spirit, Opportunity, Curiosity, and most recently, Perseverance, and even a little helicopter at Mars, Ingenuity. Interestingly, when we've been studying these large worlds, Jupiter and Saturn, we have found that even a little helicopter at Mars, Ingenuity, as the planet itself. We had the Uranus flyby in 1986 with Voyager 2. We had the Neptune flyby with Voyager 2 in 1989. Right now, outer planets in our solar system, Uranus and Neptune, are the least explored planets in our solar system. Right now, one of the things that I had learned in the Uranus and Voyager, when we continued to study Uranus and Neptune with newer ground-based telescopes, and the Hubble Space Telescope, after it had its service, and continued to study Uranus and Neptune with newer ground-based telescopes, and the Hubble Space Telescope, after it had its service, and continued to study Uranus and Neptune with newer ground-based. What I learned is that these planets change. what I learned is that and that what Voyager saw was a snapshot in time. But planets today don't look like that. And that what Voyager saw was I use the analogy that it's like if I showed you a picture of me in 1986, that's not how I look today, right? I've changed. And so using only the Voyager data doesn't give us this accurate. That's not how I look today, right? I've changed. And so you need to continue observing them with ever more powerful tools until we get a new mission there. That has only intensified over the years. Continue observing them with ever more powerful tools until we get a new mission there. That has
Good evening. Welcome to the Space Telescope Science Institute in Baltimore. I'm Don Savage, Public Affairs Officer for NASA's Office of Space Science. This evening, we're pleased to announce the start of a week-long campaign of observations of the impact of periodic comet Shoemaker-Levy 9 with Jupiter. The impact of the first fragment occurred earlier this afternoon at about 3:54, and scientists around the world participating in the NASA National Science Foundation's joint campaign, as well as virtually every other telescope and observatory around the world have been watching the National Science Foundation's joint campaign, as well as virtually every other telescope.
For the impact of Shoemaker-Levy 9, my team and I were set up in the Institute, Space Telescope Science, and for the actual event of the first impact, we were down in the basement where they had computer screens where the technicians normally check the data to make sure every actual event. Normally, astronomers are not allowed in where they had computer screens where the technicians. So we were all crowded in there, waiting to see the first impact. Astronomers are not allowed in where they had. When the first images came, it was pandemonium. So we were all crowded in there. What is this? Waiting, could this be a moon? Is this a real planet? What is it? Get it on the next. Check where Io is. Pandemonium. So we were all crowded. What is this? Waiting, could this be a moon? Is this a real planet? What is it? Get it on the next. Check where Io is. That one looks pretty good. And then when the first image of the impact site came up, we were like, holy smokes. There's video of me like pointing at the screen. Everyone around us, image of the impact site came up, we were like, holy smokes. There's video of me like pointing at the screen. Everyone around us, right in the middle. That's amazing. That's way awesome. There's video of me like pointing at the screen. At that time, there was a little tiny computer monitor up above the big screen showing Jupiter. And we could see the press conference. That was happening one floor up in the auditorium. And Gene Shoemaker, Carolyn Shoemaker, and David Levy were sitting there, not knowing that one floor beneath them, everything was happening. David Levy were sitting there, not knowing that one floor beneath them, everything was happening. Sitting there, and so I said, we have to break it. I say, this is a formal message. We can't break it. That we're going out. And so I said, we have to break it. So I said, get me a computer printout, right? Anything. It's like this thermal paper. We're going out talking about it. Like that's sort of thermal paper. But you could see Jupiter and computer printout, like anything. And I said, we're going up. The PV crew was like, she's going up. She's going up, thermal paper. But you could see Jupiter and computer printout. And I said, we're going up. It's not fair. But they didn't know what was happening. But you could see Jupiter and computer printout.
I think we may have some up-to-date. Right?
Introduce Dr. Heidi Hemmel.
Gene Shoemaker said he would be personally astonished if we saw nothing. Well, if we didn't see something. Gene Shoemaker said he would be personally astonished. We actually saw some amazing things. Well, if we didn't see something. We just downloaded the first two orbits. In the first orbit, we were able to see a plume on the edge of the planet. We just downloaded the second orbit, which I have a raw laser printer output to see as it gets. planet, we can actually see the impact site itself. And I'll remind you, this is for A, the first one, not the brightest one. So we're going to have a really exciting week.
Why be dull and boring about it, right? Let's have some spectacle. Let's have fun.
So we're going to have a really exciting
That was sort of my whole presentation stuff. Because we have conferences every day. We're like, what are you seeing today? We're like, who knows? You know, it's going to be the big one hitting tomorrow. What is that going to be? Because we have conferences big black eye. What are you seeing today? We're like, the impact of Comet 249 into Jupiter back in 1994 was a game changer to actually see an explosion taking place on the planet Jupiter was a game with the Hubble Space Telescope and with other ground-based telescopes really changed our perception of how planet changing some of these large impacts truly were. All of these places that we have visited with spacecraft, we are really limited in what we can do with our ground-based telescopes. But now, with Hubble and now the James Webb Space Telescope, we are getting new views of all of these places to supplement and complement the results we've gotten from the telescope. Myriad missions of all of these places to supplement and complement the results we've gotten from the telescope. Myriad missions. Future-proofing JWST is not a problem because what we set out to do was so ambitious that even over a quarter century it took to build this thing, what we set out to do, we've never built anything to surpass it. That even over a quarter century, the images came out, wow, it's happening. We've never built anything to surpass it. That even over a quarter century, the images came out, wow, it's happening. We've never built anything.
Along the way, unfolding itself, deploying a mirror, 21 feet wide, a sun shield the size of a tennis court, and 250,000 tiny shutters, each one smaller than a grain of sand.
So we can look at everything in the solar system that's not too close to the sun, because we have a sunshade, an umbrella to protect us, but they only protect us so we don't look too close to the solar system. So all of the planets move around in the sky rather quickly, but all of them from Mars on outwards sometimes are in the zone where they're far enough from the sun that we can see the planets move around in the sky rather quickly, and outwards from Mars on outwards
JWST looks in infrared, which is kind of like looking at heat. You can do cool things by looking at heat instead of looking like infrared, which is dust and gas of nebulas and look cool things where by looking at heat instead of looking like the solar system around the stars, dust and gas of nebulas.
The reason we wanted to use JWST to study objects in our solar system is that we knew this telescope would have JWST to study objects in our solar system that is that very stable image quality and stable photometric quality. And those are things we look at that very because they allow us to get higher precision on the objects we're studying. And those now in our solar system we do send spacecraft to some objects, but we don't send spacecraft everywhere. And so the places that we don't send now in our solar system we do send spacecraft telescopes to study. And having access to the best telescope that we can build, which is what we anticipated JWST. And that allowed us to dream and plan and think about what we would build from your facility in JWST. And that allowed us to dream.
Two basic capabilities. One is one is stretch out the light of an object into a rainbow. See how bright is it? Basic capability. But one is so that's really important for us to do the chemical analysis, the physical analysis of what's in the object. How bright is it? Basic capability. One is so that's really important for us to do the chemical analysis.
I always start by explaining what spectroscopy is because I call it JWST. All spectra are so fabulous that when you get get a group of scientists together, show them the brand new JWST stuff, and what makes the audience gasp when you get a group of scientists together, show them the brand new JWST stuff, and what makes the lines are so beautifully resolved, the sensitivity is so amazing. You're just so molecules.
We never get to print a picture of a spectrum in the newspaper because it's too abstract for people, but it's the thing that astronomers use to know what's going on inside those things that we find.
As a chemist, I can tell you the spectroscopy is the best part about the Yes, we're getting fantastic images, but even the distant galaxy spectroscopy is the best part. First galaxies of the universe, yes, we're getting fantastic images, but the images even the distant galaxy spectroscopy is the best. Without seeing galaxies of the universe, yes, can't confirm the distance of an object, even the pristine nature of our galaxies of the universe, yes, can't confirm. I'm Stephanie Milam. I'm the JWST Deputy Project Scientist for Planetary Science. I decided to become a scientist when I was actually very young. Stephanie Milam. I grew up in Houston, Texas, and I went on a field trip down to Johnson Space Center when I was about 6 years old. I came home just absolutely elated, and I told my mom, when I grow up, one day I'm a scientist, I'm going to work for NASA. I came home, pretty much everything I've done since that. I told my mom, when I grow up, I plan to become a scientist and work for NASA. I came home, pretty much everything I've done since that. I knew that I wanted, to become a mission specialist, so I needed to pursue a PhD, but at the time I was working in an environmental laboratory, basically washing glassware for a living, so I needed to get myself through school. And I knew that I couldn't spend the rest of my life doing basically washing glassware for a living. How can I become a chemist and not have to deal with wet chemistry ever again? She knew I had a passion for astronomy and not have to deal with wet chemistry. And that was sort of the turning point. My laboratory went from astronomy, a room, to now the entire universe studying. That was sort of the turning point. My laboratory went from astronomy, a room, to now the entire universe studying. That was sort of the turning point. If you would have asked me when I was an undergrad in Kansas whether or not I would be working on the largest astrophysics mission NASA's ever had, me when I was an undergrad, I would have never imagined whether or not I would be working on the largest astrophysics mission NASA's ever had. Me when I was an undergrad, I would have never imagined whether or not I would be working on the largest.
The way the program worked for those of us who were interior to the program, as part of accepting that work with NASA, we were given guaranteed time for those of us on this new telescope, especially in the first cycle. And so I knew I had 100 hours of guaranteed time that I was planning to use for solar system in the first cycle. And so I knew I had 100 hours of guaranteed time that I was.
Heidi came to me and she said, I really want my time to my projects to go to the solar system community so that they have this data. I really want my cycles and they really see what we can do to go to the solar system community so that they have this data.
Ask them, what do you think what would be challenging? And we invited them to send little tiny mini proposals to me and to my team.
And so we had a couple of conversations about what that program would look like, and she wanted to cover the entire system with her time. And so we had a couple of we broke up her time for all of the different planets that we can observe with JWST. So Mars on Earth, near Earth asteroids, comets, some of the main features of things like the Great Red Spot, Uranus, Neptune, the outer solar system, all these things. We decided that we needed to have like the Great Red Spot, Uranus, Neptune, the outer solar system. We needed somebody that would be responsible for making sure the observations were planned to delivered to the data system. We needed somebody. The best part of Heidi's entire program is it's very international planned, and that just goes to show how international this project is, how international it is for astronomy, for planetary science. We aren't just one small niche group. We aren't 2 or 3 people sitting in a room that are the experts in the field. It takes this whole team. We aren't a lot of that one small niche group. Different narratives, many different backgrounds, and all of that helps feed in, and it takes the information that we need to really get a grip on what different data is telling us. We need to learn something about the solar system. That helps feed in, and it takes the information that we need to really get a grip on what different data is telling us. We need to learn something about the solar system. That helps feed in.
So one of the things we had to decide as a science working group was how fast really were we going to try to push through. So one of the things we had to decide as a science working group was how fast really were we going to. After a lot of dialogue, we decided that the orbit of Mars would be the limiting factor. We looked at how fast Mars moved. We decided that we said, okay, so that's going to be the limiting factor. We looked at how fast that would then be fast enough that it would allow observations of Saturn and Jupiter and Neptune and hyperbolic objects, which all moved. Then NASA had a mission called the DART mission, Double Asteroid Redirect Test, where they crashed a spacecraft into the moon of an asteroid, and they were looking to see if they could move that. Part of the observing we decided to do was try to use into the moon of an asteroid to do that. And they were looking. The challenge was that asteroid system, the moon, was actually going 10 times faster than the upper limit we had all agreed to in the development of JWST. Huge thanks to the engineers and operating team for JWST. They were actually able to get the telescope to track fast enough to do that asteroid test. We did get some fabulous observations to get the telescope to track fast enough to do that asteroid test. We did get some fabulous observations to get.
So with Webb, we get to see things that we cannot at the present day see from Earth. Primarily that's because of the Earth's atmosphere. We cannot see through the Earth's atmosphere at some frequencies of light. Webb gives us the ability to go into space and to look at objects that would otherwise at some frequencies of light. In particular, that's really important for molecular astronomy. To look at objects and see the molecules in the atmosphere, it tells us information about the atmospheric composition, temperature, strong winds. This we work as a team and trying to decipher the puzzle of the atmospheric composition. One of the things we're looking at right now is some of the surface features. Technical Lake's teams and trying to decipher these are seen as methane, quite unlike the things we're looking at right now on Earth surface features, but at the same time with some of the same characteristics in terms of rainfall, rivers, the shorelines we see on Earth. So we're very excited with some of the things to see if they're still the same lakes and rivers, like the same shorelines we see on Earth. So we're very excited with some of the things to see if they're still
we have a lot of stuff going on. We have orbiters and everything. But James Webb can see Mars from the whole side. You can see the whole side of Mars. You can map it. This is something that rarely you can do with an instrument like. But James Webb can see Mars from the whole side, and that has been amazing because now we can map. That's why we are excited about. That's what we are working on right now. But James Webb can see Mars. The same thing we can apply to Europa and Enceladus. Now we can. Enceladus is a relatively small moon compared to Mars, but it's like that. Same thing. Waiting to see little pixels, and then when we point there, we saw a huge field compared to. So I mean, when you see those things that you really get surprised. This cannot be real. And then you go back there data, and then you confirm that it's that. It's a big thing coming out. You really get surprised. This cannot be real. And then you go back there data, and then you confirm.
Some of the data hasn't come yet. I'm still waiting for the Neptune science data. We have a Neptune image that was taken as part of the program to make some beautiful pictures for press releases. And boy, did that whet my appetite for what we will see with the Neptune science pictures for press releases. And boy,
even when we were
that whet my appetite for what
one of our
we will see
commissioning projects was to
with science,
just so we could study scattered light across the instruments. And within a single minute worth of looking at Jupiter, we already knew that we could detect the rings, the satellites, and within a single minute worth of looking at Jupiter, we saw all of that within 1 minute in commissioning the satellites already. And within a single minute worth of looking at Jupiter, we saw all of that within 1 minute in commissioning the satellites already. And within a single minute worth of looking at Jupiter, we saw all of that within 1 minute in commissioning the satellites already. And within a single minute worth of looking at Jupiter, we saw all of that within 1 minute in
NASA celebrates LGBTQ+ Pride Month. NASA celebrates LGBTQ+ Pride Month. NASA celebrates LGBTQ+ Pride Month.
Ever since I can remember, I've been interested in thinking about the stars. Ever since I can remember, I've been interested in thinking about the stars and thinking about the universe and how it's put together. Remember, I've been interested in thinking about as a blind person, my in about or knowing about that was to read science fiction or to watch space documentaries on TV.
You are about to take a journey out of this world.
To read science fiction or to watch space documentaries on TV. A sighted person looks up in the night sky to read around us. There's a visceral connection, I think, that people feel to the universe around us. Sonifications are the way that I get to. For me, sonifications are the way that I get to have that visceral sensory experience of the universe. Life-changing for me. Sonifications are life-changing for me. I get to have that experience of the universe.
Listen to the universe. Data sonification in its simplest form is just the translation of information that to something that we can hear. It's this idea of extrapolating out that information into sound. My name is Kimberly Arcan, and I'm a visualization scientist and emerging tech lead for NASA's Chandra X Observatory. All that means is that I get to take data from our universe and tell a scientific story with it. In this case, I'm sticking with my good friend Cassiopeia A, this beautiful exploded star. And what we've done is we've used the sliced data with the silicon, the sulfur, the calcium, the iron, and the high energy, and mapped each different layer to a different sound, a different tone. We worked with people who are blind or low vision to make sure that they could extrapolate their own meaning. If you are just listening to this object, that the scientific story would still be communicated in a way that made sense and that was also pleasing. And then we test again, because we don't want anything that's going to hurt people's eardrums, not make sense. If it's too fast, for example, if it's too slow. But it is like when you're making images, there's, choices to be made.
Sonification is important because it gives us a different way to experience and perceive information. And in particular, it's very important for people who are blind or visually impaired because it gives them access to information they wouldn't otherwise have. So the idea is to convert relations or features in data into something we can hear, like the changing pitch of a note or the changing volume. It turns out that it's not just people who are blind or visually impaired that find value and meaning in these sonifications. They're popular almost universally with the general public. And perhaps that's because they help people connect something that's far away and unfamiliar in astronomy with something that's deeply personal and emotional, such as music.
So with all of this type of data that we're getting from these various NASA telescopes, we have to translate it from something humans can't easily naturally detect into something we can either see or hear or even perhaps touch. So it's this process of translating information from one form to another. And when we're doing that, we can create a visualization, or we can create a sound, or we can create something that could be 3D printed, for example, so that we could touch it. But it's kind of the idea of, if you're speaking French and you need to translate into Mandarin, you're just taking that information and you're just moving it into another form. So it's just another way of understanding.
For me, the process of getting to know a sonification is it's demanding and rewarding, and it takes time, because instead of just looking at an image and maybe reading a caption and then listening, I want to read through what each sound means. The way the sound is panned gives a lovely sweeping sense that the image is big, or at least what the image is referencing is big. And so this one is very rich. The listening experience, even if you just listen to it not knowing what it was, it's a lovely, lingering, meandering sort of melodic listening experience. And then when you add in the meanings, it becomes so much richer and more meaningful, more important.
Most of what we're looking at in the universe is in a light or a type of light that humans can't naturally detect. I like to think of these telescopes that are up in space as just being, kind of super friends, right, with their various superpowers. And Chandra's superpower is to look at really energetic regions, really hot regions of space. But what's really helpful is to be able to look at the entire universe with a different set of eyes, looking at many different kinds of light. So for example, though Chandra looks in X-ray light, there are other telescopes that look in infrared light, like the James Webb Space Telescope or the recently retired Spitzer Space Telescopes. Hubble looks at optical light and also little bits of ultraviolet and infrared light as well. There are radio telescopes, gamma ray telescopes, and the whole point is you need all of these different kinds of telescopes to be able to fit in the various pieces of the puzzle. The Perseus cluster of galaxies is this beautiful system hundreds of millions of light years away from us, where it's a cluster of galaxies that has a very high-powered supermassive black hole at its core. And what Chandra found back in 2003 was that that black hole is essentially burping out into the hot gas around it. And what that burping into the hot gas is doing is causing pressure waves, which are sound waves.
The image itself shows hot gas glowing around this galaxy cluster. It's not true that there is no sound in space. In some cases, like in this galaxy cluster, there's enough ambient gas surrounding the galaxies that sound can travel through it. And because these ripples are visible in the image, we were able to extract their shape and resynthesize a sound.
The black hole is essentially creating a sound. It is a B-flat about 57 octaves below middle C. So I love to sort of think that there are black holes out there, like these divas in the universe, singing this really, really deep, deep song. Because 57 octaves below middle C is hundreds of keyboards, too low for humans to hear.
So I dug back into the research and I found images showing these ripples much more clearly.
And then I spent a long time learning how to cleanly extract those waves. I knew it was something special.
In a way, it's a very accurate sonification because the sound wave we're recreating came from the black hole.
I did not expect it to go viral at all. We had released it for NASA's Black Hole Week. It was on the news, and that was lovely. And then on a slow news Sunday in August, a colleague at NASA Exoplanets just tweeted about it, and for some reason it just caught on fire. And by the end of it, it was like almost 2 billion people had seen or, come across the story. And that just blew me away.
That was very windy and gusty, and so there was less of a sense of discrete phenomena like stars or galaxies and more of a sense of movement. Because the sound in this is so uncommon that it gave me a little bit of that creepiness where you start to get the sense of your own minuscule tininess when trying to comprehend big, huge forces like that.
It was so exciting that a project that we had started during the pandemic as a way to connect with a community resonated, pun intended, I guess, with a much wider part of our planet.
Nowadays, nature it feels as if all nature serenades with a mystic melody. And then it gets better. The spectacle gets better as I hear how galaxies arch across the celestial dome. What happens is that the information that the satellites gather is light. And usually, people like me who dedicate their lives to physics and astronomy, etc., convert that light, that information gathered by the satellites, into numbers. And those numbers can be converted into a sound.
So I have a very dear friend, Dr. Wanda Diaz. She is an astronomer and a computer scientist, and she's been blind since she was a teenager. She was really my inspiration. That's how I first learned of data sonification. She has told me these stories of how she would be in math class at university and her professor would just be writing equations on a board and she could not access that information. So for her to study the stars, she relies on data sonification so that she can translate that information to something she can hear and therefore process and therefore study. So for her, data sonification is an actual step of scientific research.
Sound effectively increases the sensitivity of people to signal detection. And I think it's crucial that the training begins in school. Let's not leave out people with disabilities.
Even if we're not scientists, I think that curiosity or that awe or that attempt to understand the cosmos and infinite space, I think that's something that all humans have in common. It's kind of like listening to a poem in a language you don't know. Because if you're not a scientist, those concepts are, I won't say foreign, but they're just not in your everyday parlance. They're not things you deal with every day. So it's dense. There's so much to take in.
Worth the effort, though, right?
Yes. Yeah, it's so rewarding.
I first met Matt and Andrew from System Sounds at a visualization conference that we had all attended a couple years before the pandemic, and I really admired their work.
System Sounds is a science art outreach project. So the basic idea is that we take data from space and convert it into music and sound for outreach, to inspire, to educate, and to make space more accessible.
We just decided to work together to try a few of these data sonifications based on Chandra data and to see what happens. Because I really suspected that, with over 2 decades of operation, we have this treasure trove of a data archive with Chandra and with other telescopes from NASA as well. And we just started playing. We started experimenting with translating this information into new sounds, new ways of knowing. So the first time that I heard a completed piece all the way through, it was of the galactic center, this sort of inner 400 light-year region around Sagittarius A star, our very own supermassive black hole. And it's this wonderful, dense, busy, active downtown region of the Milky Way, right? There's exploding stars, there's these X-ray binaries, there are these beautiful loops of material, all these massive stars. There's so much going on. It's kind of like Times Square, right? And I'm so used to that data and understanding it visually that the first time I heard the sound, there were things in the data set that I had never really noticed before.
For the galactic center, we started by looking at what the data looks like, what are the patterns, and the important thing is to find out what's the story we're going to tell. It was a beautiful multi-wavelength image, so it had layers of recorded light, of optical, infrared, and X-ray light all combined into one.
In most cases, the sonification results in music that is not humanly playable by anyone. And so we have to use computers and synthetic instruments to bring this music to life. But there are some examples where we actually do some real recording.
We assign each telescopic instrument to a musical instrument, so they had different qualities of sound.
One very common question I get when talking about the sonification project is from musicians who ask, can we play this data ourselves? So that was the next goal, to get sheet music into the hands of musicians.
I grew up in Toronto, and I've been interested in music for my whole life. I started playing piano when I was like 5 years old. Eventually I went to an arts high school, and that's where I met Matt, who is the other half of System Sounds.
Andrew is by far my longest friend. We met in grade 9 when I was 13. We just happened to sit next to each other in chemistry class, and then we found out we were also in the same music program at our high school. And years later, after high school, we joined the same band with a few other people from that high school. And so we've been creating music together in some form for a very long time.
In 2017, Matt and I converted a musical solar system they had found called TRAPPIST-1.
TRAPPIST-1 is a very exciting system of exoplanets. There are 7 Earth-sized planets, all orbiting a nearby red dwarf star. And this system happens to be the most musical solar system ever found, because these 7 planets are locked in an orbital resonance. So it's like they're playing the same song. They're all locked into a rhythm and playing a certain harmony.
A lot of it's trial and error. You look at what's important to the image, or like what's important to the data. So what's the image about? Is it about how many of something it is, when it happened? We just look at what the story of the image is, find out what sounds can bring that out, and then we just try version after version after version until we get something that represents the data. It sounds like the image looks, but also stands out on its own as a piece of music. I like that one. Yeah, I don't know what they were.
So the first step is I sit down with Andrew and we look at the data or the image, and we think about all the possible different sonification mappings. So we do a lot of sketching and diagrams and really try to do this design stage very slowly and methodically. And then we get into the computer programming, and that can sometimes take a while. From there, we do a bit of music production to put the elements together, and then we send what we have to Kim and also to Christine for their consultation and their feedback.
Christine Malik is amazing. She gives the best feedback we could ask out of anyone. Her insight and her thought process, and just how much she loves space and how much she loves the science behind it. Her feedback really does shape a lot of what we do.
And so what is each layer? There's the...
And it gives us a whole new perspective on anything we make. Yes, we're good. Over there.
South by Southwest was a context I never imagined myself participating in. Kim asked if I would attend also.
It was great to be in the same room as Kim and Christine because, as you know, this project started during COVID, and so the three of us were working mainly remotely, and so we all got to be in the same room, and Andrew as well, the four of us.
Do you always listen to the composite first, or do you like to hear the layers first and then put it together?
I would listen to the composite first, and then definitely the layers. I always listen to each of the layers.
So here we go. The image associated with the Perseus galaxy black hole resembles the view down the center of a purple cotton candy funnel cloud.
Being there as a panel participant was extremely exciting.
People in the blind community have a slightly different experience of these sonifications in that for us it's more directly educational.
So I was super honored. I was very grateful for the opportunity. It was extraordinary.
So I was so much
super honored. I came across the opportunity to experience the work of Matt Russo many years ago. We both live in Toronto, and a local blindness organization was promoting a presentation he was giving on the sonification he had done of the TRAPPIST-1 solar system, and I had never heard of sonifications, so I was eager to go. And he gave a sort of multi-sensory presentation at a local little planetarium, and I was completely blown away. I had goosebumps on my goosebumps. I'll never forget the experience because it was my first direct sensory experience of cosmic phenomenon, and that really got me hooked into how else can me or other members of the blind community experience these phenomena and learn about them more deeply.
In this very modern digital era of astronomy and computer science, binary code is that language that we use to talk to each other. Once we get that binary code, that digital suitcase, it's then unpacked into, say, a table of information. The table of information catalogs the energy, the intensity, all of the location information, the time of every photon, every packet of energy that was captured during the observation. And then from there, it goes down the pipeline to be created into an image, into a sound, into whatnot. Data sonification itself is also not, holding up a big space microphone. It really is just like the image translation part. It is a translation into sound.
One of the most fun steps is that whenever we start a new sonification, I get to kind of put my researcher hat back on. I get to dig into the actual scientific papers and try to understand the scientific story behind the data that I'm looking at or the image that I'm looking at. And so I still get to kind of flex that muscle a little, and that informs our sonification choices.
My feedback is often about, can we make this pitch a bit higher, or can you choose a different instrument, or could it be oriented this way or that way? Or so for me, it's informational. It's about how can the sonification be more of an educational tool for someone whose only sensory experience of this phenomenon is going to be the sonification.
And you've also caught a few of our mistakes.
You say this, but I think, is he telling me the truth, or is he just trying to make
No, we've had some stereo panning issues that
and you're listening so carefully that you can tell the sound is supposed to be on the left or the right. It's happened a few times.
Okay.
When I look at images that we've created descriptions of or sonifications of, I have a completely different appreciation for them. And I think anytime any researcher has a new avenue to go down, there's a reward at the end of that street, because it pushes how you process things. It pushes how you understand things. So I'm kind of addicted to it at this point. Like, what else can we do?
And I think now that blind or low vision kids who see things like image descriptions and sonifications feel more included and feel that they're part of the learning world, and that may be a career path that seems plausible to them in a way that it didn't seem plausible to me. I think that, as always happens when you make something more inclusive and accessible for one particular group, you positively affect a lot more people than you think you have.
When you take the time to create something of value to one community, oftentimes, that rising tide lifting all boats, well, that's a phrase for a reason, because a lot of other communities have expressed that these types of outputs matter for them as well. That was something that we particularly learned from users who are blind or low vision, that they wanted to make sure it wasn't just, this is a duck in a pond, because that could be done automatically. But being able to capture some of the visual poetry of your data set was really critical.
I'm very happy that we're at a place now where a blind astronomy enthusiast, or even just a blind kid checking stuff out, could go, oh, astronomy. Oh yeah, okay, so I can read this image description, I can listen to this sonification, I can maybe touch a 3D print of something. So having all of these access points is a dream come true for a lifelong astronomy lover like me.
Is the result of this international collaboration of scientists. We are managed by the Marshall Space Flight Center, situated at the Center for Astrophysics, our colleagues here at the Smithsonian Astrophysical Observatory, and all of our colleagues at the Marshall Space Flight Center and NASA's Universe of Learning. So many people, so many experts that really give their heart and soul into making this data possible and to helping this data get out into the world.
It's a new era of pioneers, star sailors, thinkers, and adventurers.
3, 2, 1, 0. All engine running.
Let's go.
We have been given the scientific knowledge, the technical ability, and the material to pursue the exploration of the universe.
NASA celebrates LGBTQ+ Pride Month.
Good morning from Mission Control in Houston and the International Space Station Flight Control Room, where the Orbit 1 team, led by Flight Director Elias Mirmo and his Cerberus flight team, are working with their Russian Mission Control Center counterparts in Korolyov, half a world away, just outside of Moscow. And they are monitoring the progress of Progress 88, which heads towards the International Space Station, the unpiloted cargo spacecraft. It's looking to complete its 2-day journey, which started back on Thursday morning, and will dock to the space-facing port of the Poisk module, and where it will unload 2.7 tons of cargo, including food, fuel, and supplies to the Expedition 71 crew. And once docked, it will spend nearly 6 months to the space station. Current docking is scheduled for 6:46 a.m. Central Time, and there you see a live view from the Progress 88 spacecraft as it embarks and looks to complete its journey to the International Space Station. And that journey would begin, as mentioned, early Thursday morning, in which it would depart Launch Pad 6, Site 31, at the Baikonur Cosmodrome in Kazakhstan. Launch was at 4:43 a.m. Central Time, 5:43 a.m. Eastern Time, and on a sunny day in the afternoon in Kazakhstan atop a Soyuz 2.1A booster, in which it would have a smooth 8-minute and 47-second ride into its preliminary orbit. All rendezvous maneuvers inside the Progress have been pre-programmed in its chase to the International Space Station. You are now looking at a live view, a balcony view from the Russian Mission Control Center in Korolyov, in which they are monitoring the progress of Progress 88 as it closes in, now inside 8 kilometers to the International Space Station. In advance of the launch of Progress 88, the Progress 86 spacecraft would clear the Poisk module on the International Space Station on Tuesday, in which it would harmlessly enter a deorbit burn and destructive reentry over the Pacific Ocean.
Station Moscow on Space to Ground 1 for Nikolai and Oleg. Go ahead. I have double-checked with the specialist. Everything is perfect. We can see you very well, and everybody is happy with what they see. Moscow Station, Space to Ground 1 for Yakov. Go ahead. Yakov, we have TV on. We have the range, which is 5.6, and we have the rate, and we see it in the middle. Okay, we are not seeing the video yet, the picture yet. We can only see it from your camera. We will be awaiting for the retrograde correction, and afterwards there will be the Toro activation, but only on MCC Go. All right, copy.
And you just heard conversations between the two Russian cosmonauts overseeing today's docking in Oleg Kononenko, the commander of Expedition 71, and Nikolai Chub. And you are looking at a live view from Progress and its sites on the International Space Station. And in your lower left-hand corner, you can see the telemetry data of it closing in, approaching 5 kilometers out at a rate of just inside 8.5 meters per second.
Need me to, please call me and I will report back. All right, so the picture is coming through. We see it.
And as mentioned, the two cosmonauts that are monitoring today's docking for the Progress 88 are the commander of Expedition 71, Oleg Kononenko, and Nikolai Chub, the flight engineer. They arrived to station back in September with NASA astronaut Laura O'Hara, and they have overseen the arrival of 2 previous Progress spacecraft in 86 and 87, and they've also added 2 spacewalks in their time up on station. They were awakened and up and at it earlier to begin the process and preparation for Progress, and they will be monitoring the Toru, the telerobotic operated rendezvous unit, if the Core's automatic docking system were to have any issues, and they are currently located inside the Zvezda service module. For Kononenko, he is also coming up on a personal milestone this coming Tuesday in which he will celebrate 1,000 days in space. We are coming up on Fly Around, in which Progress 88 in its approach to the International Space Station will embark on a maneuver to properly align itself up to then begin final approach to the space-facing port of the Poisk module and docking shortly thereafter, about 40 minutes from now. But after Fly Around, a period of station keeping in which the Russian Mission Control Center in Korolyov will do its fine-tuning in order to allow the Progress to be properly aligned before the forward docking probe on the spacecraft will be able to interlock with the port on Poisk. And then after docking, there'll be a few seconds of contact and capture to allow for the relative motion to dampen out between the two, and then the hooks will begin to close for the hard mate. Leak checks will then be performed, and the hatches will then open up to unload the 2.7 tons of food, fuel, and supplies, which exactly measures out to 5,520 pounds, and that includes 1,662 pounds of propellant, 926 pounds of water, and an additional 2,884 pounds of supplies. And again, the journey of the Progress 88 spacecraft began this past Thursday morning, early at 4:43 a.m. Central Time, 5:43 a.m. Eastern Time, as you see the launch day highlights on a beautiful sunny day out at Pad 6, Site 31 of the Baikonur Cosmodrome in Kazakhstan. That would send Progress 88 on its way to the International Space Station. A smooth operation from start to finish as it began its journey to bring the food, fuel, and supplies to the Expedition 71 crew. And on board the International Space Station, the Expedition 71 crew, which includes NASA astronauts Tracy Dyson, Mike Barrett, Matthew Dominic, Jeanette Epps, and Roscosmos cosmonauts Alexander Grabenkin, Oleg Kononenko, the commander of Expedition 71 and overseeing today's Progress 88 docking, and Nikolai Chub of Roscosmos as well. Today, they are well into an off day on the International Space Station as they prepare for NASA's Boeing crewed flight test that'll be occurring later on this morning, Central Time, and this afternoon Eastern Time, which will follow the coverage here of the Progress 88 docking. And there you see a live view of the White Flight Control Room, just down the hallways of the Mission Control here in Houston, the International Space Station Flight Control Room, in which the Ascent Flight Director for Boeing, Mike Lammers, and team preparing for today's launch activities. For the launch of the Boeing crewed flight tests, currently scheduled for 11:25 and 40 seconds a.m. Central Time, 12:25 and 40 seconds Eastern Time, and coverage here on NASA TV will begin shortly after the Progress 88's scheduled docking, which is going to be in about 36 minutes from now. And back inside the International Space Station Flight Control Room, Flight Director Elias Mirmo and his Cerberus flight team currently monitoring the International Space Station and the progress of the Progress 88 spacecraft. The International Space Station flying northwest to southeast at an incline of 51.6 degrees to either side of the equator, and it is currently over South America. Back to the crosshaired video from Progress as it tracks down the International Space Station, currently just a little over 2 kilometers out and tracking at just a little over 8 meters per second. After a sequence of impulse burns to maneuver its path and fine-tune its trajectory to the International Space Station, the period of the fly-around mode will begin about 9.5 minutes from now, and then a period of station keeping, which will allow the fine-tuning of the Progress 88 spacecraft to the International Space Station. That'll be in about 20 minutes or so, and then final approach will then get underway. Of those fine-tuning burns that the Progress spacecraft is currently undergoing, Impulse 4 has been completed as the spacecraft continues to track down the International Space Station. And you can see the space station coming into view now as the cameras adjust aboard the Progress spacecraft, about 1.6 kilometers away and approaching at a rate of just over 4 meters per second. And there's a fantastic view from the International Space Station as the Progress is on approach.
How do you copy? You can, you have a go to activate Toro in work. After the command, please proceed with page 21. Copy.
And you just heard the commands coming from the Russian Mission Control Center as the cosmonauts Oleg Kononenko and Nikolai Chu prepare for the arrival of the Progress 88 spacecraft, and another great view of its approach to the orbiting laboratory. Space station currently flying over Rio de Janeiro in Brazil at this hour, in which it is going 51.6 degrees, orbiting northeast to southwest.
Toro activation command is sent, and I'm proceeding with page 21. Copy.
Progress now 1.2 kilometers away, closing in at a rate of just under 4 meters per second.
I activated the сеть, then ручки питания, and the BPS is on. BPS has been on, and I am testing the RUA, turning it up, turning it in the neutral. There are no failures. Everything is great, and I'm putting it to the right, to the left, clockwise and counterclockwise. No problems there. Copy. Yes, right now I will be doing the translation.
Fly around for the Progress 88 spacecraft, just under 6 minutes away, in which it'll fly around the International Space Station at a 15-degree angle as it continues to make its way towards the space-facing port of the Poisk module. Now 1,000 kilometers out at a rate of just a little more than 3 meters per second.
BPS is command. The command has been sent. How do you copy? We copy. Please proceed with step 4.3. In work. I'm activating BPS is, the initial BPS. It's on. I'm activating Rabota. It's on. And the Peresvetka, or the AGC mode, is on. The first mark is on.
Progress 88 currently undergoing Impulse 5 and just wrapping up one of its burns to fine-tune its path. As we see from the International Space Station, its approach to the Poisk module.
It's turned off.
And as it arrives, it'll be moving at a glacial rate
Now you can probably see it
of
more
1/10
clearly.
a meter per second.
Now I'm turning off the operation, Rabota. I'm switching to page 22. Copy. Yes, we can see the image. Everything is great, and please proceed with page 22. In work.
Cosmonauts Oleg Kononenko and Nikolai Chub just completed the Toru test. That is the backup system should the Core's automatic docking system were to have any issues. And those two currently overseeing the Toru, the telerobotically operated rendezvous unit located inside the Vesda service module.
Automatic fly around.
Fly around for station for the spacecraft. A little less than 3.5 minutes from now. And then a short period of station keeping to fine-tune any adjustments necessary on its final approach, docking roughly 29 minutes from this moment. Impulse 6, another one of those fine-tuning burns for the Progress 88 spacecraft, has just been completed as we prepare for the fly-around mode to begin momentarily. And again, the view, the cross-haired view camera from the Progress spacecraft. And from the International Space Station, approaching about 1.5 meters per second. Now 530 meters away, the Progress spacecraft preparing for fly around under 2 minutes from now, and again at a degree angle of 15 degrees.
You can barely see it. Yes, you can send the Rabota command. Sending. And I can see only 2 marks there, and it's kind of blinking, so I can't see it very well. I'm trying to achieve the 3rd mark. Copy.
Progress 88 less than 500 meters away from the International Space Station to deliver 2.7 tons of cargo, food, fuel, and supplies, including propellant, water, and other dry goods.
All right, I'm turning off Rabota, the operation, but I still cannot see it very well. Well, we can stand by. The Rabota is off, and it's supposed to get better.
Fly around for the Progress spacecraft beginning in half a minute's time as Oleg Kononenko and Nikolai Chub continue to communicate with the Russian Mission Control Center in Korolyov. And now fly around has begun for Progress 88 as it approaches the space station in that mode at a 15-degree angle
We see that
in preparation for final approach.
and we are not seeing the image. So yes, indeed, we do have the radial speed at 1.1, and the fly around has been complete. Copy.
Fly around currently underway for the Progress 88 spacecraft, in which it has approximately 10 minutes or so remaining, and then a brief period of station keeping, in which the Russian Mission Control Center will make sure everything is properly aligned before final approach to the space-facing port of the Poisk module.
Maybe this is because of the reflection from the array, and it will go sideways now, and the picture should improve. Right now, the picture is awesome. We do have the range of 320, and the rate is 0.86. We are seeing the picture as well, and the quality is acceptable.
This is Mission Control, Houston, as the Progress 88 cargo spacecraft, the unpiloted craft, making its way to the International Space Station, currently in fly-around mode, and then a period of station keeping before final approach. And then you see live views of the space station from the Progress spacecraft, in which it is 200 meters away from the orbiting laboratory and starting to slow down, now at a rate 0.67 meters per second. Progress 88 using the Coors automated docking system, which is pre-programmed upon launch, in which signals going back and forth between the Russian Mission Control Center, allowing it to autonomously dock to the Poisk module. Expedition 71 Commander Oleg Kononenko and Nikolai Chub in communication with the Russian Mission Control. And from the International Space Station, you're seeing excellent views of the firings as the Progress 88 continues to make adjustments as it approaches the space station. Progress now closing in on 240 meters away from the orbiting laboratory. And Progress continues to make its way in the fly-around mode of the International Space Station. And from the view of the Progress, the cross-haired view, you can see it starting to line itself up with the space-facing port of the Poisk module, currently sitting at 225 meters out and slowing down to currently a rate of just a little more than 20 meters per second. And as fly-around mode continues in approach of the station-keeping portion of the docking procedures, Progress will slow down to allow for that and hold for those final commands and analysis from the Russian Mission Control Center. And that is the team here inside the International Space Station Flight Control Room, preparing the space station and its Expedition 71 crew for the arrival of the Progress 88 spacecraft. And this is the balcony view from the Russian Mission Control Center in Korolyov, where they are making similar adjustments to the Progress. Approach rate slowing down to nearly 200 meters away from the International Space Station. There you can follow along in the bottom left-hand side of your screen. And the rate of closure starting to slow down to nearly 0 meters per second. As both the Progress 88 spacecraft and the International Space Station prepare for docking, the two currently crossing over the western coast of Africa, and the Expedition 71 crew off day today as they prepare not only for the arrival of Progress 88, but in preparation for later this morning Central Time and into the afternoon on the East Coast, the Boeing crewed flight test, which is scheduled to launch at 11:25 and 40 seconds Central Time, 12:25 and 40 seconds Eastern Time. Progress 88 now in its final stages of the fly-around process at that 15-degree angle. And there it'll pause for a moment for the period of station keeping, the fine-tuning, to make sure everything is right on track for its arrival to the space station, or space-facing port of the POIST module.
Moscow, I have the display parameters, but the S-word value, it's changing from 1 to inaudible. Yes, from 1 to 0. Yes, we see there is this issue. And rate is from 0 to negative 148 on the display. Can you confirm visually? Stand by. We're going to use the ruler. Nikolai is going to. About 200 meters range when we measure with the ruler. And roll is appearing periodically, roll display. Yes, copy.
Great view from the International Space Station of the Progress spacecraft and its adjustments on its approach to the orbiting laboratory, docking roughly 16.5 minutes from now, looking to complete its 2-day journey to the International Space Station. And now Progress beginning to roll to properly align the solar arrays deployed on either side to match up precisely where they need to be in order to dock to that space-facing port of the POIST module.
Roll maneuver. Yes.
And there you can see right in the center of the crosshairs the Poisk module as the Progress 88 spacecraft continues its roll maneuver again to properly align the solar arrays that are on either side ahead of docking.
Approximately 160 meters range. Copy 160.
Just shy of 160 meters out as station keeping begins to wrap up for the Progress 88 spacecraft and begin making its way towards the final approach.
Roll maneuver is complete. Range 160 meters. Copy.
Station keeping now underway for the Progress spacecraft after the roll maneuver has been completed. There it'll wait a moment as it is approximately 160 meters away from the International Space Station.
And we have just gotten instructions.
Да, подтверждаю. Выдаем БПС входная, работа, формат 44.
You need to use display 44.
And during this period of station keeping, this is the opportunity to do any fine tuning necessary to the Progress 88 spacecraft and the forward docking probe before it begins its final approach to the space-facing port of the Poisk module.
Наблюдаем два причала, ожидаем начала автоматического причаливания.
We can see indication of approach.
And the command has been given as final approach is now underway for the Progress spacecraft, closing in now at under 170 meters from the International Space Station.
Copy. Approach in range of 120 according to our ruler measurement. Copy.
Cosmonauts Oleg Kononenko and Nikolai Chub relaying their measurements of the Progress spacecraft and approximately 120 meters away from the International Space Station and docking to the Poisk module.
Are you comfortable with the brightness? You can toggle it if you want. It's at your discretion. So far, so good. We can see the docking assembly. Copy.
So far, so good. Relayed down from the space station as the Progress makes its final approach to the Poisk module, in which the forward docking probe on the Progress will interlock with that port on the Poisk. And then a few seconds after contact and capture, it'll allow the station and the Progress for any relative motion to dampen out. And then the hooks will begin to close to create a hard mate between the spacecraft and the International Space Station. And then from there, leak checks will be performed. The hatches can be opened and the unloading can begin of the 2.7 tons of cargo aboard the unpiloted cargo spacecraft. Inside 100 meters now for Progress as it closes in on docking. Scheduled just inside 11 minutes from now. And as the Progress and International Space Station are prepared to link up, the two currently crossing over the Mediterranean making its way into the southernmost portions of Europe. Progress now closing in at 0.3 of a meter per second and inside 70 meters away from docking to the Poisk module. Progress now inside 60 meters from the International Space Station, closing in at just a little more than 0.2 a meter per second. And there, the Expedition 71 crew awaits its arrival.
Линейки дальность порядка 40 метров, по курсу 50. Скорость.
We have 40 meters range according to our ruler measurement and 50 meters on the course. Observing the target, everything is aligned perfectly. Copy, excellent.
Alignment right on the money for the Progress 88 spacecraft to the International Space Station, with docking coming up just a little more than 8 minutes from now. And then once
46 meters range.
Понял, дальность 46, СВП готов.
Copied at 46 meters range, SSVP ready.
46 meters, and now the docking system power-up has been completed.
Итак, мы подходим потихоньку к дальности 30 метров.
Approaching 30-meter range. Please remember to send BPS initial, command, and Работа operation. Copy.
We'll be getting video back from the Progress momentarily as we look out from the balcony view of the Russian Mission Control Center as we switch to the balcony view of the Russian Mission Control Center in Korolyov as the Progress spacecraft on final approach to the International Space Station. And shortly after docking and once hooks are closed, it's a reminder that we'll be transitioning on over to Kennedy Space Center in the anticipation of the launch of the NASA's Boeing crewed flight test later this morning Central Time and into the early afternoon on the East Coast. Launch scheduled at 11:25, with coverage beginning at 7:15 a.m. Central Time.
Crosshairs aligned. And according to our measurement, 20 meters. According to the course measurement, 30 meters. Copy. Continue. Breakout enabled command has been sent. 29 meters range.
Принято.
Copy.
Final bit of distance for the Progress 88 spacecraft is the crosshairs. You can see from the Russian Mission Control balcony view in that top right-hand corner.
Station, so you are done with this page. Proceed to page 24 of Toro RODF. 12 meters according to our ruler measurement.
Cosmonauts Oleh Kononenko and Nikolai Chu reporting 12 meters separating Progress from the International Space Station.
What's the range?
And as you can see from the crosshaired view, the target that it is looking to line up just off to the left-hand side of dead center is the target that will properly align the spacecraft to center up on the International Space Station.
Copy.
Есть база АР. Принял. Также наблюдаем база АР.
AR base. Yes, and we concur.
по линейке дальность
15 meters range and 20 meters per course. Copy.
И все в норме.
Everything nominal.
Ну, у нас дальность менее 30 метров, поэтому...
Range is less than 30, so the course range is not credible now. Okay, copy. Range 12 meters. Copy.
12 meters away, everything lining up nominal with the Coors automatic docking system, putting the crosshairs that you see on the camera with the pentagon-shaped target that is floating just to the upper left-hand side. And as it continues its final approach, we'll continue to align for docking.
Copy.
Дальность по линейке 9 метров.
Range less than 9 meters.
Less than 9 meters, you hear, as you see a great view from the International Space Station. Those final few bits of distance between the cargo spacecraft and the International Space Station.
Дальность 6 метров, скорость 0,1.
Range 6 meters, rate 0.1.
Принял, отлично.
Copy. Excellent.
Большое согласование.
Reporting 6 meters away as the Coors automatic docking system so far working well, connecting Progress 88 to the space station.
0.1. Copy.
Дальность 3 метра.
3 meter range.
3 meters, and we'll listen for confirmation
Rate 0.09.
of contact and capture.
Standing by for contact. Copy. Standing by for contact.
Дальность 1 метр.
1 meter range.
1 градус. Немножко в крене.
A small misalignment.
Да, принял, все должно подтянуться.
Yes, copy.
Да, принял, все
Есть цепка. Есть цепка. Время 11:43:13.
Есть касание сцепка.
Contact at 11:42:13. Copy that. Now continue monitoring the latching.
Contact has been confirmed, 6:43 a.m. Central Time, as the International Space Station and Progress 88 spacecraft have connected over southern Russia, and now we will stand by for the hooks to close on the Progress to create the hard mate. But for now, they'll allow a few seconds as the International Space Station in free drift for the relative motion to dampen out before the hooks can begin to form that hard mate. Contact has been confirmed again at 6:43 a.m. Central Time, 7:43 a.m. Eastern Time between the Progress 88 spacecraft and the International Space Station. A fantastic connection between the two, with the Coors automatic docking system leading the way. Now we stand by for hooks to begin closure as the forward docking probe on Progress continues to interlock with the space-facing port of the Poisk module. Docking probe on the Progress 88 uncrewed spacecraft, cargo craft, currently driving to start the production of the hard mate between the spacecraft and the International Space Station. And from there, that's where the hooks will close to seal the two together and complete the docking process. And then a sequence of checks will then be performed before hatches can open and the Expedition 71 crew can begin to unload the 2.7 tons of supplies.
Alignment is complete based on our image. Yes, it looks that alignment is completed. Standing by. Station Moscow. In order to correct the AGC performance.
Back inside the International Space Station Flight Control Room here in Mission Control in Houston as we stand by for confirmation of hooks being closed on the Progress 88 cargo craft.
What else would you like? Just try to toggle AGC mode. Copy. Will do. All right. Operation mode and AGC toggling now.
And with that confirmation, the hard mate has been completed between the Progress 88 spacecraft and the International Space Station, completing Progress 88's two-day journey that started back on Thursday morning and now delivers 2.7 tons of food, fuel, and supplies to the Expedition 71 crew. And with that, we will go ahead and wrap up our coverage of the Progress 88 docking for this morning, but do not go anywhere, as shortly coming up soon, starting at 7:15 a.m. Central Time, 8:15 a.m. Eastern Time, coverage of NASA's Boeing crewed flight test that will send NASA astronauts Butch Wilmore and Sonny Williams to join the International Space Station will begin shortly. But a successful rendezvous and docking of the Progress 88 spacecraft and 2.2 tons of food, fuel, and supplies to be unpacked by the Expedition 71 crew shortly. That'll do it for our coverage, but again, stand by as NASA's Boeing crewed flight test begins momentarily. This is Mission Control Houston.
Ellen and I are in a really unique location here over at the ASOC. We have a great vantage point on all of the operations that are going on here today. We're able to actually see all of the launch control team down here behind us. We also have mission directors to one side and engineering support to the other side. So we are really right in the middle of what you might consider the game. It feels sort of like we're in a press box at a football game. And so we're tracking everything that's going on with the countdown from here. And right now we're waiting for the pad team to start making their way back over to the pad because Dylan, fueling has been wrapping up.
Well, Lauren, Atlas V and Centaur are fueled and ready to go. We rolled the rocket out to the pad this past Thursday where we connected it up to all the pad utilities. Countdown started at 1:05 this morning. We powered up the rocket, began all the final checks of our avionics systems and all the final preparations out at Launch Pad 41. All that work wrapped up around 5:30 a.m. And with the launch vehicle ready, we started cryogenic tanking at 6:25 a.m. after completion of our pre-cryo built-in hold. Cryogenic tanking takes just under 2 hours to complete. That just wrapped up here in the past few minutes, and the teams are now polling downstairs to initiate re-entry of Pad 41 so that we can bring the team out and start loading crew into Starliner. As you know, last time we got together, we had an issue with a liquid oxygen self-regulating valve on our Centaur upper stage. Once we get the launch vehicle fueled, one of our critical ground operation rules is that we do not change the status of the launch vehicle with any of the folks out on the pad or crew on board the spacecraft. So with the fueled rocket and a stable replenish configuration for the safety of the crew, we did not or would not change the state of the rocket. So significant troubleshooting of that valve really wasn't possible with people at the pad. So that's what led us to that scrub decision of our first launch attempt. Not working any issues today, and that valve was removed and replaced and retested during our downtime here. So that is the status of the rocket, Lauren.
Yeah, and Dylan, Starliner really had a very clean countdown during the last launch attempt, but it wasn't until after that scrub that we started safing the propulsion system and closing the valves and observed a small helium leak in the port side manifold. So we decided to take a pause and investigate further, as we do in this business. And after testing all 8 of Starliner's helium manifolds, our team found the leak was isolated to one flange in one of the spacecraft's 28 reaction control system, or RCS thrusters as we call them, which makes small adjustments on orbit. And even more specifically to a tiny seal about the size of a button on a men's dress shirt. So that gives you a real perspective on how small we're talking. It's important to note that helium is not combustible or toxic. Thorough data analysis showed us this condition is acceptable for flight, and that Starliner could handle actually 4 more leaks, or this leak growing by 100 times its current size before actually needing to be managed in space. In fact, other spacecraft like the shuttle have launched with similar leaks in the past, and our teams will be checking the leak here soon, and we'll keep you posted on that. While investigating the cause of the leak, engineers also discovered that in an unlikely scenario of an adjacent helium manifolds failing, our deorbit burn during the spacecraft's return to Earth could be impacted. And because having layers of redundancy is imperative, our teams developed yet another way to perform that burn. If that option were needed, Starliner could do 2 burns about 10 minutes each and 80 minutes apart with only 4 RCS thrusters. In the last few weeks, the crew ran these scenarios in the simulator, and they feel confident with the plan.
Butch and Sunny have been on a lot of our phone calls working through these challenges for the past couple weeks, and it's been really nice to hear their voices. You know, they've been voices of reason as we're working through these. Good reminder that this is a test flight. We expected to find things both on the ground and in space. So our team really sees this as a positive to improve the spacecraft and its systems for the future. And we're already looking at a handful of long-term solutions for Starliner's post-certification missions. Now let's check in with NASA's Daryl Nail at nearby Hangar AE. He is keeping an eye on the weather for us and NASA's oversight of today's flight test. Daryl.
That's right, Lauren. Thank you very much, and welcome here into Hangar AE, where we've got a lot of the CCP engineers and management folks behind me, monitoring, of course, our launch procedures through the day here with Atlas V and preparing the Starliner for launch, as you guys just talked about. Let's talk about the weather. Well, it is June 1st, and it's the beginning of summer, meteorologically speaking. On this day. It's also the beginning of hurricane season, but I can tell you neither one of those is a concern as we look outside and take a look at the sky and the sea. Here now, the sky, you can see a few puffy cumulus clouds off in the distance. Overall, not a problem and not a concern for today. We are 90% go, according to the launch weather officer for today, which is great. Conditions are fantastic. One thing they are watching, though, and we know our host desk knows this well, they're watching the ground winds, which are really they're stronger than normally we would have expected. But we've got strong onshore flow from a high-pressure system that's just off the coast of North Carolina, and so that's creating a lot of that strong flow, which is coming in directly from the east. So you can see those cumulus clouds as they go kind of whipping by the pad. They'll be watching that. That is the only concern, and that is the 10% possibility for violation. Overall, though, we couldn't be in a better position. We were in a similar position during our last launch attempt, and come to find out, even though it's the beginning of meteorological summer, we're not having summer conditions here at the pad yet, and that's a good thing. So we'll send it now back to the host desk with Megan, Mike, and Dee.
Daryl is absolutely right. We know these winds very well as they are whipping around us right now. And Mike, talk to us about why these winds would be a concern for launch.
Well, here at NASA, it's safety first. And so if there were a problem with the rocket, the capsule can pull off and abort and fly over the shore and land in the water. And that's called an abort, right? And we could do that to keep the crew safe. However, the capsules will be coming down under parachutes, and if the winds are too strong, it'll make it land on the beach. And it sounds like it would be safe, but actually we're not sure that structurally it would work, and we're set up to land on the water. So the winds can't be too strong or they'll push us in for an abort. So if we start to get into where the winds pushing would push the capsule too much, then we'll wait till another day.
Right. Landing in water for the abort scenario, but Starliner is designed to land on land nominally, right?
Oh, nominally, and with airbags. I landed on the land in the Soyuz and the shuttle, and I'll say that these airbags are going to be good. And I think that's probably the first thing I'm going to ask Butch and Sunny after they land. It's like, how are the airbags?
Well, speaking of Butch and Sunny, let's head back inside to the suit-up room to check out how things are going there. Again, they began suiting up a few minutes ago, and right now we see Butch. He is unzipping his helmet, it looks like.
And that's really neat about these suits is that instead of having a solid metal ring, we're keeping the suits lightweight and kind of going back to the future with the Gemini program where they had zippered helmets like this. We call it a visor in this case. And since it's a very lightweight visor and helmet, it doesn't have a lot of head protection. So Butch's ear cups is also gives head protection too. So it's a very smart system, and we call it a crew head protection assembly or something like that, or a chippa. So Butch is now taking off his chippa, and you can see he cut his own hair for the flight today.
This is the kind of insight we wanted from you, Mike. As you can see, guys, we are very fortunate to have Mike here with us because he's a veteran of 3 space flights, Expedition 9 in 2004, also Expedition 18 in 2009, as well as STS-134 in 2011. We're cycling through some pictures of those previous flights now. In total, he spent more than a year in space and has conducted 9 spacewalks. He then worked with NASA's Commercial Crew Program to help bring SpaceX's Dragon and now Boeing Starliner online and ready for today's flight tests. He trained alongside Butch and Sunny as their backup pilot and was with them for CFT's first launch attempt. We actually saw him in the suit-up room here snapping pictures, and then he rode out to the launch pad with them where he snapped a few more pictures before handing off some of Butch and Sunny's belongings to the pad team.
It was a big honor to ride out on the Astrovan with Butch and Sunny, and of course we like sharing our stories here at NASA, and Butch and Sunny are very much about that too, because we all can't ride in the Astrovan, we all can't get on that rocket, but we do our very best to bring everybody with us as much as possible.
And I'm just letting people into some of the behind the scenes that's happening here. You forgot your cell phone, and that's very upsetting to all of us here because you can't take your famous Ussies. But again, providing really valuable insight on this flight test. And you'll also be taking notes, right? Because you're going to be the pilot for Starliner's first operational mission after CFT. So really important for you to be engaged and watching today.
Oh, absolutely. And that's the purpose of this flight, is to build flight experience and get certification so that we can have regularly scheduled flights of Starliner to the International Space Station, much like the other commercial crew partner of SpaceX. And we're going to get there. So Butch and Sunny, as test pilots, are going to get some really good data on how the Starliner really flies, how habitable and comfortable is it in there, is it extra humid, is it beautiful. We think it's going to be great. We tested a lot on the ground, but we'll know for sure once we launch today.
And as we take another shot here of Butch, let's talk a little bit more about him. Commander Butch Wilmore, NASA astronaut and retired U.S. Navy captain, raised in Mount Juliet, Tennessee, and is married to Deanna Wilmore with 2 daughters. As a naval pilot, Butch racked up more than 8,000 flight hours and 663 carrier landings, all in tactical jet aircraft. He completed 4 operational deployments supporting missions like Operation Desert Storm. Before his selection to NASA, Wilmore was on exchange to the Air Force as a flight test instructor at the Air Force Test Pilot School at Edwards Air Force Base in California. Butch is a veteran of 2 space flights as pilot on Space Shuttle Atlantis in 2009, and then in 2014 he served as flight engineer for Expedition 41 to the International Space Station. So far, Wilmore has spent 178 days in space and performed 4 spacewalks. This flight test will be his 3rd mission to the ISS.
And Sunny Williams, CFT's pilot and a retired U.S. Navy captain. NASA selected her as an astronaut in 1998, just 2 years before Butch. This will also be Sunny's 3rd mission to space, making her the first woman on a test flight of an orbital spacecraft. Her first trip to the ISS launched in 2006. She served as flight engineer for Expedition 1415. She then returned to the orbiting lab in 2012 and was commander of Expedition 33. Sunny has more than 50 hours of spacewalk time, the 2nd most cumulative time by a female astronaut. So far, she has spent 322 days in space. Before NASA, Sunny was a former naval test pilot and instructor, logging more than 3,000 flight hours in more than 30 different aircraft. Williams grew up in Needham, Massachusetts, and is married to Michael Williams. She enjoys hanging out with their dogs, working out, hiking, and camping, as well as working on cars and houses.
Both very experienced space flyers, and really why they were selected for this test flight, right, Mike?
Oh boy, yes, they work really well together, and it's been really fun training with them. I think that they're a great team, and they're going to get a lot of, like we said, good flight test data. They're going to go back to the mothership, the International Space Station. They'll be able to experience space station crew. They could help there a little bit, and then they'll come home in 8 days, a week or so, and maybe a little bit longer. And so it's they're perfect. And their experience will help make mission success.
Right. A look at the clock, 3 hours, 50 minutes, and 26 seconds from launch. A quick update on fueling. The cryo load was completed successfully, all as well as a check of the prop system. Again, we were talking about that helium leak that Boeing was able to resolve. They did a check of that system. They pressurized it, and so far, all is looking good.
Let's walk you through what you'll see over the next almost 5 hours on this broadcast.
After suiting up, Butch and Sunny will walk out of the ONC building to say their goodbyes to family and friends before their ride out to the launch pad in an Astrovan. And then once at the pad, the crew will ascend ULA's Crew Access Tower to board Starliner in a process we call ingress. Once ingress is complete, the pad team will close Starliner's hatch, and then they will make sure the spacecraft is sealed properly by conducting a cabin leak check. About 11 minutes before launch, the crew access arm, which is that long suspended walkway the astronauts use to get to Starliner, that will retract to the tower, and different teams will then poll to confirm they are ready and configured for terminal count before liftoff. Around 15 minutes after launch, Starliner will separate from the Centaur upper stage. And at 31 minutes into launch, the orbital insertion burn begins to get Starliner into a stable orbit. Now, if you have any questions about this mission over the next 5 hours, as we said, just send those questions our way using the hashtag AskNASA. All you have to do is jump on Facebook, X, YouTube, Twitch, any of our social media platforms, and we look forward to hearing from you and answering those questions live. Now let's head back into the suit-up room again. That's where all the action is happening. And it looks like Sunny also now has her helmet unzipped, and it looks like she's taking off her gloves. I believe both of them have had successful suit leak checks.
Yeah, we saw, and we expected it because there's a lot of testing of the suits before the crew gets inside them, but you still have to check. We saw that Sunny was fully inflated and looked kind of almost a little small inside the suit, and that's exactly how it's supposed to work. We even test the spacecraft that the crew could still push the buttons and do what they need to do to fly the spacecraft, even in an inflated condition. But you can see them there sitting in these Astro loungers, and you can see the excitement on their face and the joy that there is to getting ready for a space flight. This is the last time that they're going to be able to sit and quote unquote chillax, and they're going to get ready and leave the suit room in a little bit, and then it's game day.
Yeah, when you were here with them for the first launch attempt inside the suit-up room, this was kind of some downtime. They took some pictures with folks, right? Because really there's a strict timeline that they're keeping to, and if they're a little bit ahead, they have some pad here, right?
Yeah, our timelines are built for the whole day in case for the case when we have 4 people. That's something we're checking out to see if a 4-person timeline is workable. But we only have 2 people, so it does give us a little bit of extra time. And Butch and Sunny have really focused on the team because we realize as astronauts that we're part of a really big team, and that's really cool. It's like the biggest sports, bigger than regular sports teams, and we all work together, and it's the greatest team sport. So Butch and Sunny did want to spend time to recognize our suit-up team that you can see working in the room, who are making sure and that they're ready to go. There's also another team in there that checks the equipment to make sure that they have what they need: their wrist mirrors and watches and pens and pencils, what's going on their knee board, and we check all that to double check to make sure, because once we're in the capsule, you got what you got.
Yeah. A quick note about the suit. Again, this is a new suit that developed for this Starliner launch, and the full suit, which includes an integrated shoe, weighs about 20 pounds with all of its accessories, and that's about 10 pounds lighter than the launch and entry suits worn by space shuttle astronauts, right, Mike?
Yes, it's definitely more lightweight. We took some really good ideas from previous spacesuits, and David Clark put together a great suit.
Okay.
And it's definitely more flexible, elbows and knees. You saw Sunny kind of showing that. There's vents that come in right underneath our chins that allow us to be cooler and still pressurize this suit.
All right, we have commentators at Mission Control in Houston monitoring Starliner's flight to the space station. Let's check in now with NASA's Brandy Dean and Boeing's Jim May.
Thanks so much, Dee, and welcome back to Johnson Space Center and Mission Control Houston. I'm NASA's Brandy Dean.
And I'm Jim May with Boeing. We're incredibly excited to be here today with the flight control team that will be seeing Starliner safely through its first ascent with crew members on board. This team has been training hard for this, working through literally hundreds of simulations, and they're ready to get Starliner to space.
Yeah, the team that was here on May 6th is back again today to see Starliner into space and on its way. And they are led again by Flight Director Mike Lammers, with Flight Director Rick Kempfling working alongside him to assist with keeping an eye on the weather. And on Lammers' other side, we have Canadian Space Agency astronaut Joshua Kutrick, who's acting as today's Capcom. He'll be speaking with Butch Wilmore and Sunny Williams on the team's behalf. And he has even more than the usual level of Capcom interest in the flight since he plans to be on board Starliner the next time it launches as mission specialist on the Starliner 1 crew.
This team has been on console since around 5:30 a.m. Central this morning, working closely with the teams in Florida. Just under 4 hours before launch, once everything was activated and ready for them, the Boeing Mission Control Center ground control team handed over control to these folks here. And they'll be the ones sending any commands to Starliner from now on.
And that said, although they'll be busy, you won't actually hear too much from them as they move through the countdown with their colleagues in Florida. Some of the key calls they'll make include switching Starliner from ground power to battery power, and with the crew's help, activating the launch abort system. And of course, Lammers will speak on behalf of his team when he gives his go or no-go to the launch conductor during the final poll 7 minutes before launch.
And at liftoff, they'll work hand in hand with the ULA team, who will be controlling the Atlas rocket, which is lifting Starliner into orbit. For the first minute and a half of flight, we'll have Atlas and its solid rocket boosters providing the initial lift to get Starliner going. And then the final stretch of launch, we'll see the second stage Centaur engines finish the job of getting Starliner into orbit.
And they'll be done with the job about 12 minutes into Starliner's flight, then be jettisoned 3 minutes later. And after that, Starliner will be on its own to make its journey to the International Space Station.
So let's take a closer look at the details of what to expect during Starliner's ascent coming up at 12:25 p.m. Eastern this afternoon.
Ascent begins at T-0, liftoff, the end of the countdown, and the beginning of the mission. Shortly afterwards, at T+12 seconds, the rocket rolls, lining up Starliner with its target orbit and putting the astronauts in a heads-up position. Then, around T+40 seconds, max Q starts. That's also known as max aerodynamic pressure. This is a critical time when the atmospheric forces reach their highest. Next, at about +1 minute 35 seconds, the two solid rocket boosters run out of fuel and burn out, and about a minute later they separate from the booster. The Atlas booster engine continues to burn for almost 2 more minutes. Then at approximately +4:30, booster engine cutoff, or BECO. About 5 seconds later, the booster separates, and so does the ascent cover on top of Starliner. At around 4 minutes 45 seconds, the Centaur upper stage ignites, continuing the push to orbital speeds. Then a little after 5 minutes, Starliner is free of the atmosphere and doesn't need additional aerodynamic support, and the aeroskirt is jettisoned. After a long 6+ minute push from Centaur, main engine cutoff, or MECO, happens around 12 minutes after liftoff. Then, when Centaur successfully separates almost 15 minutes after launch, ULA's job is done. But Starliner is not quite in orbit yet. After a 16-minute coast, Starliner ignites 4 of its orbital maneuvering and attitude control, or OMAC engines, for the orbital insertion burn, and then 31 minutes after liftoff, the ascent profile is complete.
That was a look at the first 30 minutes of Starliner's journey into space, but of course that's just the beginning on getting it on its way to the International Space Station. So next we're going to check in with NASA's Rob Navius, who's waiting on launch just down the hall with the Space Station Flight Control Team. Rob?
Thank you, Brandy, and good morning from Mission Control in Houston and the International Space Station Flight Control Room, where flight controllers are monitoring the countdown for the Atlas V launch and keeping tabs on the Expedition 71 crew aboard the orbital outpost. The 7 station crew members are awake at this hour on a Saturday, having just watched the unpiloted Progress 88 cargo craft dock to the Poisk module of the International Space Station. That flawless docking occurred at 6:43 a.m. Central Time, 7:43 a.m. Eastern Time. With that milestone having been completed, the crew's full attention can now turn to the expected arrival of the Boeing Starliner on Sunday afternoon. Early Sunday morning, there'll be a pair of mission management meetings, first by Boeing management to assess Starliner's systems following launch, and the initial series of OCCs. Those are the operational checkout capabilities the Starliner crew will conduct to ensure that the vehicle is ready for docking. Following that meeting, the International Space Station partners will gather to give final approval for Starliner to press ahead with the critical phase of the rendezvous that will begin Sunday morning with the terminal phase initiation burn. By the way, at the time of launch today at 12:25 and 40 seconds p.m. Eastern Time, the International Space Station will be flying 260 miles over western Germany. A busy 24 hours lies ahead. We'll be here every minute to keep you posted. With that, and with the Atlas V countdown proceeding smoothly, let's go back to the Cape.
Thank you, Rob. Yes, a lot of moving parts over the next 24 hours to get Butch and Sunny to the space station. So let's head back now to the ASOC to hear another update from ULA's Dylan Rice and Boeing's Lauren Brennicke.
Megan, we want to let viewers at home know that we are now going to be bringing up those public operational communications. You might hear us call them loops or nets. That's kind of our lingo here in this business. But it's our job to wear these headsets, listen to the chatter in the background, and translate that to you at home. So we'll be doing that at this point in the countdown. We've been listening to the Starliner control team shift control of the spacecraft over to mission control in Houston. The team's working to get the pad team back up to the White Room to get the spacecraft prepped for crew. And our teams have also been cycling the thruster valves, and they are now in the open position. This is the third time for Starliner to launch, but of course the first time with crew on board. So if you've watched our launches in the past, the prep for this one will be a little bit different. That's why we're coming to you a lot earlier before launch today. It is important to remember this is a test flight, so we are going to learn a lot to be more efficient in the future. Dylan, how are things progressing with the rocket?
Well, Lauren, things are continuing to go very, very well. The ULA team is up on the crew access tower now, configuring the White Room for what happens next with the crew's arrival. So we are standing by at T minus 4 minutes. That's the T is the terminal count clock. All the rocket activities are sequenced to the terminal count clock, as you can see on the screen there, the L count clock or launch count is counting down to our T0 at 12:25:40. So that T clock holding at T minus 4 minutes, indicating that the rocket activities are basically nothing happening right now with the
3 at your convenience. Roger.
Nothing happening right now with the launch vehicle, but we are configuring the pad for loading.
Go ahead, Mike.
This is the 100th launch of the safe and reliable Atlas V rocket and the third flight of the 172-foot-tall N-22 configuration. This rocket's configured with a dual-engine Centaur upper stage, which is uniquely capable to deliver that performance that we need to shape that trajectory to maximize crew safety on the ride to the space station.
And of course, from this point on, as you hear some of those operational communications, the nets or the loops come across, we will pause in our commentary so that you can hear them. So if you notice us pause, that's what we're doing. We just want to make sure you can hear everything. So now let's check in with NASA's Daryl Nell over at Hangar AE. Daryl.
All right, thank you very much. And as you can see on your screen here, this is the card game.
LC, SMD on channel 1 for a comp check. Cuddy here.
I have you loud and clear on channel 1.
I have you the same, LC, SMD out.
You just heard the launch conductor there. Nothing too big to report.
Com check on air to ground 1. I have you loud and clear on channel 1.
Copy, I have you loud and clear on CST, air to ground 1. This completes hold call authority com check.
Roger.
Okay, so ground, some comm checks that you can hear there. But again, this is the traditional card game. You see Sunny and Butch there with Joe Acaba, the lead there for the mission today. And I see two camera angles here for the first time, so we actually get to see their cards. But the point of this game, and of course Mike Fink and Megan can talk more about this, but as we're looking at it, since we're watching it now, they're playing a card game, and they're going to play this game until the commander, Butch, loses. And the whole point of this is to take all that any bad luck and get rid of it on the card game, right? So they want Joe there to win the hand, and they're playing the hand out.
Now minus 3 hours, 35 minutes.
So they're going to play another hand, because I think that they may have They may have won, so we'll see. We'll see what's going on. Anyways, we also want to talk weather, which is a factor. Not too much today. Only 10% no-go. We are at 90% go. And so we're looking really good there outside. But we do want to continue to watch this tradition, which goes all the way back to the Space Shuttle program. Not sure what the card game is, but they're taking additional cards. You can see there Sunny with a smile on her face as she takes another card, and Butch observes. There's plenty of time in the timeline for this. They're suited up. They've done their pressure checks, and so along the timeline, they've built in a period of time, of course, some margin just in case, they have to do some extra checks. But there you go. Card game is complete. The bad luck, they've gotten rid of it, and Sunny gives 2 thumbs up to say, hey, we've got the good luck on this one. We're going to have hopefully a good flight today. All right, as we look outside at the Atlas V rocket with the Starliner atop the rocket, you can see there in the sky just a few clouds, not a concern. Offshore winds are driving some of them onshore, but the radar, there is no convective activity, no storm activity is basically the term there in any of these clouds. So that's not an issue at all. We are 90% go and looking good there. Also tracking NASA's oversight of the mission today, and NASA Operations Manager Richard Jones just recently polled his team within the hour. They were all go. So we're looking good there as well. If you're wondering whether or not you can see this launch from an area of the southeastern United States, we actually have a graphic that we can show that gives you an indication of where you can see this rocket at what point in time in the launch. So as you're looking at this here, if you're in the southern area, if you're in Florida along the coast or southeastern Georgia, you can see that at certain stages, the plus 30 seconds, you can obviously see that all along the Space Coast. But as you get to level 2 and level 3 and level 4, this then expands your area to be able to see this rocket. We have clear skies in the area thanks to the high pressure system, so most of the folks along the eastern seaboard should have a view. But again, as we start to go along the timeline, you see the separation events that will expand out to southeastern Georgia, and then we even have sometimes pictures coming from coastal Carolina. If you have those, of course, send those to us, #AskNASA. We'd love to see them. That's our report from here at Hangar AE. Now we'll send it back to Megan, Mike, and Dee.
You had a lot of interesting commentary here at the host desk while we were watching the card game. What is that game?
Yeah, so this game is called 31, or SCAT, although I think Sonny's niece and nephew, they call it CAT because Sonny likes dogs. So it's just a little jab. But the point of it is kind of a little bit like blackjack, except you're supposed to get 31 of the same suit. And you saw there that Butch and Sonny successfully got rid of the bad luck, and they're getting ready right now to walk downstairs and say hello to their families and get into the Astrovan. So I think that's coming up pretty soon.
Yeah, we are watching the clock here in about 2 minutes because 3:28 is when we expect them to depart the suit-up room. So in those few minutes, let's actually head outside and take a look at the Astrovan that Mike just mentioned. The Astrovan will be their ride to the launch pad, and right now it is parked right outside there of the operations and checkout building. A great view there of, again, their ride to Launch Pad 41 on Cape Canaveral Space Force Station. Now, NASA chose the company Airstream back in the 60s to create a crew quarantine vehicle for when astronauts returned from the moon. And the picture you see there, President Nixon talking to the Apollo 11 astronauts inside said quarantine vehicle. And then during the shuttle program, Airstream created the first generation Astrovan, a 27-foot motorhome that transported astronauts across
3 hours, 30 minutes.
KSC to their launch pads. And both Butch, who you see there in that picture in the front, and Sunny rode in that Astrovan.
And now, here's a closer look at the new Astrovan. It's wrapped with pictures of Starliner, has a license plate that says Ride to Space. When the door opens, steps fold out. The inside can seat up to 8 people with room for the astronauts' portable air ventilators that keep the crew cool. The Astrovan also includes a TV and sound system, so crew can watch or listen to whatever they want on their way to the pad.
Yeah, this Astrovan was it's super comfortable, and even though it held 8, there was just 3 of us last time, and Butch and Sunny are going to ride out today just by themselves. They told me last night that they'll miss me, but I'm not sure that they really will, because they're getting ready to go to launch. It's a very smooth ride. We have great drivers, and we even have a backup Astrovan.
Oh, I didn't know that about a backup Astrovan, really.
Yeah, well, it's not where the backups ride, because I rode in the primary one. But, yeah, no, it's the really important thing is that we have to launch on time. So if for some strange reason they got a flat tire or something, we'll just hop out of one van and go to the other one.
Makes sense. All right, again, look at the clock. 3 hours, 28 minutes, and 40 seconds until liftoff of NASA's Boeing crew flight test. And in about 30 seconds, we expect Butch and Sunny to leave the suit-up room inside that building you see there. Here they are. Commander Butch Wilmore and pilot Sunny Williams walking to an elevator at the end of the hallway to depart astronaut crew quarters. Looks like they have some roses in hand. Oh, that's really sweet, Mike. They're handing it out to some folks there in the ONC.
Again, Butch and Sunny are really about the team, and Butch made sure that there were roses for the ladies, and I think even some of the guys.
Yeah, one just got a rose right there. It's the thought that counts, really.
And it's really they take such good care of us while in quarantine, and Butch and Sunny.
LC Slick on Channel 1.
Longer quarantine than usual.
Hatch open ops complete. Confined space checks are nominal.
Roger.
A wave there from Butch and Sunny as the elevator doors close. That elevator will then transport them down 3 floors, and we will soon see them walk out those doors you see there.
And in the meantime, we heard that the capsule, the spacecraft hatch is open, ready to receive.
You know, Butch and Sunny have been training on Starliner for years. And Starliner training takes place at Johnson Space Center, where they can simulate just about anything they might experience in space, even zero gravity. They performed a lot of their training inside a real-size mock-up of Starliner at JSC, which just happens to be right across the room from a real-size mock-up of the International Space Station. And just down the road, they spent hundreds of hours inside Starliner's simulators, running through various possible scenarios they could face during this flight test.
Now, Mike, when they returned to Houston after the first launch attempt, they actually did get back into some of these training simulators, right? To walk them through some of the procedures that they were testing, given some of the issues that were found?
Oh, very much so. Butch and Sunny, as consummate professionals, insisted that they keep up their skills, and not just their own skills, but the skills of the entire team it takes to go fly the spacecraft. And so as we looked at how to handle a helium leak, we came up with new techniques and procedures, and Butch and Sunny we're helping work with the team to make sure that we have everything in place in case we ever need it.
So great resources available to them, again, back in Houston. All right, so we asked you for some social questions. We have one right now. Why don't we take that up on the screen there? So this one is from Abibak on Instagram asking, what are you testing on this mission?
We are testing the whole thing, right? So we have all the little pieces work together, but how does Starliner fly with humans on board? Is the ECLSS system, the environmental control system, working? How do the spacesuits work? Can we push all the buttons? Does it fly like it's supposed to? All of these things are really important. How does it dock? And then can we use it for its purposes as a rescue spacecraft? And Butch and Sunny are get a chance to check a whole 6-month mission in a compact several days aboard the space station. So this is really important. We'll take a lot of flight test data, talk about it when we get back, and add to the certification so that Starliner can fly on a regular basis.
We have a minute before they walk out of those doors, so let's sneak in one more. Nor on Instagram asking, how do astronauts feel after coming back to Earth?
Yeah, it's really amazing because you're weightless for a while, and then you come back and you have 1G again, and your body is adapting. Some of us feel sick. Some of us just feel a little bit not well, but it's really amazing because within minutes to days we feel back normal again. And my experience was on my last flight was I was hungry when I came back, so they had some sandwiches ready, and here they are.
Our CFT crew taking their first steps outside for their historic flight test to the International Space Station. Commander Butch Wilmore on your left and pilot Sunny Williams to your right. Waving to the crowd there. Their friend Mike here at the hostess applauding them from afar. Some roses still left in Butch's hand. I'm sure he'll hand them off to some of the crowd there that's outside of the ONC.
I think his wife and daughters are there, so he definitely wants to show appreciation for how patient his family has been.
Well, and you did say that Butch and Sunny have been in quarantine for a very long time now. April 22nd is when they went into quarantine.
Yeah, it's been a long time. They were allowed to see their family, but from a distance, so this is as close as they've been for a while. But we do really respect the health stabilization program. We don't want our friends aboard the space station to get sick and impact the mission for sure.
Talk to us about the people who are here, right? And there's different tiers that talk about or that have to do with how close they can get to the astronauts, right?
Yes. So if other people have been in quarantine along with Butch and Sunny, like before, then they could get really close. At this point, the crew has to maintain at least a 6'2" distance, and they can see and talk to their friends. Especially we're outside, so and with this wind, the chances of anything happening are very low. And then there's a lot of our team that are there, and we also have some very important people like the administrator and other folks too. And I think I might even see Chris Ferguson, the original commander of the CFT mission. I think he's there in the crowd also. So yeah, this is a lot of well-wishers and sending blessings to Butch and Sunny for a successful flight.
Yeah, it's great to see the crowd there, and also a number of your fellow NASA astronauts, right? They're there to support the crew's family.
Yes, we have Jack Hathaway and Doug Wheelock. Now, Doug's a veteran astronaut. Jack is one of our new former ASCANs and now getting ready to go fly on a mission himself. We also see in the distance the Boeing NASA astronaut liaison, Megan Donaldson. She's been super helpful in getting this mission together and keeping the crew pointed in the right direction, and being a very good liaison with the Boeing management too, so that our voices are heard.
Yeah, I think this scene here just shows again, a fraction of all the people that it takes to make this happen. The support of your family, the support of your friends, and then again, teams across both Boeing, NASA, and ULA to make this crew flight test happen. Lots of thumbs ups from Sunny there, lots of waves. They're making their way through the crowd now. They have still about a minute and 30 seconds built into this opportunity to say their final goodbyes before they get into that Astrovan and head to the launch pad. What do you think's happening there, Mike? There's a patting on the back there. What is that?
Well, Butch likes to give speeches, so I think Sunny is sharing the excitement. But that's really what you see here. This is spaceflight is really a human endeavor, and so these are human beings being happy and joyful and really excited in a professional, calm way. But there is a feeling of joy and best wishes so that for a successful mission. And if we're not enjoying spaceflight, if we're not seeing that it's a wonderment of humanity, then we're doing it wrong. And here they go, getting ready into the van.
We can see their helmets there hanging off of their suits. I remember this story that Butch said. He had this recurring nightmare that it would be launch day and he'd forget his helmet. So I'm pretty sure he loves the fact that they're attached to him there.
Yes, it's Butch-proof.
Butch-proof. All right, so they are in the Astrovan now. A quick note about the other folks who are in with them. You have the driver, Rodney Perry, and he said he couldn't pass up the opportunity to drive astronauts to a launch pad. Pretty cool.
3 hours, 20 minutes.
And then also the backup driver, his name is Sean Rose. He's basically going to be the communicator as well, just listening to all the communications that are going on behind the scenes as, again, everything is readied for the astronauts to arrive at Launch Pad 41. The drive will take about 15 to 20 minutes. There will be a full security escort. And here they go. NASA astronauts Butch Wilmore and Suni Williams now en route to Cape Canaveral Space Force Station's Launch Pad 41. And as both Butch and Suni make their way out to the pad, there's only one way for those two to get amped up for launch. And I know that Mike knows because he was inside the Astrovan with them on their first ride out to the pad on the first launch attempt. They will be watching the Top Gun Maverick movie, or at least highlights from that movie. And they should be doing that right now inside the Astrovan, right, Mike?
Oh boy, yeah, that's one way to certainly get excited for the mission and to remind Butch and Suni that hey, they're on an important mission and they're test pilots, and that there's a wonderment to flying both aircraft and spacecraft. And of course, I think the Maverick movie brought that excitement of flying to everyone. And so Butch and Suni are going to have a few clips there, the funny parts of the movie.
LC Slick on Channel 1.
Go ahead.
Crew transport convoy is en route to LC-41. Estimated arrival to roadblock at L-306.
Roger.
And a fun fact was on the last ride...
OSM, LC.
OSM, go ahead, sir.
Crew transport convoy is en route to pad. Permit entry into FHA.
Roger.
Yeah, that was important call there because the crew needs to get to the rocket, and if they weren't allowed to, if they didn't have permission to get inside the hazard area, then that would slow things down. But Butch and Suni handed me the remote control and said, "You play it," and I had to figure out how to play an old VCR really fast.
Oh gosh, well I'm sure they appreciate it. You probably figured it out because they were able to watch it. So again, as mentioned before, they probably really relate to the movie. They're both experienced naval aviators. And here's actually a picture of Suni back in the day. She initially wanted to be a diver in the Navy, but said she watched the first Top Gun movie and decided to go to flight school. And here's a picture of Butch. Fun fact, he was actually a real Top Gun pilot. So you see him there on the far left of the photo. To the far right, actually, is Chris Ferguson. We were talking a little bit about him, right, Mike and Dee?
Absolutely. And another fun fact is, these aren't the first Boeing products that Butch and Suni have flown. In that picture, Suni was standing in front of a CH-46 Sea Knight, and Butch was standing in front of an F-18 Hornet. And of course, today, they'll both
3 hours, 17 minutes.
And of course, today they'll be the first to fly Boeing Starliner.
Now let's check back in with NASA's Brandy Dean and Boeing's Jim May, who are monitoring things at Mission Control at Johnson Space Center.
Thanks, Megan, and go Butch and Suni. Here in Houston, things have been going smoothly for the flight control team and Mission Control. The team here took control of Starliner a little less than an hour ago, and they've been working through a number of steps in the pre-launch checklist since then. But even before that, one of the first things they did after coming on console was a weather briefing with the crew and crew quarters, and that was a quick conversation because the weather's looking very good for today's launch opportunity.
The team here in Houston is continuing to work through their pre-launch checklists. Right now, they're working in a little bit more of a monitor mode, keeping the spacecraft stable while Butch and Suni head to the pad, and the teams in Kennedy Space Center are preparing Starliner for their arrival. Once the crew gets strapped into their seats and the hatch is closed, things here will start to pick back up as we perform cabin leak checks and monitor Starliner's life support systems, hosting crew for the first time to space.
And then in the last 20 minutes before launch, there are a few important actions they'll work through, switching Starliner to internal power and working with the crew to activate the launch abort system.
This carefully choreographed pre-launch process has been practiced many times as a fully integrated team. We capped off our training with a mission dress rehearsal just a week before our May 6th attempt. And we got some bonus live training from that attempt as well as our final preparation for Butch and Suni's mission today.
And of course, all of that aiming to get the crewed Starliner to the International Space Station for its crewed flight test. So let's check in with the destination, the International Space Station. Rob Navius is with the Space Station Flight Control Team, standing by to give us an update. Rob?
Thank you, Brandy. Mission Control, a busy place today. with the white flight control room down the hall where you are, poised to take over Starliner mission operations at liftoff of the Atlas V rocket. And in this room, the International Space Station Flight Control Room, we are ready to collaborate with our colleagues once Starliner moves into integrated operations around 11 a.m. Eastern Time tomorrow. That's about 3 hours prior to Starliner's scheduled docking. Once the new spacecraft is docked to the station's Harmony module, there'll be a period of around 2 hours to conduct leak checks on both sides of the Starliner Harmony docking interface before the hatches will swing open, allowing Butch Wilmore and Sonny Williams to enter the station, which has been home for both of them on previous missions. Wilmore and Williams will configure Starliner systems for docked operations, then will join the 7 Expedition 71 crew members for a typical safety briefing. That will be conducted by Station Commander Oleg Kononenko of Roscosmos. The Starliner crew will then begin to transfer equipment to the station from their spacecraft and begin to settle in for this historic visit. Among the cargo items being transported on Starliner to the station is a spare pump module for the station's urine processing assembly. That's the unit that converts urine into potable drinking water. So this is a timely delivery by Wilmore and Williams. Countdown clocks are ticking backward as we close in on the launch of this test flight, and we're ready here in Houston. So let's turn it back to the Cape for our continuing coverage.
Thank you, Rob. 3 hours, 13 minutes, and 30 seconds. From only the 6th time NASA astronauts will launch on a new spacecraft designed for crew. And if you're curious about the first 5 crewed test flights, here they are. First, Mercury Redstone 3, Alan Shepard, May 5th, 1961.
Next is Gemini 3 with Gus Grissom and John Young, which launched on March 23rd, 1965.
Great historical footage there. Then we had Apollo 7, Wally Schirra, Don Isley, Walt Cunningham. Launched October 11th, 1968.
Then we had STS-1 with astronauts John Young and Robert Crippen, which launched April 12th, 1981.
And then NASA's SpaceX Demo 2. You see Doug Hurley and Bob Behnken waving there. That launch was May 30th, 2020.
And then, of course, today you've got NASA's Boeing crew flight test with Butch Wilmore and Sonny Williams.
And as Butch and Sonny's convoy passes the historic vehicle assembly building here at Kennedy Space Center, we should, of course, acknowledge what will be the 7th time NASA will fly crew on a new spacecraft off our planet. And that will be the Artemis II mission next year. You see the Astrovan now passing by where we are at the press site across the street from the vehicle assembly building. Again, the Artemis II mission next year, that'll be NASA astronauts Reed Weissman, Victor Glover, Christina Cook, and Canadian Space Agency astronaut Jeremy Hansen. They will orbit the moon, and their Space Launch System rocket and Orion spacecraft will be assembled in the vehicle assembly building. Check out what's already in work for NASA's return to the moon. Engineers inside the Neil A. Armstrong Operations and Checkout Building at Kennedy Space Center lowered the Orion spacecraft into a vacuum altitude chamber with the help of a 30-ton crane. The chamber simulates deep space to test for any electromagnetic energy that could damage Orion as it travels away from Earth. Meanwhile, the Artemis II crew completed an underway recovery test at sea. This exercise mimics Orion landing and recovery procedures when the crew splashes down in the Pacific Ocean off the coast of California. Navy divers and boats approached a mock-up Orion capsule and helped the astronauts into helicopters, which then flew them to a nearby naval ship, just like they'll do during the mission. Back at Kennedy and high above Launch Pad 39B, this 360-degree video takes you for a ride inside one of the Artemis emergency egress baskets. In the event of an emergency at the launch pad, astronauts and workers use this quick exit to get to safety. That's a look at your Artemis Moon Minute. It's really cool to see the progress that's being made with NASA's Artemis campaign, because really it's all interconnected, right? Like, so working with commercial partners like Boeing through the Commercial Crew Program allows NASA to focus on other goals like returning to the moon, Mike.
In fact, if you notice, the Artemis Orion spacecraft actually looks a lot like Starliner, and that's not a coincidence. I mean, the Boeing company took some ideas from NASA. We shared ideas, as well as the parachute system have a lot of commonality too. In fact, Sunny said, hey, if you were a young astronaut getting ready to go fly to the moon, maybe you want to fly Starliner first because of the commonality, including the display and control system inside. So what this allows us to do by having the Commercial Crew Program, it really allows, because Boeing is working hard, SpaceX is working hard to allow us to fly back and forth to the International Space Station, then NASA can focus, along with the Lockheed Martin Company and other partners, to fly Artemis and go to the moon and allow us to explore, and commercial American companies can establish some great business in low Earth orbit. This is great for new jobs, great for the country.
We're now 3 hours and 9 minutes until launch. Let's check back in with Daryl Nail over at Hangar AE.
All right, thank you very much, and welcome back to Hangar AE as we look at this beautiful day here at the Kennedy Space Center, watching the crew travel out to the pad. There you see the Starliner crew, Butch and Sunny, driving along, no doubt taking in some beautiful skies as they head out. We're still 90% go, and that's a good thing. The team is continuing to watch the winds. They are a watch item. They are the only reason we're not 100%. I'm currently watching the 1-minute peak winds at the Slick 41 Tower, where they're headed right now, and the winds have come down a little bit. They were gusting between 20 and 25 knots, and they're down below 20 now. That was expected. Launch weather officer said that could be the case. The other item that the launch team is making sure they keep their eyes on, and the mission team particularly, are the winds along the ascent corridor. So if we take a graphic here, we've got basically the path that the Atlas V and the Starliner will take across the eastern seaboard. That's the direction to the northeast. And you can see all along that eastern seaboard, it's important for the mission team to keep their eyes on the weather all along there, because there are areas in which, if there was something to go wrong with the rocket or the spacecraft, they could abort off the top of the rocket and come back down into a splashdown into the Atlantic Ocean. And you can see it travels all the way along the eastern coast of Canada, where they do have some cool water temperatures. That's a factor when the rescue teams, should they abort, have to go into the water. But as we understand it, the det teams, military...
Go ahead. Yes, sir. For step 150, crew transport convoys clearing roadblock. 18 personnel are entering FHA at this time.
Roger.
A good call out there. We know the roadblock's clear because we can see the crew traveling unencumbered on their way to the launch pad. And so just to wrap up the graphic there, things are looking good. We're in a low condition. Basically, the status is low chance of probability that the ascent corridor could be a factor today. So the big picture is weather's great on the ground at the launch pad. It's looking good along the ascent corridor.
LC Slick on Channel 1.
Go ahead.
We're ready for pad support personnel to perform OSE radio comm checks and to proceed to ground level.
Roger. Proceed.
And the team is on the way to the pad. Let's send it back to the host desk.
Let's actually send it back to Lauren and Dylan in the ASOC as we continue to watch Butch and Sunny drive out to the launch pad.
And Megan, we do have an update now for viewers on the helium leak situation. We are told by teams, we have confirmation the leak rate remains acceptable. In fact, they tell us it looks better than before. So good news there. We've been waiting to hear how that leak check went this morning, and all things look good. So we are moving ahead in the countdown. Everything is on time as we see the crew head over to the pad at this moment. And our pad team has been inside Starliner
Starliner, making sure everything's ready for the crew. Their inspections are complete. The pad team today is made up of 5 people from Boeing and 3 from ULA. You may also hear them referred to as the Blue Team. And we did just hear a call moments ago that one of those pad team members has been cleared to head down to escort the crew up. So we will see Butch and Sunny get out here shortly and head to the elevator, escorted by one of those pad team members. This is, of course, the 3rd time for both of them to go through these motions. They have done it with now 3 different rockets and 3 different spacecraft, including Shuttle and Soyuz.
160 crew transport vehicles entered pad. Roger. Crew is clear to proceed to level 12. Roger.
And Sunny says that this is a test pilot's dream to be on this flight. She says she feels like she won the golden ticket. We've also heard Butch talk about how much he loves this spacecraft for its agility. He has even joked at times saying that he could do barrel rolls around the ISS if he wanted to. Of course, we won't see that happen, but he likes to say that that is just how nimble the spacecraft is. And of course, they have a lot of experience in different spacecraft.
Crew transport vehicle has arrived at CAD.
Roger.
And Dylan, this crew feels very confident with the ride to space on the Atlas, which has a 100% mission success rate.
Yeah, Lauren, that's right. The Atlas V Starliner configuration was designed with an absolute commitment to safety. It's one of the most reliable rockets in the world, and it carries an extra layer of safety for its specialized duty launching astronauts to the ISS. The Emergency Detection System, we call it EDS for short, was developed by ULA engineers to enhance the protection of astronauts riding atop Atlas V by autonomously monitoring the health of all the launch vehicle systems. If the system detects an impending anomaly, it can trigger an abort much faster than any human could do so, but the astronauts also have the capability to trigger an abort if required. Along with that EDS system, we have a dedicated Ascent flight control team on console in Denver during the flight and any human spaceflight mission that we support. This team monitors the health and performance of the rocket during ascent to space. Our engineers provide real-time status and collaborate directly with NASA's flight director and mission control in Houston. When you hear the call sign Atlas, that's our ascent lead, and he'll be providing real-time telemetry data from the rocket and provide continued situational awareness.
Crew is entering CAD elevator.
All right, Dylan,
Roger.
as the crew is heading into the elevator, we are going to send it back over to Megan, Dee, and Mike.
Now, Mike, this is different from the first launch attempt. Before they got out, you were with them, you took pictures of them viewing the rocket. Today, they opted to just go straight to the elevator.
Yeah, I think they probably miss me a little bit, but it's also they've been there and done that. And today is really about focusing on the mission. So they took a few. They didn't take a few extra moments to appreciate the Atlas and Centaur, breathing and living, and they went straight to the and they're going straight up the elevator right now, straight to the rocket. And I just know what it feels like stepping out of the Astrovan, and here they are getting ready.
On level 12.
Getting ready to get inside, and it's just it's a great feeling of satisfaction and accomplishment to be here at this day at this time. This is something that the whole team has been working for many years.
And you know what's different, obviously, since we're launching during the day, they had great views of the rocket on their way to the pad. So, like you said, they probably had their opportunity to look at their ride to space, and now they just want to get in. So now on level 12 of the crew access tower, we see Sunny there with some of the pad team members. Butch went into that door there. That's a bathroom, and this is an important step in the countdown, obviously.
Yeah, well, I was on Daniel Tiger, a TV show, and we had an episode called "Go Before You Go," and so this is what we teach all of our kids: is before long missions, you should go to the potty.
And you know this from the last time. So on their ride out in the Astrovan to the launch pad, they stole your phone, right? And they made some phone calls. I just heard that they also made another phone call while on their way out. They called Mark Sorensen, the crew module lead for the crew flight test, again, while in the Astrovan. Pretty cool that they are taking these opportunities to acknowledge, again, all the folks who have helped bring them to this moment.
Yeah, Mark was a production manager, and he made sure that Starliner was ready for flight. Great teammate, and I'm glad he got a phone call.
Yeah. A view of the crew access arm from our helicopter that we have flying around the pad right now. We see Sunny there on the railing taking a look out. Yeah, you can get a great view from up there. Who needs to get out of the Astrovan and recline up?
So yeah, this is the last time for a while that Sunny's going to have the breeze in her face and the smell of the ocean air and the joys of being on planet Earth. Now she's going to see it all from a great distance.
And here it looks like Butch is now back with the pad team and
Slick
Sunny.
on launch ops.
An ordained minister, probably
Or
leading
sorry,
them
on
in
channel
a
1.
prayer now.
Go ahead, Slick.
Yeah, crew has arrived at CAT level 12, and our CTV is standing by for OSM direction to return to the fallback area.
Roger. OSM, LC?
OSM.
Roger, we can give go ahead for the CTV to clear the pad.
Roger that.
A nice moment here before the hard work of ingressing into the spacecraft and launching to the International Space Station.
Well, they just cleared the crew transport vehicle to go away, so Butch and Sunny are stuck there now, so they might as well go launch.
And here they are walking across the crew access arm. Butch stopping to take a quick look at his spacecraft and launch vehicle.
And you can see they stepped on that little white sticky mat to make sure that anything that they may have had on their boots doesn't get inside the spacecraft and possibly into the space station. We do try to keep a very clean ship both up and down and aboard the space station. Looks like they're saying a quick prayer for a successful mission.
Yeah, these are other pad team members who are in the White Room now with Butch and Sunny. The White Room, a literal name for this room from back in the Gemini era, to quite literally describe this room that will be the last stop before they get into the Starliner spacecraft. It's environmentally controlled to keep out dust and dirt and humidity.
It's actually a little bit overpressured, so it has more pressure inside so that no air can come inside to the White Room, and it all blows out. So even the door that goes to the White Room was always cracked open a little bit to let the extra air out. And this is how to keep the particles from getting inside the spacecraft.
So for the first launch attempt, to the left of the hatch was a mission patch for CFT, and Butch and Sunny took the time to sign that. Now they are heading straight into the ingressing process, which is again to get into the spacecraft, and we see pad team members there helping get Butch situated.
Certainly, this crew is being the first. They get to start a whole bunch of new traditions, all the way from the 31 CAT card game to signing a patch in the White Room. So this is different than what we did, of course, with the Space Shuttle, but yet similar, right? And so it kind of takes some of the best traditions that we learned from the Russians with Soyuz and the American traditions, and has a nice blend to make something new. We do know our pad team very well. They've trained with us and trained us. So we especially now after this second launch attempt, it looks like Butch's wrist light is working. He has a good sense of humor, and so he showed it to us that his wrist light was working. It is a little bit dark sometimes in the capsule, so inside the spacecraft, so having an extra source of light, like we all do at home. We have our cell phones. We use that to light the way, but we don't have cell phones, so of course we have an extra wrist light.
Yeah, off to the left side, off camera a bit, pad team members are going through what's called his helmet bag, right, Mike?
Yeah, Boeing designed and manufactured this helmet bag that has everything that you need: the gloves, the crew head protection, the chippa, as well as any wristwatches and wrist lights and things like that, and as well as the ascent and entry checklists that were needed, and the crew knee boards. So everything that you need is in one place, and you know where, and they bring it to the pad with them. There's also a spare helmet bag that has a few extra things in case. a Chippa.
Request permission to perform Centaur LO2 transfer line rechill.
Roger. First aid.
Yeah, in case a Chippa gets broken or glove is missing, we have a few spares available.
Team lead, LC.
The launch conductor's
LC,
calling.
OSM.
Go ahead.
Yes, sir. For step 160, 16 personnel have exited the FHA roadblock.
Roger.
Just a call out there to mark that folks have left the pad as well as the flight hazard area. So the area that's designated as where we don't want people to be if they don't have to be. So that's that call out there. And now we are watching Butch getting settled into Starliner. And Sunny is currently outside. What we'll see is Butch will fully ingress and get himself situated before Sunny ingresses. So to walk us through what we're about to see with Butch, let's head back over to the ASOC with Lauren and Dylan.
Hey, Megan. Yeah, we just saw Butch sort of slide across the seats there to get into his captain seat. That is what this first position is known here as. And Sunny, of course, will ingress second because her seat is just a little bit closer to the door. She will sit right there next to him. And they actually showed us how close they sit. And it was an interesting demonstration because for them, it felt like a lot of room. For us, it may not, but they just kind of showed us like, if you were sitting in two chairs side by side and you had plenty of elbow room, that's how they feel. In other spacecraft in the past, they've been a little more jammed in there. So they're really happy about the extra space they have in there. And Sunny won't start that ingress process until Butch is completely in and ready to go. This whole process takes about 20 minutes or so. These seats that they're going to be sitting in today are built to accommodate astronaut height ranges from as small as 4'11" all the way up to as tall as 6'4". They're made of aluminum, and Sunny's even told us that she and Butch were part of the process to make them a little bit more comfy. And another thing they really like about these seats is just the orientation of them. She said on shuttle, when you land on shuttle, you're in a upright position as you're sitting almost in a chair, but they will be landing on their backs in Starliner when they touch down on the ground, which has, since the shuttle days, been determined to be just a little bit of an easier way to land. So she and Butch are very happy about that. We do have other seats in Starliner. The third and fourth seats are filled with cargo today. The fifth seat has a flat plate on it to give them just a little bit more space in there. And you see Butch he has some paper procedures in his hand. They will both be using those paper procedures as they make that ride up during the ascent process. And then once they get into orbit, they'll be able to pull out their tablets and use those. The console there in front of Butch, you could probably see him reaching around and doing some things in front of him. That is a display that is a mix of screens and switches and knobs. It has two hand controllers, which make this spacecraft a very unique spacecraft. They have the ability to take the control of the spacecraft literally into their own hands if they want to. We have heard him talk in
Blue Team
weeks
lead, LC.
coming up to this point about
ahead,
how they are able
just be
to
advised,
do.
we're going to perform a LOX rechill at this time.
Roger that. I'll alert the crew.
Roger.
How they're able to do what they call a backup mode, or also a manual mode. So we'll hear a little bit more about those things later.
And LOX 2, you have a go to proceed.
Roger.
And the console's been simplified for maximum efficiency. Anyone who followed along with the shuttle days, the shuttle had thousands of switches and indicators, but Starliner only has 85. And the crew has told us they really like to be able to get their hands on those switches and of course on the hand controllers as well.
And we have confirmation that the prop system is activated and the pressures are as we expected. So things are going smoothly in the countdown. And Dylan, our team's really started working several days ago. The countdown didn't just start this morning for us.
Yeah, that's right, Lauren. The countdown actually started back on Thursday when we rolled the Atlas V at Centaur with Starliner atop. We rolled it from the VIF out to Complex 41. The VIF is a vertical integration facility. It's just about 1,900 feet to the south of the launch pad there. So once the rocket arrived at the pad, we started connecting it to all of our pad utilities. So that's the pad air conditioning system, the pad electrical systems, and all of our propellant transfer systems. So the hydrogen and oxygen for Centaur, and then oxygen and kerosene for the Atlas booster. Once all those connections were made, we powered the rocket up, gave it a health check, and did a little bit of testing on that on Thursday afternoon. Then powered the rocket down and secured it for the what we call a crew sync day. When we have a countdown that starts late at night, we will essentially have the crew start to shift their schedule, so there's no planned work on that Friday. Then we came in overnight and powered up the rocket again for our activities today. The rocket remains ready, waiting on the opening of our launch window and the loading of Butch and Sunny, which, as we know, is going on right now. All the activity on the launch pad is really up there on the crew access tower. You talked about the members of the blue team. So we have 3 members, the ULA teammates on the blue team, and those folks are there really to manage all of the crew access tower systems. So when they're given the go to go back out to the launch pad in preparation for the arrival of the astronauts, the first thing they do is toxic vapor checks. So they have some test equipment, and they just go make sure that the atmosphere inside the white room is safe to breathe. And when all that is done, they'll start to prepare the white room for the arrival of the team, which, as we saw, has gone very, very smoothly so far. Once the astronauts are loaded and the Starliner crew is ready for the hatch to be closed, and once all those closeouts are done, then our team will pick back up and start to configure the crew access tower's hydraulic systems in preparation for retracting the arm prior to launch. But for now, our team is really kind of just standing by as Butch and Sunny get situated in the Starliner and waiting on the opening of our launch window today at 12:25 and 40 seconds.
So there on the smaller screen where we're still watching Butch get strapped into his seat and getting his gloves on, as you can see there, we have 2 pad team members working with him, and one is Armando Lally, the other is Garrett Pender. So these 2 work the entire time inside with both Butch and Sunny to get them ingressed into the spacecraft. You may have seen a few seconds ago, Butch was sort of moving his legs up and down. They have stirrups there for their legs to go into with straps that one goes over their foot and the other goes over their knees. And you can see he's getting a good adjustment on his gloves at this time. I actually have had the opportunity to try these gloves on, and you'd be amazed at just how much you could do with them. They're very flexible, and of course that's important when they have so many things to be controlling there with their hands. They also have a 5-point harness seat belt that they're going to be helping them get into. There's a little bit better of a shot, a close-up shot. The cameras that we're using inside the spacecraft, we refer to them as the Mustang cameras. It's a system of 4 cameras, so we have some different views where we can monitor what is going on inside the spacecraft. Those views will not be live today, but as soon as we get to the International Space Station, we'll be able to download what is taking place with the crew as they are on their way up, and get a great look at that. The countdown is still going smoothly in the background. Dylan and I, of course, are listening to all the chatter on the loops.
Yeah, and thankfully not much to talk about right now. Actually, everything is cooperating, and the team is really just watching the vehicle, make sure it remains stable as we get our astronauts loaded.
We like when it's quiet. You can see there at the bottom, sort of right side of your screen, the umbilical hookup on Butch's chest. So they'll be doing some comm checks and suit fan checks here shortly. That umbilical area is where they're able to put a comms cable through, and then also that'll be like a small black cord that we'll see, and then we'll hook up an air supply to that as well. It'll be a blue hose, so that's when we see that, that's how we'll know. Butch, of course, a former flight test instructor at Edwards Air Force Base with a Master of Science in Aviation Systems. Here is more on retired U.S. Navy Captain and CFT Commander Butch Wilmore.
A large part of the desire within us is to do things that are of benefit to others. In this job, we get to do things that are of benefit truly for all mankind as we explore the heavens that not many people get to experience, true, but we don't go just to get the experience. It's about the team and it's about the benefit that it brings. My name is Butch Wilmore, and I am the commander for NASA's Boeing Crew Flight Test mission to the International Space Station. Life in Tennessee, God's country, that's where I grew up. Very fortunate, had loving parents, took us to church. When I was young, 7 years old, I believe, they bought a little land out in the country, 6 acres or so. We had horses and cows, and I raised chickens and ducks, and just enjoyed life in the country. I went to Tennessee Tech, started working on an electrical engineering degree, and played football, which was a very difficult combination, I learned, because they're both full-time jobs. So it was a lot of effort over those years, but it molded me and it helped instill the work ethic my parents had instilled in me when I was younger. I entered the Navy and was fortunate to fly the A-7E. It was a single-seat attack aircraft, and I flew that for a couple of deployments. And then I transitioned to the F-18 Hornet, and through that process, was selected in the test pilot program. You learn a lot about yourself as you go through test pilot school, where you're lacking in certain capabilities that are necessary to do a test pilot type of job. When it comes to flight test, the minute details matter. When we're doing our runs, hey, well, let's run it this way. Let's do it that way. Let's add this in. Let's take that out. And let's look at it in that regime so we can see how the spacecraft responds. And that's what you do with aircraft, that's what you do with spacecraft, and that's what this test is all about. This crew flight test is a series of these various tests to ensure that the operational requirements and the design meets those requirements. And I think everybody that does flight tests would agree. Focus, understanding, and also the team coming together to give you the overall understanding of the test and the capabilities of the spacecraft or aircraft that you're testing is vital. Sitting in this seat over here in the Starliner sim and doing the things we've done and learning about the spacecraft, developing a lot of the capabilities of the spacecraft, it's very humbling when you see and you interact with some of these professionals, and our human spaceflight and our nation has a debt of gratitude to them. Every single training evolution we have is brand new. We're the first to do it. Whether it is checking the survival equipment in the pool with a mock-up of the spacecraft and how you egress, get out of the spacecraft, whether it's the side hatch or the upper hatch, while the seas are rough and all those type of things. There's a thought of how things should be, but then there's the reality of how things need to be. And that's what this test is all. Everything we do is test. It's been a process over years that is such a benefit in all aspects of the capabilities of this spacecraft. And we're excited to be a part of it.
And, hearing Butch talk about this is a test flight, he and Sunny have been an integral part of really every aspect of the development of Starliner. They are so integrated with our team and, are able to make changes, say if they don't like something or they want something to be different. They really are the first two to pave the way for their comrades in the astronaut office. So when they get up into space, they're going to put the spacecraft through the ringer. They are both test pilots at heart. It's what they did in the Navy, and they love this job. I think I mentioned earlier that as Sunny said, she feels like she won the golden ticket. So that's pretty cool to hear that from the very first person and first woman to be doing this test flight on a spacecraft that's going to the ISS.
Want to tell you a little bit more about these pad team members because they work very closely with Butch and Sunny. And the two that I mentioned that are inside the spacecraft, Armando Lawley, he is there just to Butch's right. If you happen to see, he'll have the number 5 on his back. You can't see it in this shot, but you might be able to in other times. He is the senior project engineer covering Boeing's Florida Space Coast. He's also a private pilot, so they have that in common. And in the past, he's worked on F-15s, F-18 Super Hornets, and 777, all for Boeing. He has been part of the build and development of Starliner really since the beginning. So he's been waiting a long time for this day, just like many others on the program, and he could not be more excited. It's pretty cool to interview him because he just really beams with excitement over this flight and this crew. And he has a great relationship with them. And then our number 6 is Garrett Pender. He is over there toward the back of the screen. You might be able to see the 6 on his back as he's sort of turned around there. He's a mechanical technician, and he's the one who will actually close the hatch today. He helped build the rig that opens and closes the hatch, so he has a true attachment to it. And you can see him there. Armando just passed something over to him. And his teammates say that he's really the guy who can just fix anything. So great to have him on the team. We see number 4 there. That's Nate, and he is the pad team lead. He's a test engineer manager. He manages the fluids team who performs a variety of tests from leak checks to acceptance testing of integrated vehicle subsystems. You can see another look of him there. Number 7, that is there close to the capsule, that is Michael, and his teammates call him the Chief. He's a systems engineering technician. He performs all the final cabin leak checks, and this is an amazing stat about him. He has worked 110 launches, including this one. So he's been around the space program for a while. He said that he is a child of the 70s, and he said when Butch and Sunny take off on their ride today, he's going to tell them it's time to rock and roll. You see Sunny giving them all hugs there. And she is starting to get into the spacecraft now, so as they check her feet to make sure there are no foreign object debris, or FOD as we call it, we are going to send it back over to Megan, Dee, and Mike to walk you through Sunny's ingress.
Yeah, so right now we see Sunny stepping over the seal around the hatch there carefully, and the 2 pad team members that are inside the capsule who have been helping Butch get in will now do this exact same steps for her, essentially.
Exactly. It's a little bit easier here because Butch is fully ensconced behind the integrated crew control panel. They have a little bit extra room from the side to work with Sunny, so that's going to make it a little bit easier process. But the nice thing about this is that we've practiced this a lot now, and I know Sunny's feeling happy, and we just got to watch out Butch. He might take a small micro nap here because he's all set and ready to go. But Sunny's still getting strapped in, and we've gone through this procedure a lot.
A micro nap, so just an opportunity to kind of, decompress a little bit, or?
It's a little bit of a Zen moment, and it just helps. It's scientifically proven that I've read that it helps a quick recharge because they still have a whole full day in front of them to get into orbit and to get headed towards the space station. They'll have a chance to sleep overnight, and it's always hard to sleep in a new place, especially when you're adapting to zero gravity.
I do want to mention that they were in Starliner just yesterday, right, Mike? They were specifically going in there to see if one of the things to see if the configuration would be different because Starliner is now carrying up that urine processor, correct?
Yes, they had to kind of move things around on the inside of Starliner. So, and Butch and Sunny hadn't seen the spacecraft since the first launch attempt on May 6th. So yesterday they climbed in, not with their flight suits on. I mean, not their space suits, but their regular flight suits, and they got a chance to do the comm checks, make sure everything's going to be good for today. And then they also checked out the cargo configuration, because it is a little bit different. But it is important that the space station program has this 150-pound-ish bag urine processing pump, because that'll help the water to keep getting recycled aboard the International Space Station.
Yeah, talk to us a little bit about this urine processor and how important it is, and how great it is that we do have Starliner flying up there today.
Yeah, it is. It is really cool what we've done by having the International Space Station as a test bed for exploration, which means that we've learned how to recycle over 97% of our water. So especially like during the shuttle program and early space station, we didn't recycle all of our water. We were like at 30%. Now it's up over to 97%, and this regenerative Eclipse technology, the good things and the bad things we've learned from it, we can definitely use for the Moon and Mars. So for the International Space Station, it takes about $5,000 to send a liter of water to the space station. So it's good that we recycle it over and over. But 97% is great. On the Moon, it's going to be really hard to get water there, so we're looking to use the water that we find in the south pole of the Moon. So this is all really interesting and exciting. But one of the things we recycle is urine, right? So this urine processor has a pump to move the urine fluid to get fully purified. And so it broke recently, and the space station program was very fortunate to have Starliner available as the next ride up to space station. So this urine processor will help us aboard space station not to have to keep a lot of the urine stored in big bags off to the side. We'll be able to recycle it sooner than later.
A beautiful aerial view now of Starliner. Again, we've been looking at views inside with both Butch and Sunny seated in Starliner.
And I think the Boeing team should be really proud. They worked very hard to put that Starliner together, and boy, she's beautiful. This is Calypso, is the name of this particular spacecraft.
That's right. Actually, we have a picture. Let's see if we can pull that up early, since you did mention it. So the spacecraft, there it is. The spacecraft is named Calypso, as you said. Sunny named it Calypso in 2019, and it's after Jacques Cousteau's ship that he sailed all over the world to teach people about the ocean, and Sunny believes Starliner will do the same for space. So again, a picture of Jacques Cousteau there. Starliner named Calypso as his ship was named Calypso. And speaking of Calypso, be on the lookout for a zero gravity indicator that the crew picked. We saw it in the first launch attempt very briefly. Again, a zero gravity indicator is usually a soft toy that a crew picks to fly with them. And once the toy begins to float, it's that visual indicator that they have reached the weightlessness of microgravity. Because again, they are buckled in, snug, safely in Starliner. So really the only thing that should be floating around is that zero-G indicator. And Sunny's niece and nephew helped her choose this zero gravity indicator. You see it right there. She's holding it. A narwhal. It's a kind of toothed whale. Male narwhals are the ones with the signature single straight tooth or horn. Sunny wanted to choose an indicator that raised awareness for how space and ocean research go together. After all, you know, space gives us a unique vantage point of our oceans. This particular narwhal toy was coincidentally also named Calypso, which is part of the reason why they chose the toy. And just so we get a better view for it, because it is kind of hard. So what we expect to see, right, is Sunny after she is buckled in and she does her comm checks as well, her communication checks as well as her suit leak check. They will pull the zero gravity indicator out of her helmet bag, and they will then tether the toy. And here is a closer look at that zero gravity indicator. It is very sparkly.
Very sparkly.
I love it here. And yeah, like I didn't know that it was actually already named Calypso, and that was why I thought Sunny also named it Calypso. But really, I mean, this is great because she does have a love of oceans, right, Mike? So this is just serendipitous, right, that we found a narwhal named Calypso already.
It was meant to be.
Yeah, talk to us about her love of the oceans and ocean research.
So Sunny grew up in both Ohio and Massachusetts, and she's very close to the Woods Hole Oceanographic Institute, and she's spent a lot of time as a Navy person and a graduate of the U.S. Naval Academy on the ocean. I actually had a chance to live with Sunny under the ocean in the NASA's NEMO Extreme Environment Mission Operations program. We lived 50,000 millimeters under the sea, and it was great to see her love of. She was our science officer. It was great to see her love of the ocean and how well she scuba dives. So yeah, this connection with the Navy, with narwhals, with nature, with Earth, as well as the name of the exploration vessel that got to know the oceans better with Jacques Cousteau is a perfect name for an exploratory spacecraft that's going to go fly soon.
And you mentioned the fact that Sunny once lived underwater for 9 days while working within the robotics branch of the International Space Station. So why don't we learn a little bit more about her journey? Again, the retired U.S. Navy captain, Boeing CFT pilot, Sunny Williams.
Exploration is curiosity. It's asking the question why. It's taking that next step. Every time we do something for the first time, we're expanding our knowledge. My name is Sunny Williams, and I'm the pilot for NASA's Boeing Crew Flight Test Mission to the International Space Station. I feel really lucky to have grown up in a small town outside of Boston, Needham, Massachusetts. It was a great town because we were able to ride our bikes everywhere we went. My brother, sister, and I, we were all swimmers, and it was just a great childhood. My dad was a doctor and also did neuroscience research. We were the strange family who had pictures and diagrams of brains on our dining room table. My older brother went to the Naval Academy. I started researching a little bit, and I thought, well, what the heck, I'll try this out. And when I went, I found that I really loved it. Teamwork, followership, leadership, those opportunities that we had right from the very beginning, and to accomplish something a little bit bigger than yourself. And I think that paved the way for the rest of my career. Got a basic engineering degree from the Naval Academy. I really didn't know what it was all about when I went through that course curriculum, but when I went to test pilot school, all of that stuff sort of gelled together. I was like, oh wow, this is why we do math modeling. This is how we try to predict how changing an engine is going to affect the way the helicopter flies. Time on the International Space Station is priceless. People always ask, do you get bored, or, is it terrible being up there for a long period of time? And for me, I loved every minute. There was always something to do. You wake up, you look at your timeline like, wow, I got to do this experiment today. I got to get ready for a spacewalk. Every day was different. And just life on the space station becomes routine, which is sort of crazy to think about it. At one point in time on my first mission, I was like, I don't even remember really what it's like to walk. I've been flying around for so long. I don't even know what it's like to sit down. I got assigned to the commercial crew cadre in 2015. We went to the companies, found out the shell of their programs, and then actually started working with them to make them what they are today to accommodate astronauts. For Starliner, we've been heavily involved in the last couple of years in the software with the folks doing the development to make sure its capability will allow us to come home. And we've been involved with all the suit development, making sure every different size of person could fit in all these suits and they could operate the spacecraft adequately. We've had our fingers on every single procedure that we work inside the cockpit, as well as operated it with our mission control team to make sure that everything that future crews will do will be right. We haven't had the classic training as we had for Shuttle and Soyuz. We've sort of helped develop the training as well as the hardware. And this is sort of the shape of things to come as we get ready to go back to the moon. All of that is going to be developmental, and we're going to have the same mindset. It's not already established. We all have to be part of this big team to help develop it and make sure that integration, as the astronauts use all this equipment, is going to be top-notch and ready to take us even further.
Really cool to see both Sunny and Butch's background, and again, you know, how they've got to this moment. And they're different backgrounds, right?
Absolutely. Even though they were both in the Navy, they both approached things quite differently. Sunny came to us in 1998. I remember when she first arrived, and then Butch came to us in the year 2000. And Butch focused a lot on space shuttle. Sunny and I worked together in Russia a lot. She picked up Russian language super fast, and so she flew aboard the space station pretty quickly. But it's been nice to see when Sunny joined us for CFT that how well she and Butch get together or work together as a crew, and how well they get along, and they're a great team for a great mission.
A check of the clock, 2 hours, 24 minutes, and 25 seconds until liftoff of NASA's Boeing crew flight test. The first time astronauts will fly on Starliner's spacecraft, the Starliner spacecraft that you see right there on top of a United Launch Alliance Atlas V rocket. Another beautiful aerial shot of the spacecraft and rocket on pad 41 at Cape Canaveral Space Force Station. Now, I don't know if you can hear it in our mics, but the winds have really picked up here at the host desk, Mike, but it seems like they're still within the acceptable range to fly, but we definitely feel it out here.
Oh yes, well, it's a nice cooling effect, but I do think our weather team is all over it, and they're watching carefully so that the offshore winds or onshore winds in this case will be safe, and so we're still keeping an eye on it, but all predictions show that we should be okay. We'll find out. I do have some breaking news from Mission Control Center in Houston. Butch and Sunny, they just had a taco breakfast delivered to the flight control teams, just because they're thinking of other people, and that's what's really neat. I didn't get one here. I don't think we got one, but I know. But I'm really happy for the guys at the Mission Control Center. So thanks, Butch and Sunny, for looking out for others.
Oh, that's really sweet. Yeah, it's been very thoughtful. The whole broadcast so far, we have seen them call people, acknowledge people, hand out flowers, and now a taco breakfast, huh?
It does look from appearances that we might be running a little bit early. Again, our timelines are built for 4 people, getting ready for Starliner 1 next year.
Go check 5. NPRV, unlock, extended, and caster push station. Pad copies all.
So that's the negative pressure relief valve right behind.
Coming out. Pad. Copy 202 monitors being removed from the vehicle.
Right behind Sunny's head, and they are getting ready to close out the cabin and pretty soon close the hatch. So it looks like we're running
Starliner crew, it's been an honor not to stop in my group with my friends. Anything else you need help with before we leave?
This is Armando Lolli, one of our closeout crew, and we're really good friends, and he definitely is, along with the rest of the team, is making sure that Butch and Sunny are ready to go.
Yeah, for those just joining us, again, if we look at the clock, 2 hours, 21 minutes, 45 seconds until liftoff. And yes, the team is ahead of schedule in a nominal timeline, as we call it. You know, they were expecting to maybe be done with the crew ingressing or getting into the spacecraft at around 1 hour and 37 minutes before launch. And as you can see, they are done well beyond that time.
LC Fuel 2.
Go ahead.
Just wanted to make you aware that my topping valve I to P has failed and dropped to 0.
Roger. AC, LC.
AC on 1.
Roger. Fuel 2's reported a I to P has given an anomaly. Please screen the anomaly team and provide a recommendation.
We'll go.
LC Locks 2.
Go ahead.
I've just experienced a similar anomaly with my LOC 669 FCB I to P as well. Topping valve locks also commanded and is currently 0.
Okay, so you're in a stop flow effectively?
That's a firm, not flagged, but the valves are all closed in the skid, so we're not closed in the vehicle.
Copy that. Yeah, AC also for Locks 2.
Copy that.
Yeah, we can hear the launch conductor, Mr. Lebo, Doug Lebo, working some small anomalies right now that just popped up, some sensor indications for some loading valves. We'll see how the anomaly team works on it, but this is kind of how launches go. They receive some data and start looking at it and see what's possible and what to have to work on. So we'll hear more about that. In the meantime, it looks like they're getting ready to close the hatch.
Starliner Houston for the entire crew, comm check on air to ground 1.
CDR, loud and clear, air to ground 1. TLT, loud and clear, air to ground 1.
Starliner Houston has both crew members loud and clear, air to ground 1. Stand by for a comm check of air to ground 2 via the T0 line. You're going to hear me and reply on air to ground 2. Stand by.
That's Josh Kutrick, the Capcom, my crewmate for Starliner 1.
These continued comm checks to make sure that everyone who needs to talk to one another can.
Well, communication is important, especially in a big team sport, so like spaceflight. So it's good that it all works.
Loud and clear, air to ground 2. And Houston, TLT, loud and clear, air to ground 2.
And just to set expectations for our viewers, they will continue to hear comm checks almost up until liftoff. Like we hear them even within that final half hour, just to make sure that everything is still working as it should.
And right now we're talking through a bit through the umbilical, the T0 umbilical that connects. And after that, after a while, they're going to take that umbilical away. So it'll be good. It's good to know that they're ready to talk over the satellite system, TDRS.
Right, there's different pathways of communication that they have to
Houston
test.
on air to ground 1, audio system checks complete. In 10 seconds, it will be L minus 2 hours, 18 minutes. 3, 2, 1, mark. L minus 2, 18.
Good check.
Copy, good check.
LC Slick on channel 1.
Comm panel. Lift
Go ahead,
off
Slick.
on air to ground 1 and 2.
Crew insertion is complete.
Roger.
All right, you heard that call out. Crew insertion is complete.
Listen only on air to ground 2 just makes it a bit easier for us.
That's what I figured. Okay, there's air to ground 1 only talk.
Okay, copy.
So
Houston and
LC.
Rio getting clear here, so it's all working. One other note from us is a thank you. Everyone here is enjoying a lot of breakfast, and we understand that you two had something to do with that.
Roger,
so
you also command a stop flow
thanks.
at this point.
We'll go.
Field 2 is complete.
Hey, it's our pleasure. A well-fed team is a well-ready team, so we are happy you guys are well-fed.
You heard those communications there, Mission Control in Houston, thanking Butch and Sunny for sending a taco breakfast to them, and Sunny saying a team well fed
Channel 1.
is ready to launch them.
Yeah, just for your awareness, we're troubleshooting a control issue on both the Centaur locks and hydrogen topping valves. So we're currently have both those tanks in a stop flow condition, so we're not actively topping at this point. No safety concern at this point, but just want you to know we're troubleshooting that.
Roger.
Yep, flight copies following on channel 6. Roger.
So those communications between members of the launch team acknowledging that they are currently watching an issue with a control center, with the control center locks and hydrogen topping valves. Mike, can you talk to us about what topping is? What are these valves? Really break it down for our viewers.
Certainly. The Centaur is the second stage. We're kind of looking at it right in the center of the screen right now. It's a little bit thinner than the rest of the rocket and spacecraft. It has two. This one's a dual engine Centaur, meaning it has two RL-10 engines, and that allows the Starliner, after it gets off the booster phase, the first stage, it goes. It can fly us in a really nice shallow trajectory over the North Atlantic exclusion zone to give the crews more chances in case of abort. So the Centaur is a well-proven upper stage. We've used it quite a bit in the U.S. space program as well as for national security launches. It uses its engines use liquid oxygen and liquid hydrogen, which is super efficient. Tory Bruno, the president, calls it of United Launch Alliance, calls it a Porsche or a sports car of engines, very high specific impulse, so it gets great quote-unquote gas mileage. Liquid hydrogen and liquid oxygen are wicked cold, as they would say in Sunny's Massachusetts. They're very cold, and so you can see it kind of some liquid oxygen right now boiling off right under at the bottom of your screen there. And what they do for topping is that as the liquid oxygen normally boils off, just because even no matter how insulated you make it, it's still going to turn from a liquid to a gas. That they top it off, and it sounds like both for liquid oxygen and liquid hydrogen. And so in this case, it sounds like that the top off valves, they were having some issues with them, and they're looking into it. And I'm sure these are things that United Launch Alliance has perfected over time. So we'll see what answers they come up with as they work together on the anomaly team.
Yeah, and I think it's really important. We did hear them say no safety concerns as of yet, and then we heard them say, we're going over to channel 2. So we have been listening to, again, communication loops or nets between the different members of the teams monitoring today's launch, and essentially you hear some of the public loops, public communications that go out, but they also go to different channels so that they can work all of these different issues. So that's what the team is doing right now, but in the meantime, we are still proceeding towards launch, and again, are early in the countdown. They were expecting to be closing the hatch around 1 hour and 37 minutes to launch, but here we are at 2 hours and 13 minutes to launch. We see Butch and Sunny inside Starliner, and I don't see any pad team members because I believe they have, they're all outside there of the white room. So basically what's happening now are hatch closure preps. So the pad team has gone through the Starliner spacecraft to make sure anything that isn't supposed to be in there is taken out. And now, Mike, they are outside and making preparations to close the hatch.
Yes. One of the things that we have, or the seal around the hatch, is really important to maintain a hermetically sealed capsule so it can keep the air inside. So we have I think you can see it in the picture, a golden frame that goes around the hatch seals to protect them as people go inside and out, that they don't harm the seals. So they're going to take off the hatch seal cover and then do an inspection and then close the hatch. They've perfected the procedures over time, so this is something that the pad team is really good at.
And there are methodical steps to hatch closure, as you were saying. Again, making sure that they're checking the seals, the framework. There's also like support structures, right, that they need to move out of the way before they actually close the hatch.
That's exactly it. And that's pretty important. But the really neat thing is that once they close that hatch, it will not open again until they land somewhere in the southwestern desert of the U.S.
Yeah, that's
so
crazy, huh?
They need to make sure it's leak tight.
Again, beautiful shots there of our Space Coast.
This is the first time I'm going to see a Starliner launch. I missed the first two. I was in helping support the mission in the Boeing Mission Control Center. So I'm personally looking really forward. It's right behind us, and looking forward to seeing the beautiful rocket launch.
Again, a big thank you to you for being here. I know that the first time around you had a pretty cool role as well. But again, all of that insight, your intimate knowledge of both the crew, but also the procedures, the mission, really invaluable to our viewers, and really explaining why this launch is so important.
Well, thank you. I enjoy my job. I've been an astronaut for half my life, and I love it. And I'm hoping that we're talking and reaching out to future astronauts out there, because there's more and more with Commercial Crew Program and other things. We're able to send more and more people to different places in space, and this is a great mission to be part of. And I'm enjoying sharing it with Dee and you, Megan.
2 hours, 10 minutes, and 8 seconds to launch. Again, this flight test is a big deal. It's only the
2 hours, 10 minutes.
6th time that NASA astronauts...
Elsie. Go ahead. Adjust the safe flow rate to 170 pounds per minute.
Roger.
Only the 6th time that NASA astronauts will fly a new crew vehicle.
And here on NASA TV, we're all sharing this adventure together.
When last asked how Butch and Sunny, each of them respectively, might feel once they're in Starliner on launch day, Butch said he couldn't wait to get in there and see real data and telemetry. I see that he's woken up from his micro nap, as he said, and now he's looking at telemetry there.
Yes, we have a really nice simulator system back in Houston, and with the Boeing company, they have...
LC on one, this is RLM.
Go ahead, RLM.
Yes, sir. I have received, it appears, 4 OTCs at this time. The first one is line item 326, and LH2 Delta P. Looks like they all 4 are.
Roger.
Data's out of tolerance.
Roger. Understand, and that's a result of us not topping at this point. Are all 4 of those OTCs Delta P related?
Yes, sir, they are.
Yes. Okay, let's continue to monitor that while we're troubleshooting the topping valve situation.
I copy.
Right.
I think that was some conversation that talked about with their stop. They stopped topping the second stage, the Centaur tanks, so they were receiving some more telemetry saying, "Hey, we're not being topped right now," and so they're saying, "Yep, that makes sense to us. They're going to continue troubleshooting and see how it progresses."
Communication is so important, because for people who haven't been in a launch control room or really followed us to this degree, there are so many people who are specialized in certain fields and certain parts of what it takes to launch a rocket to space, a crewed spacecraft as well, that you really need to be communicating as much as possible so that we can troubleshoot any issues.
And that's something that I've noticed as my kids have gone through school, is that they've learned how to, been focused more not just on reading and writing and arithmetic, but also on how to work together in teams and how to communicate with each other effectively. And these are great skills that we need in the space program, and certainly great skills that we need as fellow human beings on any team that we're on.
Yeah. So we're looking inside of Mission Control at Houston, and again, all these different consoles have different teams that are specifically monitoring certain things, certain aspects of the launch. So again, it takes a lot of people to do what we're doing today. And here's inside ULA's room as well.
And you can see it takes a large team of dedicated professionals to get people into space. And again, Butch and Sunny are sitting at the tip of the spear, but here's the rest of the team that's working hard to get the mission accomplished today.
Now, So if you're just joining us, again, we have Butch and Sunny sitting in the Starliner spacecraft. The pad team is outside as they work to begin closing the hatch. I do want to take a moment to acknowledge a phone call that Sunny made. So if you remember, Butch ingressed first, and then Sunny stayed in the White Room. While she was in the White Room, she made a phone call to Zach Brandon, and he's the lead technician on Starliner's crew module. He's been working on Starliner for 7 years. The team says he takes great pride in his work, which is evident to Butch and Sunny, and why they chose to call him
LC Slick
today.
on channel 1.
Brandon now watching the launch with
Go ahead,
family
Blake.
and other Starliner coworkers.
Yeah, no, I
reviewing
gave you.
location
Crew
activity.
insertion is complete, so the team did exit the vehicle, put the last couple bags in, and they're starting hatch closure preps, and we'll stand by for approval to close hatch.
Roger.
I bet Zach was surprised to get the phone call from Butch and Sunny. He's like, hey, what are you guys doing there?
Yeah, again, I think this crew has been so great about acknowledging everyone. I mean, Dee, this must be great, again, to see them take these opportunities to acknowledge some Starliner and Boeing employees.
Absolutely. You know, they have been working closely with this team, as well as Mike here, for many years. And so it's extremely thoughtful. I'm sure, you know, the team really appreciates it. But again, you know, they've worked together for a long time to get to this point. So being here is exciting for everyone.
On the first attempt, Sunny called Bill Barr from the White Room, and Barr is the responsible engineer for the ECLSS system, which stands for Environmental Control and Life Support System. And that system provides a habitable atmosphere in Starliner for Butch and Sunny throughout their flight. So that was really cool because Bill sits in mission control. So for that first launch attempt, we were actually able to see him receive the phone call. As you said, Zach, we were not able to get him on camera as he is at a launch viewing site here at Kennedy watching with family and friends, but I'm sure he was as thrilled and excited as Bill was on the first attempt.
Starliner Houston on 1.
Go on 1.
Just giving you an update, ULA is working an issue with a Centaur topping valve. No safety concerns we're monitoring, and we'll let you know where it goes, but that's the reason for the delay on hatch closure. We'll keep you abreast.
All right, thanks for the heads up.
And that was Capcom, right, Mike, calling out to the crew?
Yeah, that's Josh Kutrick, my crewmate, and launch and entry Capcom for Starliner. So he won't be able to do both of those tasks at the same time for Starliner 1. In the meantime, it's amazing as a crew member at the tip of the spear, as Butch likes to say. Sometimes we don't get the information that we can hear down here on the ground. So that was really nice of Josh to step in and give the crew an update and say, hey, you know, the hatch isn't closing because we're working on something. We still have time to sort this out, and so we'll just delay closing the hatch.
Yeah, two important things there for sure, that there is still a lot of time, a lot of pad built into the countdown to still have them close the hatch and launch on time. Again, 12:25 and 40 seconds p.m. Eastern Time, an instantaneous opportunity today. And two, no safety concerns as ULA works this issue.
And what line is that? Okay, got it. certifying a second spacecraft for regular flights to the International Space Station will greatly benefit the orbiting lab. For more on that, here's NASA's Antonia Jaramillo.
Thank you, Dee. We are here at OSB-2, one of the viewing locations for this launch here at Kennedy, and joining me is NASA Deputy Administrator Pam Melroy. Deputy Administrator, can you tell us why is it having multiple spacecraft available to send humans to space, helping advance, scientific research on board the International Space Station?
Yes, it's going to make a tremendous difference for us. The station has been operating for more than 20 years. We've done thousands of experiments, but really in some cases we're limited by the amount of time the crew can spend. By having 4 crew members instead of 3, we're literally going to be able to double the amount of time that our astronauts can spend doing science. Also, our crew vehicles can carry more science. We also have a diversity of locations that we're landing, meaning that we're bringing science back faster to the ground. And of course, one of the most important aspects of this is as we have more astronauts in space, we can do more human research. And that's really important.
Absolutely. Always having more is better for this. As a former astronaut yourself, you have firsthand experience on the effects of spaceflight on the human body. Can you tell us a little bit more about the human research experiments that Butch and Sunny will get to participate in for this mission?
Yeah, we will never waste an astronaut in space. I will say that. So when Butch and Sunny get up there, even though it's a shorter trip, they're going to join our astronauts that are up there right now, Tracy, Mike, Jeanette, Matt, and join in some of the human research. So the larger of a pool of data we have, the better it is. So they'll be participating in those experiments. But in addition to that, literally, this is a brand new trajectory. We're going to find out. The first question we're going to ask, how did it feel? Did it feel like the shuttle? Did it feel like the Soyuz? What's different? What's the same? And I think the other key aspect of this is we know eventually when we go to the moon and Mars, we're going to have astronauts get outside of the vehicle by themselves when they land. And so every piece of data that we can get on their experiences on these new vehicles is going to help us do that better.
Absolutely. I know we all definitely cannot wait to hear how this mission goes for them. And you briefly touched on this, Deputy Administrator. How do flight tests mission like this help contribute, to future crewed missions to the moon and eventually onto Mars?
We are going to be doing a lot of flight tests, and this is really core to what NASA does. If you're going to stay at the cutting edge of development, you're always going to be developing new technology and you have to test it. And so what that means is it's adding to our body of knowledge. So in this specific case, the Boeing Starliner vehicle has parachutes that have commonality with Orion. The docking system is similar to the one that will be used for exploration. So the more data we have on a system and the more experience with it, the safer we will be and the better operationally we'll be. But in addition to that, I think, again, so much of the human research aspect is really important to try to understand and go forward. And there's so much happening on the space station that is supporting both the science and technology, whether it's water reclamation and other technologies that we are going to need to go to the moon and Mars.
Absolutely. Well, Deputy Administrator, thank you so much for joining us. Megan, D, Mike, back over to you.
Thank you so much, Tony and Pam. Okay, so for the last 20 minutes, the ULA team has been tracking an issue with the rocket's upper stage. So let's head on over to the ASOC now, where we have Dylan Rice standing by to give us an update.
Hey, Megan. So yeah, you heard on the net that there was a stop flow reported, and essentially what happened was some instrumentation. We stopped getting some data from a couple pieces of instrumentation on the Centaur upper stage, and some automatic protections kicked in and stopped the propellant replenishment process to Centaur. So for the past few minutes, the engineering team has been talking through the process of switching to our redundant instrumentation data stream.
Been received as alarms as well.
Roger, thank you.
And as we do that, one of the things that that we do is communicate that full process with everybody, so that everybody understands what to expect when we take action like that. These contingencies are pre-planned, but when it comes to human spaceflight, we like to ensure that the broader team is really familiar with what to expect as we make changes to the
adjust the
data
ISA
streams.
temperature to 145 degrees Fahrenheit. Roger.
Because those data streams will change during the switch to the redundant circuits. So the team now is finalizing that plan, and they're going to get the approval for that. And then here shortly, we'll hear the team switch that instrumentation to the backup data stream, and we expect that to resolve the issue.
A path forward to allow us to continue to launch. Basically, what Dylan is saying is the fix is to move the
1 hour, 55 minutes.
the operation of needing to top off to move the that operation to another valve, right? A redundant valve that will do the exact same thing.
I think it's going to be really the actually the sensors, right? Because you don't want to fill something and not know how it's going. So I think what I think I heard was they're going to switch to a different telemetry system, so then they can reopen the valves and monitor how the top-offs are going. Yeah. But we'll find out in just a few minutes as they go forward. But that's really what is important in aerospace engineering, and for all you future aerospace engineers out there. That's really what is to know that if you really want your things to work, you build them as best you can, and it's really good to have redundant systems. And as a backup, I totally support that. But I mean, it's good to have other ways to do things, and that's why we are looking forward to NASA, as Pam Melroy said, is flight testing is what we do, and getting new spacecraft are really important. So we have redundant systems to go up to the International Space Station.
And even if you look at this in the larger view of the Commercial Crew Program, I mean, the reason why we want at least 2 dissimilar spacecraft to be able to ferry astronauts to and from the International Space Station is, again, because of redundancy. Because if something were wrong with one of the vehicles or one of the spacecraft, there is another one to go to.
And we ran into that trouble in 2003 with the loss of Columbia and our friends. Thank goodness our Russian partners stepped up, and we started flying people up and down regularly on the Soyuz, where up to that point all of our crew members were being really launched on the space shuttle. So having a redundancy, or sometimes as we say dissimilar redundancy, really helps to keep the mission going forward.
Again, we are now 1 hour, 52 minutes, and 55 seconds to liftoff of NASA's Boeing crew flight test. The ULA team working to transfer to a redundant system to allow the countdown to continue, to allow a topping of the Centaur, the rocket's upper stage, to continue. But for now, we're going to head back over to Johnson, where our commentators there are going to introduce you to one particular person who's mostly communicating with the crew. You heard us mentioning him a couple of times already, but that is Capcom, and Brandy and Jim can walk us through that.
Thanks, Megan. As you were saying, the Capcom role has been around as long as NASA has been sending people into space. It's shorthand for capsule communicator, but it's used even when there's not a capsule to communicate with. For instance, there's a Capcom today in the International Space Station room working with the space station crew. In this case, though, the name is entirely accurate since Starliner is a capsule.
Yeah, historically, Capcom was a role exclusively held by astronauts, with the thought being that an astronaut would know best what another astronaut in space needs to know in any given situation. But when the International Space Station began operating 24/7, 365 days a year, NASA no longer had enough astronauts to constantly fill the Capcom position. So now it's often held by training instructors, mission controllers who have worked closely with the astronauts previously and have a good understanding of the information that they need. But for extremely dynamic situations like launch and landing, you'll often see an astronaut back in that seat.
Yeah, and that's the case today. You've actually heard Canadian Space Agency astronaut Joshua Kutrick's voice a few times already today. He did some communication checkouts with the crew. You also heard him giving them an update on the hatch closure being delayed while the ground teams work through this.
Coordinate with you.
testing this out
issue
still
on the Centaur valves.
we speak, waiting
So
for
you'll
that
be hearing him
complete.
a
Once
little
we
bit.
have that thumbs up from Sil, what we're planning to do is to disable her safety. We need to run option 354 to disable the fluid monitor testing. Then we need to switch from VRIC 3 to VRIC 1. That'll be a SYS function. Once that's complete, we can go ahead and reestablish fluid monitor and a her safing capability, and that should put us into a position to proceed.
Roger. And do we have an estimate when the still test be complete?
I was told 5 minutes ago, about 5 minutes, so it should be imminent.
Roger. And LC concurs with this. LD?
LD concurs.
Roger. And AC, could we get an update on the still test?
I'll get that right now.
And SYS LC?
Go.
Roger. Do you have the steps as were outlined for executing this
That's affirmative.
switch? Okay. Okay, let's see. Flight channel
Sounding-
one. Flight here. Yeah, Roger. Understand we kind of want to give the broader team a little insight to what we're planning to do here. So if we want to merge the nets, we could do that at this time.
In work.
NLC, the pad team is on channel 1. We'll be listening in.
Roger. Roger. Thank you.
LC flight and Starliner flight, we merged channel 1 and air to ground 1. So LC, give the crew and the pad team an update.
Roger. And Starliner, can you copy me?
Catch it loud and clear, LC.
Roger. So at this time, what we have is a control issue going to the LOX and hydrogen topping valve. So they are both closed this time, so we're not topping Centaur at this time. So we put in a troubleshooting plan together, and we're going to switch the control logic from VRIC 3 to VRIC 1 because we have redundancy in our control system. And so we're going to switch to VRIC 1 and hopefully restore this topping control and get the vehicle back into topping mode.
Great. Copy all. Standing by.
Roger.
Pad copies as well.
Blue team lead copies.
Roger. And flight, let's go ahead and leave this, if you can, leave this merge till we're done. Should take about 5 minutes to complete this operation.
LC copy, leave your merge.
Roger.
Heard some more communication about the topping issue on Centaur. So let's head back over to ULA's Dylan Rice to walk us through any other updates from the team.
Hey, Megan. Yeah, so we did get quite a bit of an update there just a few moments ago as Chief Launch Conductor Doug Lebo briefed the crew and Starliner, and I can add to that a little bit. But basically, what has happened is the communication to the Centaur topping valves, which are on the mobile launch platform. These are the valves that control the replenishment of oxygen and hydrogen on the Centaur upper stage as it warms up and evaporates. We stopped getting some data from those valves, and the team has talked through the troubleshooting steps to switch to our redundant control circuitry on those valves. So we'll be using the same valves on the mobile launch platform, but using our redundant control circuitry. But as I said a few moments ago, anytime we're going to be interrupting data or changing a configuration, we brief the entire team to include the flight crew. And you also may have heard in the background there that we're the word SIL test, and so we actually are simulating that activity in a lab prior to performing it on the pad, just to double verify the procedures for switching to those redundant control circuits. So that will be taking just a couple of minutes to wrap up that test, and once that procedure's been verified, then the team will implement that corrective action to switch to the backup control circuitry on those Centaur topping valves on the mobile launch platform. So for now, the rocket remains stable. Again, the only impact here is that we're not currently replenishing propellant on Centaur, but with our schedule today, we do have quite a bit of time to get this issue resolved and resume topping on Centaur, which would only take a couple of minutes to get us topped back up to our flight levels where we'd expect. So we will continue to listen and stand by as the team wraps up that exercise and just
flight
verifying.
And Starliner, LC on channel 1. Flight here.
Starliner, go ahead.
Yeah, Roger. So right now we are exercising the steps to do the transfer from VREC 3 to VREC 1. We're executing that in our SIL test in the SIL lab just to make sure that we have the proper procedure steps before we execute it here on the pad. So team's asked for a few more minutes to complete that test.
Starliner, copy. Standing by.
Flight copy.
And so, Megan, as you just heard there, that was again the chief launch conductor, informing the broader team there that the team in the lab has just taken some additional time to exercise those procedure steps before we implement those and switch to that redundant control circuitry. So that's the update from the ASOC, Megan. I'll give it back to you, and then we'll get back together here in a few minutes when we have another update and the situation's been resolved.
Yeah, Dylan, thank you so much. That was really helpful, Mike, the way that Dylan really broke that down for us.
Oh boy, yeah, I'm so glad I'm here today. We're learning more about our NASA for crew. Haven't flown before on an Atlas, and we're learning and gaining great confidence in our team. They're doing all the right things to make sure that you can always make something worse, so they're double checking their work before they actually do it. They let everybody know what they're doing. They got concurrence, so we're on a really good track, and in a few minutes we'll get reports to see if switching to a different telemetry control system does the trick. We are highly optimistic, but we won't know until we hear the results. But then that means that the Centaur will get retopped, and the crew will have gas, so to speak, so they can fly into orbit. So this is really a great example of launch operations and aerospace engineering at work real time.
Yeah. For those who might have joined in the middle of all of that explanation from Dylan, again, the ULA team stopped getting data, right, from a ground valve that controls the topping of liquid oxygen and hydrogen into Atlas V's upper stage, the Centaur. So the fix, right, is they'll still use the same valve, but they're basically switching over to a redundant control system, which will allow them to, again, regain data from that valve as it tops off.
Exactly, both because right now the filling system doesn't know if they're going to overfill or underfill. It doesn't have any insight for a closed loop feedback system. So without the insight to the sensors, it said, all right, I'm going to close both the hydrogen and oxygen valve until I know what's going on, and they're going to put a new sensor system, and then they should be able to refill.
Great. All right, and again, we are still good in terms of the countdown, hatch closure.
On 1.
Go ahead, SYS.
Step 200, L2 balloon cycle task is complete.
Roger.
Hatch closure was scheduled for 1 hour and 10 minutes before launch. So again, we still have about 30 minutes to close this hatch and get everything ready for launch. But for now, let's head on over to Daryl Nail. He is in Hangar AE with some NASA leadership of the Commercial Crew Program, and basically they're monitoring everything that's happening. Right, Daryl?
Yeah, that's right, Megan. NASA Operation Manager Richard Jones is listening in and talking to his team about the operation that's currently underway. You heard Dylan describe it, going to that redundant control system in order to get data from the LH2 valve, topping valve, and the LOX topping valve in the Centaur upper stage. And as you also heard over the nets, they are currently still running that test in a lab where they execute that basically that operation to move to that redundant system before they do it in real life. And so we're currently waiting for the completion of that test before they go ahead and do it. One indicator, talk this over with Dylan, that kind of gives you an idea that it's not the valve and it is the instrumentation kind of led them in this direction, is that when you get stop getting data control from both LH2 hydrogen and the tank liquid oxygen at the same time, that points towards an instrumentation issue
1 hour, 40 minutes.
rather than a valve issue. So all of that was a right, and just to so that we're all clear, this is on the ground side feeding the propellants into the rocket, but the valve is on the ground side. Again, propellant flowing into the vehicle, and so that's an important note there. But again, it looks like all indications are that we're making that switch to that redundant system, and then we should know here momentarily, and they're going to communicate this to the crew, so we'd expect to hear this over the nets when they tell them that they've made the switch, and then what kind of data are they getting once they've made that switch to the redundant system. This all kicked off around 10:20 a.m. Eastern Time when the Capcom reported out that, or rather the launch conductor took a report that the Centaur topping valve had gone into a stop flow. So stop flow was initiated as a safety parameter for both the liquid hydrogen tank on the upper stage and the liquid oxygen tank. So they are no longer in replenish. And remember, they're in replenish for the entire time up until just before liftoff, when they cut those, when they turn it off and pressurize the tanks to flight level in order to fly. So as we're speaking, the levels are coming down ever so slightly in those tanks due to the natural boil off, a little more in the hydrogen tank because it's substantially much more colder than the liquid oxygen. But they'll get those replenish valves open back up and feeding that propellant back into the launch vehicle if, as expected, they get the redundant system to tell them where those levels are inside the tank. That's key. That's why they went into stop flow, is in order, because if they don't have visibility on the tank fill rate, then they need to make sure that they do the safe thing and stop flow into that. So again, you can hear the clear communication between the launch team of ULA communicating to the crew, Butch and Sonny, inside the Starliner capsule, keeping them up to date on everything that's happening, even testing in the lab. And so the crew is standing by to get an update. You heard the launch director tie in air to ground to the main net along with the pad so that everybody can hear what's happening and everybody is on the same page. It's a critical part of, as Dylan mentioned, this is a team sport and you want everybody communicating and on the same page. All right, that's the latest here from Hangar AE. We'll send it back to the desk.
Thank you, Daryl. You know, not only is Starliner flying Butch and Sonny today, it is also bringing up nearly 800 pounds of cargo to the space station. Let's check in again with Boeing's Lauren Brennicky and ULA's Dylan Rice.
Thank you, Dee. Yes, you're right. They are taking a lot of cargo up and actually even more than we originally thought back on May 6th, along with Starliner's most precious payload, of course, Butch and Sunny. We are also carrying about 760 pounds of cargo up today. More than half of it is Boeing cargo, like CFT patches, mission coins, silver Snoopy pens, American flags, and a hard drive with about 3,500 pieces of artwork from children across the world. Also, tools, emergency life support equipment, and a late ad at NASA's request. Just yesterday, our teams packed a new pump for the space station's urine processing assembly, which is part of the water recovery system on the ISS. The 150-pound pump replaced 2 non-essential cargo bags. Now, it's all methodically packed weeks in advance, 25 bags for Boeing and now 10 bags for NASA, which are carrying things like food, clothes, exercise gear, medical supplies, and things the crew wanted to bring with them as well. On the way back, Starliner will bring about 750 pounds of cargo, so a little bit less on the way back, and that includes 1 empty NORS tank, which is a nitrogen-oxygen recharge system, and that will be refilled for future missions. Now, Dylan, we have been focusing on what's going on with the rocket. There's also just been a lot of other nominal procedures going on in the background.
Yeah, Lauren, that's correct. And so one of the big differences between a countdown for a regular, what I'll call a regular satellite, a payload that doesn't talk back,
yes,
is the length of our built-in hold. So typically, for a robotic mission or a communication satellite, we would use a built-in hold of 15 minutes or 30 minutes, depending on the length of the launch window that we have. So the launch window for today is, the built-in hold for today is 4 hours, and that really accommodates that crew loading. So that's the big difference between a countdown for an uncrewed mission versus a crewed mission. During that hold, normally we're into our propellant replenishment, which is the anomaly that we're about to hear an update on.
Steps to switch the card on the VREC.
Roger. LD, go on.
LD on 1.
Proceed, AC.
Okay, we did run through this through the SIL. Slight modification from what I described earlier. First, SOS option 547 to disable her safety. Option 548 to switch VREC 3 to 1 for both the analog and PCM. Then there is a couple command lines that the SYS has that will be utilized during the switch. Finally, re-enabling the her safing using option 547. I'd like to implement that this time.
Roger. And understand and concur. LD?
LD concur.
Roger. SYS LC?
Yeah.
Roger. Are you ready to implement at this time?
Affirmative.
Roger. Proceed.
In work. We'll report when complete.
Roger. And Fuel 2 and LOX 1 LC?
LOX 1. Fuel 2.
Roger. So during this transfer, you may pick up Flumon number 29 and 31 due to a miscompare, but there's no issue with that, and we'll just clear that after the switch is complete.
Copy. Roger.
Okay, with that update, then the launch conductor and the launch director have approved the plan to switch the redundant data stream that will allow us to resume our Centaur propellant replenishment. So with that, we'll let the team get back to that, and Megan, I'll send it back to you at the host desk.
Thank you so much, guys. All right, so of course this is a historic day for all teams involved, particularly for employees of United Launch Alliance. So why don't we head over to Antonio Jaramillo, who's joined now by ULA's CEO, who has more on the significance of this flight test, but also can talk us through a little bit of the troubleshooting that they're doing today.
Thank you, Megan. Joining me is Tori Bruno, CEO and President of United Launch Alliance. Tori, this is a really historic day for ULA, but before we dive into that, we've been hearing a lot of discussion on the replenishment valve. Can you tell us a little bit more about what's going on?
Yeah, absolutely. These are ground valves that are
topping off the propellants in the Centaur, so both the LOX and the liquid hydrogen. It's part of a triple redundant system, and so the fuel levels are being maintained, the crew is in no danger whatsoever, and we will still have enough propellant to go. But we like to have redundancy, and so they have a common controller, and what we've just done is come up with a plan to recycle that controller and see if we can get that third redundant valve pair working. It's come through the SIL, it all looks good, there's no unintended consequences with that. Procedures are written up and they're just being reviewed right now with the team out here at the Cape, and so once we're satisfied, those ground valves will be cycled and we'll see where we are.
Sounds good, and we'll definitely keeping our eyes and ears tuned for that. You know, as we were mentioning, this is a really historic day for ULA, getting to launch humans to space, and also the 100th launch of an Atlas V rocket. Why is this such an important milestone for the company?
Oh, it's so exciting to be back and be part of the human spaceflight community. And as you said, it's a really cool event for Atlas because Atlas's great-granddaddy was on Mercury Atlas. John Glenn, first American in space, and then, of course, ended that, you know, with Gus Grissom there with Mercury Atlas 9. So we're super excited about that. This is a very special configuration of Atlas and flight configuration. And of course, you know, we fly a lot of really critical payloads, but there's just nothing quite as precious as this crew. And it's just very, very different for us to be able to shake hands with our payload, if you will.
Absolutely. Tori, thank you so much for joining us here today. We're very much looking forward to this launch. Megan D. Mike, back over to you.
Yeah, that was really great to be able to hear from Tori Bruno again from ULA. He again recapped for us that the team is currently working.
Go ahead.
Complete.
Roger. So LOX 1 and Fuel 2, go ahead and reestablish topping at this time.
Roger.
And LOX 2, LC.
Go ahead.
Roger. You can reestablish topping also.
Roger.
And with that confirmation that the ULA team is able to...
Go ahead.
I just received an OTC for the second stage gaseous helium bottle mass, line item 260. Data went out of tolerance mode.
Okay, copy.
The ULA team is able to
Go ahead.
continue topping off.
Centaur helium bottles are venting.
Can you hit a stop flow on that? Or do you understand why they're venting?
Looks like I've got a valve failed to verify.
And IFS LC channel 1.
Present 1.
Right, is there an action we can take to stop venting?
Kurt with a stop flow.
Roger, Peony 2, did you copy stop flow?
I copy inward.
Yeah, well, it sounds like the United Launch Alliance engineers.
LC, that's complete, and it did stop the vent.
Roger.
They re-enabled the
ACLC channel 1.
AC1.
Roger. During the transfer repairs that we did pick up Centaur helium bottle venting command, which looks like, I don't know, we vented about 1,000 PSI. If you would please convene the anomaly team and provide a recommendation.
We'll go.
And as they re-enabled comm with the valves, it looks like they had some startup transients, and they're looking into what happened, including the helium pressurization tanks. So they definitely are looking at it with the anomaly team, and they should have some recommendations soon.
So basically, they had transferred to that redundant data tracker. And when they did that, they felt confident to start topping off liquid oxygen and hydrogen in the Centaur again. But in doing that, they got another
Go ahead, LOX 2.
At this time, I'm about
indicator.
to resume topping, but I will need to perform the transflight shuffle.
Roger, proceed.
And answer that call. They said that they can continue topping the liquid oxygen, and we'll see how the rest of it goes. But yeah, when you start something new, you get these new transients. You get some messages and alarms, and you have to look at each one to make sure that that you're in a good configuration.
And SYS, LC. Roger, just as a result of the switch there to VRIC 1, you're seeing all normal operation at this time?
That's affirmative.
Roger. And LOX 1, advise when you're reestablished topping.
Roger, we're still in Rachel right now. It should be any minute now.
Roger.
So it looks like...
I'll see we're reestablished topping.
Roger.
It looks like we are reestablished.
Go ahead.
Yes, as understood, we got the booster LOX 10% full alarm this time. Out of tolerance.
Roger. And we've reestablished topping, so we should get that restored here shortly.
Understand, just wanted to make you aware.
Thank you.
So the good news is that we're retopping on the liquid oxygen side. Some of the messages associated with the liquid oxygen are expected for the configuration we were in, but we definitely had to check them. And it's still a little bit open, and at least to me, Megan, and Dee, is that we'll see what's going on with the liquid hydrogen side. They're still working this.
Yeah, just to give people a little more insight, again, we have these loops, and our commentators, as you've heard throughout the show, they're listening to those back channel conversations that us here at the hostess, as well as you guys, the viewers, we are not hearing all of those conversations. So it's really nice when we do get to hear updates from our commentators, because they can really fill us in on what we're hearing, because what we're hearing is in real time, and we're trying to translate it as best as possible for you. So again, about an hour ago is when this issue was initially flagged again, that maybe they weren't receiving the right telemetry, or that the data they had stopped receiving data from a particular ground valve that is responsible for topping off liquid oxygen and hydrogen into the Atlas V's second stage, the upper stage. They have been able to reestablish topping on the LOX side of things, the liquid oxygen side of things, but we're still troubleshooting the helium side of the system, yeah?
The helium that's pressurizing the hydrogen. Lots of elements on the periodic table today.
And so, like I said, we have teams listening in to the chatter, the communications between the different folks who are monitoring this issue. So we should have an update there soon.
PNE2, LC.
Go ahead.
Start center and chill down.
Roger. LC Slick on channel 1.
Go ahead.
Looking for approval to go ahead and move the hatch frame and continue with hatch closure preps.
Roger, proceed.
Copy.
So that call out you heard there is from the pad team, who are still in the white room just outside of where Butch and Sunny are sitting inside Starliner. You can see a live view of them there. They just...
Calcium 1AC.
Go ahead.
I'm ready for provide a recommendation for the Centaur bottle repress.
Roger. LD, channel 1.
LD on 1.
Proceed, AC.
Okay, so we need to have the PNE2 use option 350 to reset the stop flow, and then option 320 to deselect resume. That will get us back in a configuration and recharge the bottle.
Roger. Understand and concur. LD?
LD concurs.
And PNE2, LC?
Go ahead.
Roger, you ready to execute that at this time?
Can you please repeat the steps? I was initiating CEC.
Roger. That's option 350 to reset the stop flow, and then 320 to deselect and resume.
Copy. I'm prepared.
Roger, proceed.
Roger.
So it sounds like that the ULA is still pressing forward, and that allows the pad team to begin hatch closing.
Go ahead.
Without actually closing the hatch,
have you
they're
been
just
able
getting
to
ready.
Restart topping at this time?
Affirmative. In topping.
Roger. And everything's nominal?
Affirmative.
At some point, could you give me an estimate when you think you'd be back at flight level?
Affirmative. I will get back to you.
Thank you.
All right, that was a good call
And
out
Lock
there.
2 LC.
Go ahead.
Roger, have you initiated topping yet?
That's firm reach was successful, currently at 98.9.
Roger.
Well, it sounds like our elements are taken care of with
Yeah.
So flight,
oxygen.
and Slick, and Starliner,
and
Channel
helium.
1.
Here we go.
Flight here.
Starliner, go ahead.
Roger. So at this time, we've completed the transfer from VREC 3 to VREC 1, and all our systems are back active topping and returning Centaur helium to flight pressure. So at this time, I think we're on track to continue with the countdown, and in flight, I think we can demerge these nets for the time being.
Good news, LC. Nice work.
Roger. Thanks, Starliner.
Good news, flight copies will deconfigure.
All right, a lot of good call-outs there, a lot of good updates. So why don't we toss it
Go
back
ahead.
over to ULA's
Should be
Dylan Rice.
approximately 20 minutes.
Roger.
And Megan, yeah, we've had a busy couple of minutes here, but as you did hear, we have recovered from
And LC
the stop.
Slick on Channel 1.
Go ahead.
Wondering if you had an estimated for hatch closure weather brief.
Yeah, getting ready to issue that right now.
Roger.
RC, LC,
RC on 1.
conduct weather briefing on Channel 8 Weather Conference Net.
Roger.
LC Lock 2.
Go ahead.
Centaur LO2 at flight level.
Roger.
LC Peony 2.
Go ahead.
Bottles have returned to flight mass and flight pressure.
Roger.
Okay, so yeah, a lot of traffic on the net here, but just to kind of recap, we had been tracking the issue with the instrumentation associated with the Centaur topping valves. That issue's been resolved. Centaur is now back in replenish on both tanks. In fact, we just heard that the
And
Centaur
arm control, LC. Arm control. Power on crew access arm hydraulic heater as required.
Roger.
So Centaur liquid oxygen is back at flight level, and also we did have to we did vent a little bit of helium there as we recovered the systems, and the Centaur helium bottles have now been recharged as well. So it's a good sign that we did hear the team talk about continuing with the hatch closure preps, and they're moving forward to the next weather briefing, which will get us closer to launch. It sounds like that. Although we had a really exciting past hour, hopefully we have all that behind us now. And we get back to nominal operations as we continue to march toward our planned T0 of 12:25 and 40 seconds Eastern Time.
To launch. So with that, as you heard, the pad team is in the white room. They are continuing preps to actually close the hatch. There will be a weather briefing first to decide whether or not they should move forward with the hatch close. While we wait for that, let's check back in with NASA's Brandy Dean and Jim May and Mission Control.
I just want to give you step 220, Centaur engine shutdown initiated.
Flight control team here in Houston has been following along with all the issues that are going on in Florida, but things are going fairly smoothly on the Starliner side so far.
So once
We're about an hour and 16 minutes away from today's liftoff, and once we do lift off, the crew will have a 25-and-a-half-hour ride to get to the International Space Station. And with this being the crewed flight, they'll have a number of test or flight test objectives to work through, putting the Starliner systems through its paces to prove them out before operational flight begins. First of those will come after Butch Wilmore and Sunny Williams reach orbit today, when they'll be doing some manual piloting checkouts while they're still well away from the space station. They'll be flying some attitude maneuvers, changing Starliner's orientation, using only visual cues to start with, and then using Starliner's attitude direction indicator, which we use for all of those other planned attitude maneuvers. And they're also going to point the spacecraft's tail to the sun to demonstrate that it can use solar arrays to recharge its batteries.
And once they arrive near station, they'll take over with manual control again to demonstrate their ability to station keep for about 5 minutes at the opening of the approach corridor. And this corridor reaches out to about 260 meters away from the forward docking port on the ISS Harmony node, or as you may hear later on the broadcast, Node 2 forward. This maneuver should be pretty familiar to both Butch and Sunny because it's very similar to flight ops they performed while in the Navy, like lining up an aircraft with a refueling tanker,
and Slick LC Channel
or
1.
landing approach with a carrier. Like lining up an aircraft with a refueling tanker, landing on a carrier,
Slick on channel
or also hovering.
Roger, Slick. You have a go to proceed with hatch closure.
Roger.
Just heard the teams across the country there pulling to go ahead with the hatch closure. So that's good news moving forward with the countdown. And sorry, Jim, go ahead with what you were saying.
No worries. Talking about the manual piloting demo the crew's going to do while hovering out in front of ISS.
Starliner, be advised we've been given a go to proceed with final hatch closure.
Outstanding. Nice job, guys. We'll see you in a couple of weeks.
Much appreciated. See you when you
Or longer.
And with Butch planning on staying up there longer, maybe he'll do a couple extra manual piloting demos for us while he's around there. But when they fly with these manual flight controls, it'll be 6 degree of freedom control using both joysticks. One called the rotational hand controller for changing direction. The other called the translational hand controller, similar to a throttle in an aircraft, but instead of one direction, you can go up, down, left, right, forward, and back.
That's right, but we've got to get into orbit before we get to any of that. So we've got another hour and 13 minutes until today's 10:34 p.m. Eastern launch today. Flight Director Mike Lammers has been keeping a close eye on all these activities as crew got into their seats and went through the suit leak checks. We'll have a few more things to watch as we go through the hatch closures, including the capsule leak checks. And in about an hour, Lammers will be polling for a go or no-go here in Houston, hoping to get a thumbs up across the board for today's launch. He'll be speaking for this team when he gives his final go or no-go to the launch conductor about 7 minutes before launch.
And the International Space Station also has to be go to welcome Starliner tomorrow. So let's go back to Space Station Flight Control Room and NASA's Rob Navius for an update. Rob?
Yeah, thanks, Jim. Flight Director Pooja Jasrani on console at this hour with the Orbit 2 team of flight controllers. They'll be polling their team to get the green light to proceed with the countdown and the launch that hopefully will culminate with a docking by Starliner to the Harmony module of the International Space Station at 1:50 p.m. Eastern Time on Sunday. During the week or so that Wilmore and Williams are aboard the International Space Station, each dock day will see a different variety of activity for the Starliner duo. On Monday, for example, Wilmore and Williams will continue unloading cargo they brought to the station and will transfer some used emergency equipment from station to Starliner for the trip back to Earth. They'll stow their launch and entry suits aboard the vehicle and conduct a debrief with NASA and Boeing officials about the rendezvous and docking phase of the mission. Once Starliner's batteries are charged through station power resources, Starliner will be configured for quiescent operations. So with hatch closure in the offing and the countdown proceeding for a liftoff 1 hour, 11 minutes, and 40 seconds from now, we'll toss it back from the Space Station Flight Control Room to you folks down at the Cape.
If you're just joining us, welcome to the official broadcast of NASA's Boeing Crew Flight Test, or CFT. What you are seeing now is a live look from one of our helicopters here along the Space Coast, orbiting the Starliner spacecraft atop a ULA Atlas V rocket. Inside that Starliner spacecraft, 2 NASA astronauts, Commander Butch Wilmore and Sonny Williams, pilot.
Maybe I just didn't get it formally from you, but you're back at flight level.
Affirmative.
Roger.
At launch, Butch and Sonny will make history as the first people to fly aboard Boeing's Starliner capsule. And liftoff is targeted for about an hour and 10 minutes from now at 12:25 and 40 seconds p.m. Eastern Time. And we are happily proceeding, marching towards that T0 after a busy hour. Mike, can you kind of recap for people the last hour of the launch countdown?
Well, in the last hour, we got to see some really great engineering and launch operations and teamwork happen. So the second stage of the Atlas launch vehicle, called Centaur, it is powered, its fuels are liquid oxygen and liquid hydrogen, and it's already has all the fuel in it, but since they're liquid, they're very cold and they kind of boil off, so we just add a little bit more on top, so we top it off.
1 hour, 10 minutes.
The 2 valves that were used for topping off lost insight for their control algorithms, so they couldn't see the sensors, and it was an upstream bus, so they changed the control algorithm and logic, and got back in business. So we were back on the launch timeline. The crew was informed. Everybody was talked to about it. Never in danger. Just a way to just having to relook at a different control system and sensors. So in the meantime, the pad team was held off from closing the hatch just in case they needed to get the crew out today.
RC, LC, Channel 1.
And they're
RC,
closing the hatch now.
Verify range ready for FTS open loop test.
Verified.
FTS, LC.
This is FTS.
Start final open loop FTS test.
Roger.
And FTS stands for Flight Termination System, in case the rocket were to go off course. Of course, by that time, the Starliner, if the FTS were needed, the Starliner would fly out of the way. And but that's just a normal test right now. And you can see they're closing the hatch. We're getting ready to launch in 1 hour and 8 minutes. Very exciting.
Yes, very exciting.
You know, teams are periodically briefed on the weather for today's launch. Let's check back in with Daryl Nail over at Hangar AE with the latest. Daryl?
Thank you very much, Dee. And here at Hangar AE with the team, monitoring both the launch operation as well as the weather. We got a great weather report from our launch weather officer just a few minutes ago. Winds were the one watch item, and they were driven, as you look at the satellite map, by a high-pressure system off the coast of North Carolina that you can see there, that clearing area. You see how it's turning in a clockwise direction. That's what's bringing all of our onshore flow. That is what's driving these winds. You see the clouds going by overhead. So this image from College of DuPage, they've got our GOES 16 data streaming through, and it's a great representation. You can also see the ascent corridor as a result of that high pressure system is also fairly clear all the way up the eastern seaboard. That's the track that Starliner will take. That's good as well. Only some moderate concerns for high sea states because of those winds. But overall, we are looking good in the corridor. We are 90%
LC
go.
Slick on Channel 1.
Go ahead.
Hatch closure is complete, and we're moving into hatch gross leak checks.
Roger.
All right, hatch closure is complete, a great milestone that we've reached in this operation to get to liftoff. And just to wrap up, 90% go here at the pad. We're good to go along the ascent corridor, and so for weather, we're looking fantastic for a June 1st day, and which is the first meteorological day of summer. Usually we have rain and thunderstorms this time of day. Unfortunately, we don't. There you see the graphic, 90% go.
On one.
And everything look weather-wise.
Starliner Houston back with you, ready for pre-launch cabin leak check. You can prepare for cabin pressurization per your checklist. Configure the HIU VOC sensitivity knobs to maximum.
Teamwork.
And as we look at the Starliner capsule from inside the white room, the blue team getting ready to make their exit, doing their final preparations before they leave. You can see them going through their list of procedures right there on the desk there. Also, that's a great call out. We want to hear that the capsule can be pressurized, and so they're doing that now. At this moment, I want to welcome into Hangar AE Deputy Program Manager Dana Hutcherson, who is here now with me. Thanks for taking the time to come over and talk to us. You're on console. You've been listening to the teams, both ULA and Boeing, as they prepare this rocket and spacecraft to go. It's been a little exciting over the last hour or so. Talk a little bit about that, what you observed from ULA team and your team in getting through the ground valve issue where they were able to do a redundant system.
Is removed.
And they were able to get that stabilized, get back into flow.
Yeah, it's been an exciting last hour or so, I guess, on the count. It's really cool to see the teams reacting to any anomaly that's been popping up, and they've been able to work through it. They've ran tests offline to validate the procedures and been able to jump right back into it to be able to get us back into the flow and the process. So it's really neat to see how everyone is ready for this launch and on point and just getting everything together for this launch today.
I was particularly impressed in listening to the ULA team and how quickly they worked through the problem and how fast they were able to bring the flow back in after resolving that redundant data issue that they had. That was impressive. Let's go over to the Boeing team. Earlier in the count, they pressurized the thruster manifold that had the issue with the helium leak. How did that go?
They everything went nominal. We expected to see some leak, and it was about the same. All the other checks came out nominal as well. So I believe that we are all systems go in that front. Haven't seen any other issues that have alerted us or alarmed us as well. So we're happy that we've discussed that at length, and we've planned out our procedures and our process of how we would react to that. But so far, everything is looking good with the helium system as well.
You mentioned discussed at length. This team, your team, along with ULA and Boeing, have worked extremely hard in the weeks leading up to this. I've sat in on a few of the meetings. It is amazing to me the amount of detail, the amount of work that has been done in order to verify and make sure this is safe to fly. Talk a little bit about how hard the team was working.
Oh, the team is just all the teams. You remember we started off with working with the ULA, with the valve replacement. So that started our process from the time we scrubbed in early May. So from there, we've moved into the working with the spacecraft and the helium anomaly. The teams have been working night and day to resolve that, to make sure that we've stepped through every procedure, every process, and making sure that we're okay. It's been phenomenal to watch the team and to see the camaraderie across all the boards and listening to all the experts and making sure that we are good to go. We've had to pull in a lot of extra boards and actually had another flight readiness review as well to make sure that the whole agency at NASA and then Boeing and ULA, everyone is ready to go. Very awesome to see this teamwork and the seamless teamwork across the board.
That Delta FRR just a couple days ago that was held, and we had a press conference yesterday, and the team reported out that everything is moving forward. You're talking about how hard the team worked. They deserved a little time off, so you guys took Memorial Day weekend to kind of recharge a little bit.
Yes, we did. We allowed some the folks to go and take a little bit of a break, have a barbecue if they needed to, and get a little bit of a recharge, as you said, to be able to get. to get back into and have a clear mind and be able to get back into the procedures for this week.
Further proof that you are indeed a human being. You know, these are human people that are working on all this. I just got to flash this really quick. This is Dana Hutcherson on a local community magazine in our city. And here she is with her husband, Jeremy, and her 2 dogs, her 2 labs. I sat down to my dining room table. My wife had this sitting on, and I said, "Well, look at this. This is the woman I'm interviewing today for the launch broadcast." Learned some interesting things about you, Dana. You like to, obviously travel and do fun water sports all around Florida. And it also says here that you're an introvert.
Yes, I am very much so an introvert, but you wouldn't know it, I guess, some days. Yeah. But yes, that was really a surprise to get to see that and have that opportunity. Being featured on Cocoa Beach Living.
Cocoa Beach's own Dana Hutcherson, Deputy Program Manager for CCP. Thank you so much for being here. We appreciate it. And continued good luck on the team working towards launch.
Appreciate it.
Yep. All right, we'll send it back to you.
We have teams monitoring today's launch operations here in Florida as well as in Houston. In the room right next to Leroy, you have ULA's Dylan Rice and Boeing's Lauren Brennicky, who have been monitoring operations with the rocket and the spacecraft for the last 3 hours.
Yeah, Dia, we've actually been monitoring them close the hatch and start the pressurization process. As you've seen there on your screen, I want to give you a little bit of perspective on how this works, and it's kind of interesting what the astronauts will experience sitting in there. It's a lot like when you feel a pressure change when you're in an aircraft. So their ears will pop, and the whole process, doesn't take very long. It just takes a couple of minutes. But our team is checking about half a dozen valves and more than 60 seals. So things like windows and hatches and vestibules. And they will let the spacecraft sit for about 10 minutes while they check. You could think of this as like inflating a balloon. When you start to inflate a balloon, you'd be able to tell pretty quickly if there was any kind of a leak where the air would be coming back out of it. So very similar process here, and that's what the team is going through. If you are just joining us, we are just under 1 hour till launch time. A couple of hours ago, our teams, the Boeing teams, were able to confirm that the leak rate remains acceptable. If you've been following along with us this week, you may have heard about the helium leak that we had, but we know now the leak rate remains acceptable. And in fact, our teams even said that it looks better than before. So all good news. And Dylan, Atlas really has been all over the solar system. Today's a little different because we have crew on board.
Well, that's right, Lauren. And so, we really are thrilled to have Butch and Sunny on board, and thrilled to be a part of this program as we put Atlas back in service for human spaceflight. This on the one hand, we have some really thoroughly established processes and procedures that we've used for missions to the Sun, the Moon, Mars, and we're using those today. But this countdown really is unlike anything we've done before, and so we're just absolutely thrilled to be a part of it. We remain in our final built-in hold now as we continue to prepare for liftoff, but there are still a few things ahead of us today. As you talked about, the blue team is on the pad while that leak check is going on. They're continuing their preps to clear out. Once we do get the area clear, we'll be preparing the vehicle's propulsion and hydraulic systems for launch. We'll also be getting some data and loading that into the flight computer that will help Atlas and Centaur steer through the upper level winds as we pierce the atmosphere. You'll also be hearing some comm checks between the Chief Launch Conductor Doug Lebo and the Starliner crew and Houston as well. As we get all those things will take us closer and closer to our launch opportunity today, coming up at 12:25 and 40 seconds. And of course, the one big visual cue that you will get that we're moving right along will be a retraction of that big crew access arm. So that's going to be coming up here in just a little over 40 minutes, a little under 40 minutes, I should say. But the big crew access arm will retract, and at that point we'll be very close to launch.
And it's really important that the crew cleans everything up.
On Channel 1.
Go FTS. Operation 55, Step 270, FTS open loop test is complete.
Roger.
All right.
All right, we just heard that leak check is complete. Again, we are just under 1 hour. We're about 56, 57 minutes right now away from launch. The cabin leak check is complete, and we are moving forward nominally. Feeling like a great day to go to space, Dylan.
I agree. Let's do it.
Megan, we will check back in with you in just a little bit. Back over to you guys.
Well said, Dylan. Let's do it. And actually, why don't we take the time now to take another look at the crew making history with this test flight. You see Commander Butch Wilmore closest to the screen here, corner right. Now, Commander Butch Wilmore, NASA astronaut and retired U.S. Navy captain, was raised in Mount Juliet, Tennessee, is married to Deanna Wilmore, and they have 2 daughters. As a naval pilot, Butch racked up more than 8,000 flight hours and 663 carrier landings, all in tactical jet aircraft. He completed 4 operational deployments supporting missions like Operation Desert Storm. Before his selection to NASA, Wilmore was on exchange to the Air Force as a flight test instructor at the Air Force Test Pilot School at Edwards Air Force Base in California. Butch is a veteran of 2 space flights as a pilot on Space Shuttle Atlantis in 2009, and then in 2014 he served as flight engineer for Expedition 41. And so far, Wilmore has spent 178 days in space and performed 4 spacewalks. This flight test will be his 3rd mission to the ISS.
And Suni Williams, CFT's pilot and a retired U.S. Navy captain. NASA selected her as an astronaut in 1998, just 2 years before Butch. This will be Suni's 3rd mission to space, making her the first woman on a test flight of an orbital spacecraft. Her first trip to the ISS launched in 2006. She served as flight engineer for Expeditions 14-15. She then returned to the orbiting lab in 2012 and was commander of Expedition 33. Suni has more than 50 hours of spacewalk time, the 2nd most cumulative time by a female astronaut. So far, she has spent 322 days in space. Before NASA, Suni was a former naval test pilot and instructor, logging more than 3,000 flight hours in more than 30 different aircraft. Williams grew up in Needham, Massachusetts, and is married to Michael Williams.
Starliner at Houston on 1. Good pressure. The side hatch is being configured now. Audible noises may be heard.
Standing by, thanks.
She enjoys hanging out with her dogs, working out, hiking and camping, as well as working on cars and houses.
What do these 2 not do, Mike?
No, they are some of NASA's finest, and were chosen to fly on this mission so that we can get Starliner certified and fly more Starliners to the space station in the future.
Mm-hmm. How does it feel, seeing your friends who you've trained alongside with so many years now? How does it feel to see them about 53 minutes to launch?
I am so proud of my friends. I've been working with Butch and Suni for, as like Butch likes to say, half a decade, 5 years or so, and we're as you can see today, and all the work as we were getting ready to launch today, how much Butch and Suni, as well as we appreciate the whole team that we're part of. Sure. And Butch and Suni have really expressed their gratitude to everyone and try to include the team as we all go forward on this mission. And so I'm super proud of them. And I'm a little envious, but I'm really happy for them to be this close to flight. 53 minutes to go.
You're not the only astronaut that says that. It's okay.
As the crew aboard Starliner prepares to launch to the space station, let's take a look at what's in store for them, for Suni and Butch, while on this mission.
The mission of the Commercial Crew Program is to provide transportation for astronauts to the International Space Station.
Multiple providers provide you redundancy. Redundancy is important, as we know. In our systems, we have redundant systems.
But actually, more importantly, it's providing the aerospace workforce the opportunity to test out new ideas, new technologies, and work them into spacecraft. Butch and I are the first 2 to fly the Starliner, so this flight will be a crew flight test, so there'll only be 2 on board. We're going to fly it up to the space station, dock it, and test it all out, and then come back home.
everything's new. The procedures are new. We have procedures now that we didn't have a year ago because we've learned as the process has gone forward.
We've had 2 test flights uncrewed previously, but this will be the first time we're putting people on it.
We're test pilots, and so we're going to be testing the spacecraft in all aspects of the flight, from launch, on orbit, all the way to entry and landing.
We're testing out the environmental control system, we're testing out the manual flying of the spacecraft. Then while we're docked to the space station, we have a bunch of tasks to make sure that the spacecraft can act as a lifeboat. And just in case anything bad goes on the International Space Station, the crew on board can come to the Starliner and make sure that they're okay.
This has a mode where we call it backup mode, which is your get home mode, if you will. We can, without any communication at all, we can still effect a return to Earth, do a deorbit burn, and hit the point where we're trying to land, even without our computers. You know, that old mantra, failure is not an option, because it's a very dynamic thing we do flying in space, and it's not very forgiving, and we know that. And that's why we have these multiple systems and multiple redundant capabilities, because human life is special, and we want to preserve it at all costs.
I think exploration is just in the human heart. Butch, he describes himself as the first thing he said as a kid was why. And I think that's in all of us. Maybe we don't verbalize it, but we all ask why. And that's what exploration is. It's that next step of why. So why not go back to the moon? Why not try to live on the moon? It seems like a natural stepping stone to the next thing, Mars, which just calls us. Like, why is that planet there? What is the future of that planet? What is the future of our planet? And to be able to take these next steps in exploration, we're going to start answering those questions.
We stand on the pinnacle. This is kind of where everything, integration, everything comes together, which is where Sunny and I sit. And this is just a part of the ongoing process of growing and expounding our knowledge and our understanding of all things for the benefit of mankind.
I am Sunny Williams, and I am ready to fly NASA's Boeing Crew Flight Test.
I'm Butch Wilmore, and I am ready to fly NASA's Boeing Crew Flight Test.
And we are ready to see them fly as well. You know, we've been inviting our viewers, you guys, to reach out to us on social media and ask us any questions you might have about this historic flight test. And one that we've been seeing a lot is, you know, why are teams still launching while there is a helium leak on the Starliner spacecraft? Mike, can you address that?
No, that's a really good question, and we spent a whole week and a half getting ready to be able to answer that to ourselves and to Butch and Sunny, saying, why is this okay, or how is this okay, or should we take the spacecraft back and replace it? Well, we looked at not just the data that we've seen, but also the what could happen in the worst case, and then what could happen even worse than that. And at every point, and because Starliner, you heard what Butch said on the overview there, was that Starliner has a lot of redundant systems. So even if we were to, if that leak were to get bigger, and it hasn't, but if it were to get bigger, it could get a lot bigger, and we'd still be okay. And even if it leaked out the entire bottle of helium for that manifold, we could still fly back and land safely in the desert in southwest United States. So NASA looked at what the risks were, and working with the crew, and the crew office said, hey, this is not ideal. We don't like this. But this is a test flight, and we were able to manage this risk and accept this risk. And it's a really tiny leak. We will be okay. And if it isn't, here's what we do. And we spent a lot of time in the simulators and writing procedures just in case. Just like we saw a little bit earlier, United Launch Alliance, they had a small anomaly. They said, all right, here's our alternate procedures. Let's run through it. And they went through it methodically. We do the same thing on board. So we have everything ready just in case.
Yeah, and just for more context, you know, as you said, this is a very small leak. Starliner could handle 4 more leaks, or this one leak growing by 100 times its current size before needing to be managed in flight. And actually, other spacecraft like Shuttle have launched with similar helium leaks in the past. Also important to note, teams continue to watch and monitor this leak to make sure that it's not growing. And as we've said, it has not grown in the time that they've first detected this leak. So again, that's why the decision is being made to fly. And that's why we continue to march towards our instantaneous launch opportunity at 12:25 and 40 seconds Eastern Time. Meanwhile, inside Mission Control at Johnson Space Center in Houston, folks there are keeping a close eye on launch, continue to do so. Here's NASA's Brandy Dean and Boeing's Jim May.
Thanks, Megan. Welcome back to the Starliner Flight Control Room in Mission Control Houston, where the flight control team is continuing to follow along with all the activities going on in Florida now that we are 46 minutes away from today's launch. Once Starliner gets off the pad, Jim and I will be with you through Ascent, giving you play-by-play and expanding on the calls that you'll hear Capcom Joshua Kutrick making to Butch Wilmore and Sunny Williams on board.
There are a number of major milestones you want to keep an eye out for during Starliner's climb to orbit. The first call that you'll hear from Starliner's crew is roll program, coming from Commander Wilmore, indicating that Starliner is rolling into the right orientation for ascent and orbit operations. Then about 45 seconds into the flight, the crew and Starliner will reach max Q, which is the maximum dynamic pressure that they will experience during ascent, and that happens just before they reach Mach 1.
Then 1 minute and 35 seconds into flight, the solid rocket boosters that give Starliner its first major push into orbit will have used up all of their fuel. Starliner will hold on to them for a little more than a minute after that and then jettison the boosters before second stage takes over and take Starliner away the rest of the way.
Starliner will actually reach orbit around 11 minutes and 58 seconds into flight, at which at that point the Centaur main engine will cut off. Starliner and its crew will hold on to that stage for a couple minutes and then separate from it at around the 14-minute, 58-second mark. From there, Butch and Sunny will be free flying on orbit in Starliner.
During Ascent, you'll hear Kutrick mentioning a number of abort-related milestones as Starliner moves past them. Starliner can safely abort all the way up to orbit, including off the east coast, off the coast of Newfoundland, and off the coast of Ireland. Beyond that, it will be able to safely reach abort to orbit, just staying in space as an abort. And of course, we're hoping not to need any of those.
Request permission to begin white room closeout.
Slick. Roger, thanks, Slick. Blue team, perform toxic vapor and O2 checks when raising the environmental seal and configure white room for launch.
Roger.
And Slick, if you get a annulus purge disconnect time.
And once Starliner has made it to orbit, the last major milestone before the crew begins what we call orbit ops is called the orbit insertion, or OI burn. That will move Starliner into an elliptical orbit as opposed to a more circular one.
Slick, we're calling it 1537 Zulu.
Roger.
Going from a circular orbit, which they get off of after separating from Atlas, into an elliptical orbit, and then from there, Starliner will be on its way to International Space Station.
Yeah, and it sounds like the teams that have been getting Butch and Sunny ready are just about done with their job and ready to move, or getting ready to move away from the white room. But before we go back to Florida, let's check in with Rob Navius and the International Space Station Flight Control Team. Rob?
Thanks, Brandy. Just inside 44 minutes until launch, and back here in the ISS Flight Control Room, flight controllers are keeping tabs on the countdown and monitoring the work on board in the aftermath of the docking of the unpiloted Progress resupply craft earlier today at 7:43 a.m. Eastern Time. Now, NASA astronauts Matt Dominic, Mike Barrett, Jeanette Epps, and Tracy Dyson, along with Station Commander Oleg Kononenko of Roscosmos and fellow cosmonauts Nikolai Chub and Alexander Grabenkin, will form the welcoming committee when Wilmore and Williams arrive on board tomorrow. The dock timeline is elastic. That means that the number of days that Starliner could stay at the station could be pared down or expanded depending on any further launch delays or undocking delays driven by weather conditions at the western U.S. landing sites for Starliner. One critical dock day for the Starliner crew.
Starliner Houston, cabin leak check complete. You can open the vent valve.
All right, great. That's in work.
One critical dock day for the Starliner crew will come 2 days prior to their scheduled undocking, when they load the last of the cargo items to be returned to Earth in the vehicle and will conduct onboard manual piloting proficiency that will enable them to stay sharp for their departure from the station and the deorbit and entry events that will follow. So here we are at the intersection of Cape Canaveral, Houston, and space. And aboard the station, two of the Expedition 71 crew members, Jeanette Epps and Tracy Dyson, recently took a moment to set the table for the arrival of Wilmore and Williams at their orbital destination.
Hey, Sonny and Butch, we can't wait for you guys to join us here on station. We'll be monitoring your every move on the journey, and we'll be waiting to open the hatch and welcome you to your home away from home.
Butch and Sonny, we know you've waited a while to get your ride aboard Starliner, but we know it will have been worth every minute. So from all of us on the International Space Station, Godspeed, and we'll see you soon.
In less than an hour to launch 2 astronauts to space during this test flight. Let's check back in with NASA's Antonio Jaramillo, who spoke earlier today with NASA's top administrator about this mission.
It's always an honor to be joined by NASA leadership, and joining me today is NASA Administrator Bill Nelson. Administrator Nelson, can you tell us why it's so important for the space agency that we have another American space company launching from American soil?
You always want to have a backup position, and in this case, a second spacecraft. For example, when we go to the moon, we will have 2 landers. We will have a SpaceX lander, that's first, and then the Blue Origin lander. But this is a significant launch of a test of a brand new human-rated spacecraft. And it's only 6 in the history of NASA. There was Mercury, Gemini, Apollo, then the Space Shuttle, then Dragon, and now the Boeing Starliner launching for the first time with humans on board.
That's right. It's very historic, very important. And you touched on this. Why is it important in general that we do have multiple spacecraft available to send humans to space? Because
we want to explore. We are exploring in many different ways with humans as our astronauts. We go back to the moon, not just to go to the moon, but to get ready, to learn, to live, to create in order to go to Mars. But that's just one part of our space program. The science, research, the exploration of the heavens, the commercial program. We're going back to the moon later this year with a commercial lander with a NASA instrument that's going to dig to see if there is water on the South Pole. It's a whole combination of a bunch of things that are going on.
That's right. You briefly touched on that. I mean, there's already been a ton of exciting missions this year. What else can the public look forward to?
Well, in addition to those, remember the first A in NASA is aeronautics. And we're going to fly the needle-nose new supersonic. It goes faster than the speed of sound, and it's designed so that it will not make the sonic boom, so that it could fly faster than the speed of sound over populated areas. That's one. We got another aviation project to improve the fuel efficiency by 30% of a mid-range single-aisle transport aircraft like the Boeing 737.
That is fascinating. Administrator Nelson, thank you so much for joining us here today. We'll send it back over to you.
We interviewed the administrator earlier because he is currently at the ASOC with the launch team as we watch the crew access arm moving away from the Starliner spacecraft. Now, the plan is for Butch and Sonny to be docked to the ISS for at least 8 days, and after they will return to Earth with a soft touchdown in the American Southwest. There, this is video and sound from inside Starliner during its return to Earth 2 years ago as part of the Orbital Flight Test 2 mission. Its heat shield reaches 3,000 degrees Fahrenheit during re-entry, and parachutes are then deployed, and the heat shield discarded to expose Starliner's airbags. The original test pilot, Rosie the Rocketeer, you see there, collected data of what astronauts might experience during landing. Starliner is the first and only American orbital crew capsule to land on land. This allows for quicker access to crew and cargo. It also makes turning the spacecraft around for future missions quicker. But, Mike, Starliner can also land in water, like we were talking about earlier.
Yes, Starliner is a very capable spacecraft. Of course, we want it to land on land for the reasons you said. I love those airbags. I can't wait to ask Butch and Sunny how good those are. But in case of emergency, we can land on water. And we have a central airbag, another one.
28 seconds, excess burn duration, and we'll go north to triage 6 if necessary.
The crew was just calling in. They just got some data.
And those are all good work, Starliner. Good readback. One additional item for you. In the commander's folio, you'll recall you have your 2 tablets. You've got a serial number 12 and a serial number 13. They're both ready to go, but one thing for you. Serial number 12, we were looking at footage here. Its time is out of sync. So it's no issue for you till orbit. When you're on orbit, you'll want to get that tablet, serial number 12, back in sync with the time on your DUs. It's only going to influence where you see the red line and bold. So if you did have to use bold before that, go ahead and do it on 13. Otherwise, we'll just resync in flight, and we can help you with that when we get there.
All right, good words. We'll copy that, and if we have any questions when we get there, we'll give you a call. And I have confirmed that I can reach the tablets.
Houston copies.
That was Josh Kutrick giving some last-minute info to Butch and Sunny about their tablets, as well as in case of emergency where to go left or right at the end of the slide wires. But yeah, Starliner could land on water. We'd rather not, but it has that capability, and it has a different airbag configuration for that.
Yeah, the flexibility is great.
We have just about a half hour left before launch. Let's check back in with NASA's Antonia Jaramillo, who's now with someone who's been a part of Starliner since the beginning. Tony?
Thank you, Dee. For those of us just joining, we are here at OSB-2, one of the viewing locations for this launch. And joining me is Chris Ferguson, former NASA astronaut and Boeing astronaut. Chris, you've been part of Starliner since the beginning. How does it feel to be here and now get to watch it take flight with astronauts on board?
Well, given it's such a darn gorgeous day, I'm really excited. Of course, this is the culmination of probably 12 years of, just watching and working and getting involved with the development. But I was very excited to see it all come together. It's a little breezy out here, but you can't beat the weather.
Absolutely. It is a gorgeous day. Now, Chris, if you could give a piece of advice to Butch and Sunny and to all our astronauts flying on our commercial crew missions, what would it be?
Well, Butch and Sunny are pretty darn experienced. They probably don't need my advice, but what I would say, on a very first ascent of a vehicle and a re-entry, I would say take it all in, experience it. Think about what you're feeling, what you're experiencing, what's staging going to be like, what's it like when the parachutes come out, because these are questions that everyone's going to know when you get back, right? We want to know, did we build a vehicle that's comfortable to fly?
Absolutely. We can't wait to know. I mean, we're all taking it in here too. Chris, it's our understanding that your fingerprints are all over the spacecraft, in particular the launch console and displays. What can Butch and Sunny expect to see and experience aboard Starliner for their flight, and how does that compare to flying the space shuttle?
Yeah, I think the idea behind the design is to make sure that the crew always has reasonable awareness of what's going on. I remember with the space shuttle days, sometimes the displays were a little archaic. You had to really almost have a graduate degree to understand exactly what you were looking at. So the idea is to make it a lot more airplane-like, because the crews are very experienced pilots and aviators, and for the next generation of Starliner astronauts to come along, we want to make it very intuitive. So we've reduced the number of switches to the bare minimum. The shuttle had 1,000. We have 25 maybe. I don't know what the right number is, but it's a very streamlined. It's capable of being flown by a single person. So there's a lot of, I would say, upgrades that make it safer and a lot more flexible than its predecessor, the Space Shuttle.
Definitely a very impressive spacecraft. And Butch and Sunny, they're going to also perform a few manual demonstrations aboard. You also were a part of this flight test in the beginning. Can you talk to us a little bit about these manual demonstrations and just kind of the importance of why Boeing decided to have both a blend of autonomous and manual capabilities?
Yeah, there's always a sort of a a contentious look, between engineers and pilots on how do I control the spacecraft. The pilots always want the ultimate ability to take over in a situation when they need to. So the Starliner flies very much like the Space Shuttle and the Apollo and the other capsule vehicles, with 2 different hand controllers where you can control all 6 degrees of freedom. You can maneuver it to an attitude if you needed to, say, charge your solar arrays or pick up a communication satellite, and they'll have the opportunity, of course, to check that out. And then there's also a deeper level of redundancy called backup mode, which is a means that the crew could manually fly the vehicle, even in the unlikely event that all the flight management computers fail. So there's a lot of redundancy, and it really is a true piloting vehicle, which is, I think, why the NASA customers really enjoy it so much.
I'm sure. Well, Chris, thank you so much for joining us. Megan D. Mike, back over to you.
All right, a quick check of the clock. We are 31 minutes and 40 seconds to liftoff of NASA's Boeing crew flight test. And right now, what you just saw on the screen there, you see Butch and Sunny. They are patiently waiting their launch inside of Starliner's spacecraft there. And then also, we did see the pad team who've been helping Butch and Sunny into their spacecraft, as well as securing the spacecraft and closing the doors. They have since left the pad, right, Mike?
Absolutely. So only thing that's left is we have a rocket and a spacecraft and 2 human beings sitting on top getting ready for launch in 31 minutes.
Yeah, and so what we expect to hear coming up is just repeated communication checks with Capcom in Houston and with the crew. And also, this is an opportunity, right, to discuss any anomalies or resolutions, but we haven't heard anything.
Yes, I think we hopefully got that out of our system earlier, and here we go.
Go ahead.
Yes, sir. Per step 20, operation 60, blast engine area is clear.
Roger.
They just confirmed that that it is just indeed the rocket, spacecraft, and 2 human beings.
And so, yeah, so we'll hear those continued checks, and this is just an opportunity for some status updates if needed, right? This is kind of time that's built in to allow for discussion if needed.
Absolutely. We're waiting for the Earth to rotate in just the right position for that instantaneous launch window. And any anomalies we had, we got out of the way. And now everybody is
30 minutes.
Double checking their data.
RC, conduct weather briefing on Channel 8 weather conference.
And the weather.
Right.
Roger. Arm control, start arm hydraulic final prep.
Roger.
LOX 1, perform pogo suppressor charge.
Roger.
Prop 1, perform RD-180 transducer converter calibration.
Roger.
P&E 2, perform Centaur LH2 SVV cycle test.
Roger.
These are nominal countdown checks for the from the launch conductor, Doug Lebo, asking his team to do their 30-minute steps to get the rocket that much closer to ready for launch.
A historic flight test, as we've been telling you throughout this broadcast. We've been on air now since 8:15 a.m. Eastern Time to tell you about the first 2 astronauts that are going to fly in Starliner. And again, we keep seeing live views of them inside Starliner. Commander Butch Wilmore and pilot Sunny Williams.
Transducer calibration is complete, and the engine FIV is in a closed condition.
Roger.
L-minus 29 minutes.
Flight control, start flight control final prep.
Roger.
Now, Sunny will be the first woman to test an orbital spacecraft. Another fun fact, the last time people flew to space in an Atlas-class rocket was 61 years ago with the end of the Mercury program. CFT is the final test to certify a second commercial spacecraft to ferry astronauts to and from the space station, which really is a wonderful resource to us and many countries and also research institutions. All right, again, 28 minutes, 5 seconds to liftoff. Let's head back over to Brandy and Jim inside Mission Control in Houston.
LC, P&E 2.
Go ahead.
Centaur LH2 SVV cycle tests are complete.
Flight test
Roger.
Flight Director Mike Lammers is just about to poll the flight control team here in Houston for a go or no-go, verifying that all of Starliner systems are ready for launch today. Everything's looking good at the moment, and Lammers will use this poll to determine his own response to the final go, no-go poll by the launch conductor just before liftoff.
Once we do get into the
And flight
terminal
control.
countdown time frame,
LC.
there are
Go ahead.
Roger, do we have the temperature update complete?
Roger, the RP1 temperature update complete.
Roger. Prop 1, initiate fuel fill sequence.
Roger.
And once we're in that terminal countdown time frame,
Go ahead.
A few
Yeah,
major.
we've been discussing before the CISA temp. It's a noisy measurement. I'd like to take this to 6, get a recommendation probably to disable.
Roger. Convene the anomaly team and provide a recommendation.
We'll go.
L minus 27 minutes.
And the first
LC arm control.
one of the major activities that
Go ahead.
Step 100. Arm hydraulic final preps are complete.
Roger.
One of the first activities Mike Lammer's team will be doing is transitioning Starliner from ground power to battery power. That'll come about 18 minutes before launch. We leave it about as late as possible so that the team can launch with those batteries as close to full power as possible. A few minutes later, with less than 10 minutes to go before liftoff, Starliner's ordnance will be armed, and that activates the critical systems that are needed to detach all the things from Starliner that will ultimately jettison as it climbs to orbit, and if it were needed to abort. And finally, just 1 minute and 15 seconds before launch, they'll work with the crew to activate the launch abort system, which would rocket the crew to safety in the case of an abort, or on the pad, or early in the ascent.
This is likely the last you'll hear from us until liftoff, so we are going to send you back to the team in Florida to let Megan, Dee, and Mike see us through the rest of the countdown. We'll be back once Starliner is on its way. Go Starliner.
Randy and Jim. Okay, let's take a closer look now at Starliner. The next generation crew capsule measures 16.5 feet tall with a diameter of 15 feet. That's about the size of a mid-size SUV. It was designed to carry up to 7 astronauts or a mix of crew and cargo for missions to the International Space Station. After today's test flight, NASA will fly crews of 4 or 5 with cargo. And Starliner is also reusable up to 10 times.
Yeah, we're looking
LCOSM.
to getting...
Go ahead.
Yes, sir. Per step 60, flight hazard area has been cleared. All personnel accounted for.
Roger.
All right, everybody is in place for launch. Starliner, we're looking forward to getting it certified so we can continue our missions to the International Space Station with 4 NASA astronauts. And Boeing will have the option to use Starliner to fly to other space stations and to help build the low Earth economy, low Earth orbit economy.
Hey, Mike, let's squeeze in a social question since we've invited viewers to send them to us. This is from John on YouTube asking, how did the astronaut train for this mission? It's actually a question from a 10-year-old named Maddie.
Well, hi, Maddie. Hi, John. Yeah, so we spend a lot of time practicing exactly what's going on today. We sit inside a simulator, which looks and feels like a rocket, and we push all the buttons and switches and look at our data. And sometimes they even give us these things called malfunctions, which something goes wrong, and we have to think our way through it and follow our procedures to have a safe practice mission. And we do that for about 1.5 years. In this case, for us, it's a new spacecraft, so it took us 5 years, but it takes us about 1.5 years to train for new spacecraft.
Roger. Please disable line item 390.
Active.
Again, some nominal call-outs there as we march towards our instantaneous launch opportunity at 12:25 and 40 seconds.
It's really neat that we're hearing all the voice chatter back and forth from our team. I mean, what a nice thing to be able to share with everybody watching today.
Flight control final preps complete and Atlas hydraulics at standby pressure.
Roger.